blockchain of Merkle and Merkle trees for enhanced blockchain security. Hi, everyone. Today we're presenting a new work from our cryptographic team that is proposing a new type of tree construction that is going to significantly reduce the overhead of hashing and solve the state storage problem in blockchains. So to start, blockchains are introducing a fundamental shift in storage of data where they bring security and transparency and decentralization using cryptographic methods to maintain distributed ledger. However, in such scalability is the biggest problem because it requires to maintain the ledger on many instances and process large volumes of transactions, leading to bottlenecks and increased costs. Overcoming such scalability is essential for blockchain continued growth, and it's necessary to come up with a new model and architectures to sustain growth. Here we can see that the growth of total unique Ethereum addresses over a one-year period is quite significant. And if we're looking at the frequency of use, we can notice that the number of frequently daily used addresses is quite narrow, representing only 17% of unique addresses that are actively engaged with the network daily, pointing to a high concentration of pattern activity. This concentration challenges for optimizing the blockchain state management, emphasizing the need for efficient data verification and management strategies to accommodate the network scaling complexities. Our contribution is we're proposing a new dynamic restructuring algorithm for Merkle trees that enhances scalability and efficiency of blockchain systems by optimizing verification and storage processing. And we also extend the applicability of these optimized tree structures beyond traditional blockchains, demonstrating their versatility that goes beyond blockchain. To conceptualize the problem, what we have is in regular blockchain designs, Merkle trees act as a balanced tree. And here you can see that for any frequency of use of the address, for any leaf node, the search complexity is averaged out. The problem with this is that even for high frequently used leaf node, the search complexity is on average the same as for the low frequency used node, which leads to an average out significantly higher computational cost for accessing the data. So the inefficiency really comes from their verification strategy while maintaining the data integrity. And what we are proposing is the adaptive tree that uses the frequency distribution of use and narrows the search complexity for it, thus enhancing the efficiency and scalability of the blockchains. Our adaptive Merkle tree, inspired by Huffman encoding, prioritizes data based on the usage frequency, placing frequently accessed nodes closer to the root to streamline verification process. By aligning nodes placement with usage probability, the adaptive structure significantly reduces the path and computational complexity for verifying high-frequency data, enhancing efficiency and reducing verification time. Their verification path for high-usage nodes, such as node A, like here we can see it, designed is considerably shorter in the adaptive tree compared to the balanced structure, demonstrating a direct correlation between data access frequency and computational resource allocation. So here we can see that for a node A, which is high frequency use, we can restructure it to be positioned higher to the top of the tree, thus reducing the hashing amount of hashing that is required to access the node. The efficiency of adaptive Merkle trees in comparison to the balanced trees, what we see is the average path length is determined in balanced trees is determined by log m of n, where m represents the maximum allowable number of child nodes per node, or the arity of the tree, and n is count of unique symbols within the alphabet. For the adaptive tree, what we indicate that the average path length mirrors the average length of the Huffman encoding, calculated as the weighted sum of all code length with the probabilities of the corresponding symbol serving as weights. And here we see a sigma over pi times li, where pi is the probability of the ith symbol and li is the length of the code for the ith symbol. Now, the efficiency of the adaptive tree is theoretically average length of the Huffman code given a specific probability distribution can be derived from the entropy formula. Transforming these assessments into a comparison of the complexity of data integrity verification in both the classical balanced and the proposed adaptive tree yields for balanced binary tree, the average Merkle path complexity is k equals to 4, whereas for adaptive tree, the average path length is roughly equals to 3.5, which indicates an efficiency gain of approximately 13%, which is an average theoretical efficiency. The gain reflects the reduced average number of hashes required to verify the integrity of the leaf data. And here we're going to show the experimental evidence that actually this reconstruction yields even far bigger efficiencies.
Yeah, thank you. I'll continue. So our efficiency of adaptive Merkle tree with the Ethereum experiment on Merkle Patricia trie. So we have evaluated the efficiency of our approach on 100K blocks consecutive of Ethereum blockchain. So for the evaluation, we use simplified model of blockchain where transactions only changes to and from addresses and only mentioned in transaction slot exists. So we have like the block range of 100K. We have around 31.5 million of transactions. We have 3.9 active addresses, and the addresses that capture 50% of total activity were around 4K from 3.9 million. Addresses that captured 90% of total activity was 1.6 million. So the percentage of total activity captured by the 50% of the addresses is 92% of all activity that was happened on chain. P-next transaction will introduce new addresses is 9%. So you can see the efficiency. So we expected the average depth of accessed element was calculated using the formulas from the previous slide and sample probability distribution. So you can see the number of blocks and logarithmic of number of blocks. The results, as we use depth of assessed element in tree as estimation of number of hashes needed to calculate the tree cap. In our experiment, we calculated theoretical improvement of 27% on 100K blocks. As probability of transaction of new address with the new transactions is much higher than in real Ethereum blockchain, we conclude that the result will continue to improve with additional blocks, and we project that theoretical improvement for the full Ethereum blockchain could be around 42%. So in our small-scale implementation experiments, real improvements was within the 5% of theoretical limit, and we expect it to be even closer for full-scale implementation. So the next part is the algorithm for Merkle tree reconstruction, as adaptive tree requires the reconstruction in Merkle tree in order to put the more frequently used nodes higher in the tree and put more rarely used nodes lower. The reconstruction of Merkle tree aimed to optimize this efficiency of blockchain applications. So the two criteria we have is minimization of average path length. The deviation between key and age is assessed through the average disparity. So with each element disparity defined as the next formula. So and the second point is that minimization of altered paths. The algorithm should limit modifications to a minimal subset of nodes, reflecting the reality that only a few accounts are activated in any given transaction, including complex smart transactions, like contract addresses and execution of subcontracts. This approach ensures that inactive accounts retain their positions and paths within the tree, preserving the integrity of user data and access pathways. So the input is a tree or a tree fragment with the root, intermediate nodes and leaves. The probability distribution frequencies of these three leaves is a set of leaves available for reconstruction. A new leaf or a new probability distribution for all three leaves. So the output will be a restructured tree or a fragment of restructured tree optimized according to the criteria of minimizing the average disparity. So we have the next steps of the algorithm. Utilize the set of leaves available for reconstruction, formulate all possible reconstruction alternatives for the tree. Evaluate the average disparity for each alternative, select the alternative with the lowest average disparity, and adopt selected alternative as the algorithm output. So the most challenging aspect of this algorithm is step 1, which involves generating all possible reconstruction passes. So you can see here on these examples that, like with adding a new leaf, we need to reconstruct all other probabilities, like disparity for all other leaves, and put a new leaf in one of the position. So, like this iteration is shown on this table with first alternative and the second alternative for the same tree with different disparity. So the same examples is going further when we have a second iteration. We have like in next iterations, and then we have like this more third iteration, fourth, and this is like 5 to 10 iterations. All of them are showing the examples on binary tree, but we also have the examples on the fourth Merkle tree and the Merkle Patricia tree. So this is, yeah. And this is the examples of reconstructing Merkle Patricia tree with the new leaves adding and the leaf pair swapping. I think I'll transfer the word to Alex back for the path encoding in adaptive Merkle tree.
So to talk about path encoding in adaptive trees is integrating adaptive trees into the Ethereum's framework. It necessitates the departure from understanding that we can use balanced Merkle Patricia tree as the data structure, proposing that in our proposal is the unbalanced tree that aligns leaves based on the frequency of usage, challenging the traditional path encoding method. The new method would alter the deterministic path encoding of addresses, necessitating a novel mechanism that accounts for the dynamic positioning of leaves without disrupting the existing address system. This means that in order to adopt for balanced Patricia tree structure to adopt this adaptive structure, what we have to do is we have to attach a new dual structure that would effectively not disrupt the existing addresses which are stored in the balance tree, but would have a subsequent new structure added to it that would have a dynamic address system. The dual structure system mapping account addresses to their adaptive path encodings emerges as a practical solution to maintain compatibility, ensuring seamless integration and operational continuity within the blockchain network. This innovative integration promises to significantly reduce verification complexity and costs by adapting to usage pattern, potentially revolutionizing the way blockchain systems manage data integrity and address verification. Here we can see effectively in a more detailed way what is the leaf probability distribution and what is the path encoding for balance tree, which is average code length is 4, and for the adaptive tree is 3.49, which is effectively 13% more efficient. As Ethereum is moving into a more compressed tree with a vertical tree construction, we believe that the adaptive tree structure will yield even more savings, as the cost of moving from layer to layer in the vertical tree is even more expensive. The advent of the vertical trees marks a transformative advancement in blockchain storage and verification, melding the succinctness of vector commitments with the hierarchical integrity of Merkle trees and address scalability and efficiency challenges. By implementing an adaptive restructuring approach, we can significantly augment the efficiency and scalability of vertical trees, tailoring their configuration dynamically in response to usage patterns within blockchain systems. Our strategy involves the dynamic adjustment of vertical trees, utilizing statistical analysis to optimize data organization based on access and update frequencies, thus streamlining verification process. By incorporating Huffman coding principles allows for strategic placement of frequently accessed elements closer to the root, effectively minimizing path length for verification and enhancing overall system performance. Reduce proof size by optimizing the structure of vertical trees to reflect access pattern. We can significantly reduce the size of proofs required to verifying transactions. This is because frequently accessed data can be positioned closer to the root, making it quicker and less resource intensive to generate and verify proofs. Meaning in the vertical trees, as you build the tree and it gets deeper, the size of the proofs increases. So and the cost of this proof increases with it. Enhanced adaptive restructuring can also lead to a more efficient verification process. Shorter paths for frequently accessed data mean that less computational effort is required to verify transactions, enhancing the overall throughput of the blockchains. Dynamic scalability of blockchain system can evolve so the storage and access pattern of adaptive restructuring allows vertical trees to dynamically adjust to these changes, ensuring that the data structure remains optimized to current usage trends. And by optimizing the path length for data access and verification, this approach can reduce the costs associated with these operations. In blockchain systems where transaction costs are significant concerns, such as Ethereum, this can lead to substantial savings for users and applications. Through rigorous analysis and examples, we demonstrated the efficiency that can be achieved using adaptive Merkle trees. Our algorithm for Merkle tree restructuring, detailed in section number 5, provides a systematic approach for dynamically adjusting tree structures, significantly improving upon the static nature of traditional Merkle trees. By extending our concept to vertical trees, we show that how adaptive restructuring can be also applied to the most novel tree structures. And in conclusion, we can say that we provide a conceptual framework for adapting existing Merkle tree constructions to current blockchain infrastructures and demonstrate through examples the practicality and benefits of this approach, notably in the optimizing verification process and cost reduction. Comparing to analysis underscores that adaptive restructuring offers foundational improvement in scalability and efficiency without adding complexity or securing vulnerabilities, distinguishing it from other scalability solutions. And in conclusion, the adaptive restructuring of Merkle and Verkle trees marks a significant advancement toward resolving the blockchain scalability challenges, both on the state storage and search complexity and computational complexity for storing and accessing the data, offering a blend of efficiency, security, and practicality, which is crucial for evolving blockchain ecosystems. Thank you.
Thank you so much.
I'll just use this. Hey everyone, welcome to the Trident stage, ETH Denver 2024. I'd like to welcome to the stage Elie Ben-Sasson. He's the co-founder and CEO of Starkware. The talk is titled Fry versus KZG, Does Field Size Matter?
Thank you. So I'll talk about this topic. And the TLDR is that already today Starks dominate the Ethereum scaling scene. And thanks to recent breakthroughs like Circle Starks and Stu, which we just open sourced yesterday, Starks are going to become the new gold standard for scaling Ethereum. So yesterday we released the next phase in scaling in validity proof technology. It is Stu based on the Mersenne 31-bit field with an improved Cairo virtual machine based on the mathematical breakthrough of Circle Stark that was published just last week, joint work by Polygon Zero and Starkware. I'm going to use GKR lookup and mixed degree trace and a lot of other bells and whistles, making it yet again a pretty darn good prover. And if you think about the landscape today in terms of proving technology, there are roughly, for things deployed in production, not just for things that are out there in academic research, so there are roughly three categories of commitment schemes. Fry-based, which most of the Stark systems lie in, inner product arguments like bulletproofs, and then you have KZGs used by things like Plonk, Roth16, and a bunch of teams. And over time, I mean, it used to be that KZG dominated almost everything in the ZK and scalability space, but over time, Fry-based systems have been emerging. And again, basically my point is, I think you'll see this trend of moving more towards Fry-based Starks as time goes on. And why is this so? So you could consider the efficiency of one of the main bottlenecks in constructing a proof, which is to do a polynomial commitment scheme. And we can do a head-to-head kind of competition, measuring the number of clock cycles to commit to a word being 32 bits, inside of stream of length roughly 1 mega word. So 2 to the 20 words, that's roughly 1 million words. And now we can measure the load in the commitment scheme per each word. And let's compare Fry and KZG. So this is based on some comparisons that I already presented in the past, both at Stark at Home and at the Stanford Blockchain Conference this past summer. So the current status is that if you look at non-vectorized instruction sets, so KZG, under the even most ideal algorithms that we know of today, you're going to have to do roughly a cost of word length, so that's 32 divided by the logarithm of the stream. In our case, it's 20, so 32 divided by 20. Number of group operations. Each group operations at best, and you have to do a lot of fancy work to make that work, you need to do 6 modular multiplications for doing elliptic curve operation. And each one of those roughly costs 38 to 40 clock cycles. On the other hand, if you look at something like 31-bit Fry, you'll see that you pay for the FFT roughly 1/2 of the blow-up factor times logarithm times 20. In our case, the blow-up factor is going to be 2. So 1/2 times 2 times 20 equals 10. And that's the number of clock cycles per word, plus blow-up factor times hash. So if you use something like Blake, that's going to be 80 clock cycles. You see the most dominating factor here is going to be the hashes, and you have to pay 2 of them. So out of the 220 cycles, 160 belong to the hashing. However, if you move to vectorized instruction sets, which are today common in all CPUs, then the picture changes pretty drastically because KZG probably doesn't vectorize all that well, whereas something like a 31-bit field Fry with an FFT does vectorize extremely well, and then you get that each modular multiplication on the small field is 1/3 of a clock cycle amortized. So you get a total of 31 clock cycles versus something that is probably going to be around 10 times greater than that. So you have like 10 times greater efficiency, but the story doesn't end there. In practice, when everything is combined, if you look at the Fry-based system, to best of my knowledge, this is along some of the world records, even though it's like 4 years old. So we already showed 4 years ago a construction over a 64-bit field that proves 100,000 rescue hashes in less than 10 seconds on a quad core with 16 gigabytes RAM. And this was at the time 20 times faster than the fastest known KZG-based system, SNARK. And we still don't know what is the best proving time for something similar. You know, it would be a good measurement to do head by head. Take your favorite algebraic hashing function and see how long does it take to prove 100,000 iterations of a hash on some simple hardware. It's probably not going to be all that simple. Anyways, but Fry-based systems, or Starks, have a bunch of other advantages over SNARKs. They have fastest commitment time. They're agile in the sense that they work over all finite fields from binary all the way to large prime fields. They're safest because they have no trusted setup, meaning they're transparent proof systems. Their security assumptions really revolve only around the existence of some secure hash function, and in particular, they're also post-quantum secure. KZG does have advantages, SNARKs. They have very short proof length, under 200 bytes, and they have additive properties, which, well, it's a double-edged sword. You can use them for doing things like folding and compressing things, but they also, this additivity is related to things like post-quantum insecurity. So now, this theory that says that Fry-based systems over small fields are going to be better is not just something that we believe in on the mathematical or back of the envelope side. We're also committing ourselves to it. So for the past 6 years, we've been using basically one prover that is Stone, which stands for Stark 1. It is our first Stark-based proving system, and now we're moving slowly towards Stu, which is the second Stark prover. And I want to tell you a little bit about this because it's pretty exciting. So what it's going to give you is much faster proving technology. It's going to reduce the total computation cost, meaning you pay less dollars for proving stuff. And it's going to be seamlessly integrated with StarkNet, which means if you start deploying and building in Cairo on StarkNet tomorrow, you will get all of these benefits without really any modification. So let's look a little bit under the hood. What is Stu? So first of all, let's talk about the 31-bit Mersenne prime field. So a Mersenne prime has the form 2 to the k minus 1. And if you take k to be 31, you get the number 2 to the 31 minus 1. It is a prime number. And it has a lot of cool properties to it. I mean, Mersenne, the great Mersenne, already found it probably a couple of 100 years ago. And it gives you, so moving to 32-bit fields in our world where all computer devices, off the shelf operate in 32-bit instructions in the fastest way, means that you get a lot of benefits. One, the smaller field size allows you to get your arithmetization better done because when you have large fields, you need to pack things into big field elements and it's inconvenient. It fits inside a computer instruction word. And you even have nice modular reductions because 2 to the 31, which in bitwise representation is just 1 with a bunch of zeros, happens to equal 1. So if you have, if you do have the 2 to the, if you have your 32nd bit turned on, you can sort of replace that with the lowest bit turned on, and that's how you do modulus. So it's a very simple modular instruction. And there are a lot of nice benefits for doing fast implementations both on CPUs and GPUs for basic field operations such as modular addition and multiplication, for doing FFTs or NTTs, and for computing things like Stark-friendly hashes like Poseidon. One example is if you take two 32-bit numbers and you just concatenate them together, two 31-bit numbers, what you're looking at is literally equivalent to their sum modulo this prime. So you can, concatenation, at least of two such field members, does represent the addition of them. And you can do a lot of such tricks. So let me tell you a little bit about this exciting breakthrough, joint work by Polygon and Starkware. Ulrich Habok from Polygon, David Levitt and Shachar Papini from our team at Starkware. Really spectacular result. So circles start, and the circle refers to the good old circle that we all know and love. So let's see how we get there. For Starks to work best, they require a group that is of size 2 to the k. We often talk about an FFT-friendly domain. And it turns out that the multiplicative group, usually we take fields and work with their multiplicative groups and find subgroups inside those multiplicative groups. But for that, you have to look at the factorization of the prime minus 1. In our case, that would be 2 to the 31 minus 2. And 2 to the 31 minus 2 does not have very large factors of 2. And in fact, 2 is the largest power 2 that divides it, which means you don't have the nice multiplicative groups that you would like. Now, if you go to the degree 2 extension of Mersenne, you already have a very nice FFT-friendly group of size 2 to the 31. However, now you'll be needing to work with basically 62-bit field elements and doing all your operations. So, and that's a bit inconvenient. We would like to get all the benefits of the Mersenne arithmetic, but working only over the Mersenne field. So one possible solution is to use some work that we did a few years ago at Starkware called elliptic curve Starks, which basically replaces the group, the multiplicative group of a finite field with an elliptic curve group defined over that finite field. The nice thing that is that there's an abundance of elliptic groups of all sorts and, well, not of all sizes, but there's a pretty large variety of them within the Hasse-Weyl bound. So you can find one that has a nice subgroup of size 2 to the k, which is what you want. However, this would be relatively complicated. Elliptic curves are a little bit more complex than some simpler curves that we all know and love. So enter the circle curve or circle Starks. They operate over the genus 0 curve that is the circle defined over M31. So what does it look like? You take the good old circle, which is the set of pairs of points such that x squared plus y squared equals 1, in our case modulo the Mersenne prime. And there's a bunch of examples of such points on the group on the circle. So 1 0, minus 1 0, which in our case equals 2 to the 31 minus 2. And also if you take the point that is 2 to the 15, 2 to the 15, that thing, if you square each one and sum them up, you get 1 modulo the Mersenne prime. So here are a few numbers, a few points on this group, and it turns out that there are exactly, well, there are 2 to the 31 groups that reside inside the, that are defined over the Mersenne field, meaning that the pairs x and y, both of them belong to the Mersenne field, and it forms a group. I think actually the group is of half the size, but I'm confusing myself now. So it's at least of size 2 to the 30, and you have a very nice operation for addition. So that's the Mersenne 31 field. There's going to be a talk by Shachar Samocha, either later today or tomorrow, and by Ulrich Habok, I think it's going to be tomorrow at the Stark meetup, sharing a lot more details about the math behind it and about looking deeper into Stu, which is already open sourced by now. So what are the implications? This gives you the very fastest prover using new math, and it's going to be crazy efficient. We believe it's going to be something like 100 times more efficient end-to-end than the current stone proof, and the current stone prover is among the fastest proving systems end-to-end for production systems today. So we are extremely excited about the potential of Stu to go even further in scaling Ethereum. For Starknet, what you need to know is that if you write in Cairo, you'll get all of this goodness for free because it will just be adapted seamlessly. This will lead to lower fees and to quicker finality. Hopefully, we'll start seeing it already helping us with finality and reducing latency this year in 2024. And another nice thing is that it is open source, written in Rust, and the open source is already open today. So you can just Google for Stu under Starkware, and you'll find it under Starkware libs, and you can start hacking or using it. So I'll repeat the TLDR. Starks dominate the Ethereum scaling scene already today, with more and more teams moving over to using Fry-based systems that are safer but also more efficient. And the recent breakthroughs of Circle Stark and Stu will become the new gold standard for scaling Ethereum. Not just at Starknet, probably also Polygon Zero, and other teams are going to adapt to them, and then we'll see a lot more in the industry. So this is as good a time as ever. It's the second best time to start looking into Starknet in Cairo. The first best time was probably, a year ago, but still we're early enough in the game. So you can take this QR code, follow the links, join the ecosystem. Thank you very much.
Check, check.
Hello, everyone. GM would like to welcome to the stage Vivian Fung, founder of Snowball Tools, and her talk today is called Crypto Mobile and Mass Adoption.
Okay, so I just want to preference my voice completely shot, and so bear with me while I go through this. Okay. Okay, our industry. Okay. All right, 1, 2, 3. Every phase of development has raised new challenges for programmers, and each time these challenges were met with streamlined tools that lowered barriers to entries, eased processes, and paved the way for innovation, leading to significant breakthroughs. However, the tools needed to ease the burden of development in crypto on mobile have yet to be created. This is happening, this is hampering a wave of innovation, creation, and adoption. We are building Snowball to address these issues head on and help usher in a new generation of engineering. Before we get into what we're building, I want to take a step back and talk through a few stories about the recent past. Early web development for desktop was a mess. For instance, each company had to run their own web servers. Deploying and hosting a website took a lot of steps. And if you messed up at any point, your site could go down. You may have blown up your whole production database. So many errors could have occurred without even considering the actual code. Next came cloud services, providers like AWS and Google Cloud, which enabled firms to move away from independently owning their hardware or rack space. You could spin up as many virtual machines as you'd like. These outsourced services provided necessary resources without the upfront costs, radically accelerating the pace of development. Barriers to entries were lowered. This opened the door for many more developers to write, maintain, and continuously deploy apps more easily. While helpful, tools like AWS and Google Cloud were still difficult and tedious, which led to new offerings like Heroku and Vercel. These services provided beautiful UX, simplified launching UI, and web applications through a single platform, saving enormous amount of time and further accelerating development. Today, it's pretty incredible. A website takes as little as 10 minutes to deploy. All right, so when we look at recent history of mobile app development, we see a similar story. 10 years ago, it was a highly manual process. Just getting on the App Store was painful and complex, given the requirements about screen sizes, properly sized screenshots, build validation, and necessary certificates. Again, this is draining a huge amount of time, resources, and creating a barrier to entry for new builders. Fastlane changed the game. Suddenly, these crazy screenshots and certificate requirements could be automated, and a more seamless process was born. Still, it was time-consuming, and there was much to improve. Being CI-based, Fastlane lacked intuitive UI, struggled with the documentation, so there was a high level of knowledge and time required to build and deploy using Fastlane. After a series of acquisitions, Fastlane hasn't evolved much in the past few years, which leads us to where we are today. Streamlining mobile development for crypto. Let's say you want to do XYZ in Web 2. For example, you want to build a blog, you want to build a storefront. On Vercel, you can do that in 10 minutes or less using a template app. In crypto, you want to do a simple dApp. It takes way, way longer to do anything of that sort. As I previously mentioned, tools like Heroku and Vercel allow developers to deploy a website in as little as 10 minutes. Their templates in many language and frameworks enable developers to automate, build, and deploy through something as simple as a commit. But this is all still complicated and time-consuming when it comes to building for mobile. Building out UI, user authentication, databases, API, remote notifications, Apple Pay, and submitting the app to the App Store review takes forever. Streamlining web development infrastructure like Vercel lets just about any dev launch an app through a unified platform, but this still doesn't exist for mobile applications. There's no wonder why more engineers focus on web rather than mobile. Few companies are thinking about the mobile developer experience. It seems like only enterprise-based engineers with years of experience building and deploying mobile can actually play in the space. Crypto makes application development even more complicated by requiring authentication, authorization, smart contract deployment, indexing chain data, and so much more. The level of technical expertise remains extremely high. Stitching together each piece is a nightmare. Development requires navigating a series of companies, systems, and possibly the different infra for each chain needing to be mended together. It goes without saying, this labor is intensive. Building for mobile is even more, a higher hurdle, leading most crypto apps to be built for web. At Snowball, we believe that the future of crypto is mobile. Hard as that may sound, most people in developing countries do not have a desktop computer. And yet crypto, especially, developers are not building for the audience with the most to gain from crypto adoption. For crypto to fulfill its promise of changing the world, it needs to scale on mobile. That's why we built Snowball, because it empowers devs with better tools, especially for mobile. We can open up crypto for the rest. We can open up crypto for the rest of the world. We're following the lead of previous companies that offer the same simplified DevX web development. That is, we're making it much more simple, less time-consuming to ship applications to consumers so you can focus on what matters most, the product. We want to grow the market and for new developers from new places to build original projects people want to use, not just another Twitter clone. Let's enable developers to build crypto web and PWAs on both iOS and Android with integrated infrastructure that matches the Web 2 experience today. Okay, so do you need to index your smart contract? Give us your ABI, give us your smart contract address. We work with providers like Laconic, Gold Sky. If you want remote notifications, baked in users and profiles, Forecaster, Lens integration, use one of our template apps. And you want to deploy your application to the App Store, Google Play Store, to the web, your PWA or website. We got that for you. History repeats itself. Technology moves in cycles. In each prior phase, streamlining tools simplifies processes, lowers barriers to entry, and unleashes a wave of innovation in new projects. The same will happen in crypto mobile, and Snowball will be a big part in making that real. And so we actually have an MVP that is working right now. We're shipping PWAs, any commit to whatever development branch you want, we'll deploy. And it's a streamlined process, similar to any Web 2 experience with like Web 3 components like authentication, authorization, on and off ramping, and account abstraction. You pick your provider. We work with them all, and then we're a multi-chain. So thank you so much. And does anyone have any questions? Okay, cool. Thank you so much.
Thank you so much, Vivian, for that really inspirational talk. We have a few minutes till the next talk, so sit tight. Hi, everyone. Welcome to the Trident stage and welcome to ETH Denver 2024. Our next speaker is Zen, CEO of Web3 Auth.
Thank you. Hey guys. Hi Denver. How's everybody doing? Is it a fresh morning? I'm feeling a little bit jet lagged to be honest, but glad to be here for sure. The spark whales are a lot cuter this year. I was checking one out. I'm Zen. I'm one of the co-founders of Web3 Auth. We are the leading wallet as a service company that provides social logins to wallets and via account abstraction, MPC, and more. We power Gnosis Safe, Animoca brands, and a lot of other both Web2 and Web3 brands that you guys might know and have heard of. Today I'm going to be talking a little bit more about, let me just get this out. It's a bit weird. Okay. Today I'm going to be talking a little bit more about something a little bit more technical. I'm going to talk about passkeys and basically enabling face/touch ID on wallets and on your applications so that you guys can go off and try it out and kind of like play around with it yourselves. So before that, just want to do a quick lay of the land, right? Who here knows what passkeys are, even in the first place? Okay, most of y'all. And who here also know what account abstraction is? Okay, also everybody. And also, fantastic. That's just perfect. Who knows about WebAuthn? Okay, I'm surprised. Okay, yeah, that's great. Okay, so most of you kind of know what passkeys as a construct are. Passkeys are an implementation of WebAuthn, which basically is a interface on your browser or also on some native devices that allow you to use your hardware enclave key pair to sign and authenticate to Web2 applications. Now, although passkeys and the user experience is really nice and seamless, it actually looks a little bit like this. This is me doing it on my Mac. I was just doing it last night. But basically, you can see that I just use my Touch ID on my Mac, and I'm basically into the application or into whatever I want to do, right? So passkeys is also a trend that has been pushed out by large industry giants, including Apple, Microsoft, and y'all know that already because most of y'all know what passkeys are. Some of you might have felt the experience on applications that you guys already know and love. Coinbase in particular just launched it, I think, a couple days ago or last night. Binance has it, GitHub, you know, all of these nice applications have passkeys. And now today we're going to learn a little bit more about how these are implemented and how also y'all can do that in your application yourselves as well. So first steps, the first thing is, right, digesting kind of like the flow and the authentication flow of passkeys themselves and how that works. So this is just ripped off from the website directly itself. You'll see that there are two main parties over here. The first party is the relaying party server, and this is the server that's looking to authenticate the user, looking to digest and understand and make sure that the user is who they say they are. And the second one is the authenticator. The authenticator, and as well as like this browser and all that, lives on the user's device, and that's the second stakeholder here. Now, the flow of authenticating a passkey is simply the relaying party server issues a challenge. This is not too different from what you'd think a OTP is or an email, a passwordless email OTP might be. It typically is a string. You can configure it as the relaying party server, and you issue that challenge to a user's front end. Then it's ingested by the JavaScript on a user's website or user's on the website that your user has loaded up. The WebAuthn API is then called. It hits the browser, and then it hits the authenticator. Now, authenticators are actually generalizable. There are lots of different authenticators out there. Passkeys is a form of a authenticator. In particular, that like Google and like Apple have implemented on their phones. But I'm not sure. Do you guys know like YubiKeys or let's see, YubiKeys. Authenticator app is different, but YubiKeys and all of these different hardware keys that you might have played around with before, that's also forms of WebAuthn authenticators as well. But today we're specifically talking about passkeys. And so the authenticator will basically sign on the challenge that's been issued. This challenge is then propagated upwards. Generally, a new public-private key pair is generated for each credential that we're talking about signing on. And that's also relayed upwards in step number 4. And finally, last but not least, it's relayed through the browser and passed back to the relaying party server where we see server-side validation. So how do we add crypto into this? How do we add a connection to the blockchain into this, right? So the way we do it is, and this is the first way to kind of, naively implement this would be, steps 1 to 5 are basically exactly the same, right? But afterwards, the public key as well as the credential is relayed via, like Infura or whatsoever, on-chain in particular, into on either a smart contract wallet or a account abstracted setup, right? On-chain and just used the signed object which was received back from the relaying party server is used as verification and is used as an intention for a user interaction. So we would basically choose to edit the challenge, right? In step number 1, we would, instead of just issuing a random nonce or a random challenge to the front end, we'd actually issue maybe a set of commands, something like transfer 20 USDC. We then go through the same process, sign, relay that object through the gas relay in step 6, and then it goes on-chain and is verified on the contract. The signature itself is verified on the contract itself. Now, this is a naive implementation, right? A naive architecture of how this would be done. Can anybody kind of spot what's wrong with this implementation just outright if we were just to do this? If we were just to take a WebAuthn signature or a passkey signature and put it on-chain, can anybody spot something that's wrong? I don't know if we have a Q&A and mic, but you guys can shout. Anybody? What? Wrong curve. Yes, it's WebAuthn is a wrong curve, but that's why we're actually doing the signature validation on-chain in step 8 relative to it. He mentioned wrong curve, and that's absolutely correct. WebAuthn signatures do not comply with ECDSA or SCCP 256K1 signatures. And therefore, we need to validate WebAuthn signatures specifically on-chain. And while that's correct and accurate, that wasn't the problem that I was trying to point out here. Can anybody else see potentially what's wrong in this naive setup? Again, we're just taking a signature and we're relaying it on-chain and intending that that is a interaction that the user wants to do. For example, in step 1, we're saying, hey, you want to send 20 USDC, and we're just relaying that on-chain, and that acts as verification for the account abstracted wallet to then move forward. Anybody? Okay, so the problem is actually replay attacks. In particular, So in particular, it's replay attacks. The main issue here is that if I choose to try to send 10 USDC outwards, right, and a signature from WebAuthn describes my intent to do so, once I relay that transaction on-chain, this transaction is public. People can see it. People can basically take the same WebAuthn signature, this same the same intent, right, and replay it. So for example, if I Zen were to send Bob $10 and I actually had $100 in my wallet, Bob could take that same signature and replay that 10 times, right? Because it's the WebAuthn signature that we're verifying on chain, because the curve is not compatible. That describes my intent to send money. How will we fix that? Does anybody have a fix to this now that we've outlined the issue? What do you say? Yes, that's right. Use a nonce. He said use a nonce. So basically, we just have to add a nonce on chain that describes part of the intent. It's not unsimilar to the transaction nonce that you might typically implement. So you just add a nonce, and this nonce will increment. It can start at 0, and that means that every signature that you sign on is unique because of that nonce. And if it's not signed on a incrementally, increasing nonce, it's just not a valid signature. Yeah, and that basically is more or less a basic, a very high-level interpretation of how one can implement passkeys into an account abstracted setup. So us at Web3Off, we've done this with a couple of clients and a couple of companies, and we've made a lot of mistakes along the way. Passkeys is a relatively new concept. It's a relatively new thing for users to be adopting. And as such, in production, you actually face quite a few issues here and there. The experience is great in general, but definitely one of the biggest problems is that passkeys themselves, or WebAuthn, works super well on Apple and some of the latest Apple versions, but on other devices, on like Windows, on like Androids, they don't work so well. There's a lot of different versions of Android. There's a lot of different versions of Windows, a lot of different manufacturers, and there are issues with passkeys implementations across them, right? Another thing is definitely there's extra cost for the verification. In particular, because the chains are not compatible, you are paying an additional component for passkey verification, which is on-chain verification, which can be costly. And then last but not least, so it's about like, the last I checked is about 15 to 20 cents on Polygon, and quite a bit more expensive on mainnet. And then last but not least, there's actually a centralization risk with the relaying party solver. So passkeys, as well as WebAuthn in general, are application scoped, meaning that there has to be a relaying server party issuing the challenge and receiving the challenge as well, in particular. This is required by the domain specification, and it's enforced by domain ownership and like DNS ownership, right? So if somebody, basically you are dependent, your passkey is dependent on that specific domain to be used. And if this domain goes down, they can't steal your money, but they definitely can, you basically can't use your passkey anymore. So some implementation recommendations so that you guys don't commit the same mistakes that we do and some of our early customers did are definitely, with passkeys, what you want to do is you definitely don't want to use passkeys in a silo at this point in time. What I mean by this is you don't want to use passkeys as the only signer to your account abstracted wallet or the only signer to your to your account, essentially. Why this is the why this is the case is because passkeys are, well, not exactly as robust. There are edge cases. People do lose them, and you don't want people losing accounts on your different implementations. No Web2 implementation that exists today includes just a passkey login into a user account because recovery is an issue. The second thing is the second thing is just to add on that, you definitely, you can use it as a alternative login as the first factor, but you can also use it as a second factor, like a 2FA, as per normal, as per normal. Last but not least, you want to restrict your implementation to compatible browser and OS setups. So, for example, Chrome and iOS just don't work with passkeys. You won't be able to access your hardware enclave via Chrome. Passkeys is a very specifically Safari integration. So on iOS, you only want to allow Safari, and if the user is not on Safari, you don't want to enable this feature because it just runs into read routes. And this is the same on Chrome Android. You only want to allow Chrome Android or Chrome and Windows Edge/Chrome as well, in particular. Yeah, I mean, that's about it. And I hope you guys enjoyed this little snippet. And I can take some questions actually, if there's any time for Q&A in particular. Anybody has any questions or anything they want to double click on here? Yes, sir. So the Coinbase implementation is a very interesting and novel implementation. For those of you who don't know, the Coinbase implementation is they have your main key, right? Your main smart wallet that is on Coinbase wallet itself. And then they basically use passkeys as session keys for dApps and applications to use and sign without having to go back into the Coinbase wallet to confirm each and every transaction. So what they're using passkeys as is essentially they're using passkeys as session keys for dApps. I think it's a good implementation because even though you lose your passkey, you never lose your original account with Coinbase. You just lose your session key and your session on that application. You can rehydrate it and you can create a new passkey for that dApp, so there's no concerns of loss. I think it's quite an innovative and novel approach of using passkeys, and I think it's really cool. Any other questions? All right, okay. Yeah, you can find us here. If you guys want to use social logins in your applications, do hit up Web3Auth. We also have recently released our Passkey SDK as well as our Farcaster login SDK. So if you want to do login with Farcaster into your application, do check us out as well. Unfortunately, we aren't sponsoring ETH Denver this year, so we have no prizes to offer. But toodaloo. That's it. Thank you, guys.
Thank you so much, Zen. Stay tuned. Our next talk is at 11:40. Hello, everyone. GM, thank you for joining us at ETH Denver 2024, and to everyone watching us on Twitch, thank you for tuning in as well. Our next speaker is Ahmed Al-Balaghi. He's the CEO and co-founder of Biconomy. His talk today is called Session Keys, Unlocking Account Abstraction for the Masses.
This is not one. Okay, cool. Hey everyone, we need 1 minute. We're getting Super Tom to fix the issue. Okay, got it. No worries. All right, awesome. Hey everyone, thank you so much for tuning in, and yeah, I'm really excited to speak to you all today, and thank you all for coming. My name's Ahmed. I'm one of the co-founders at Biconomy, and at Biconomy we build infrastructure for wallets, app chains, dApps, to essentially enhance the UX on-chain. And for us at Biconomy, it's all about making on-chain UX as simple as off-chain. So today I wanted to basically talk about session keys and actually do more. I wanted to show you guys session keys. I think a lot of talks about account abstraction with use cases like session keys, there's been a lot of talk but no show or tell. So today I'd love to do a show and tell on session keys. So I guess just very quickly, we don't need to go into the weeds. What are session keys and what is it in the context of account abstraction? So session keys in the context, in the Web 2 world, are essentially, JWTs, right? And so, they use JSON Web Tokens as a way to authorize transactions, and we essentially do this every single day, right? Like, we grant permission to applications, be it Google, Zoom, Slack, and so this is something that we use on a day-to-day basis. And of course, this is all centralized verification and authorization. In the context of account abstraction, session keys become a lot more cooler because they're now programmable. And so what this essentially means for the user is that they don't now need to have wallet pop-ups every time they do a transaction. And so imagine you're doing a trade, an NFT mint, anything on-chain. When you give a permission that is limited, controlled, and that's verifiable, you essentially can have an amazing UX from the wallet or the app layer. And so what this means is here temporary keys are generated for the user in the browser or phone or even on the laptop. And of course, this is all going to be based on predefined conditions that either the user sets or the wallet sets or maybe the dApp sets on behalf of the user. And the great thing about this is because this is all on-chain, this means we can have decentralized verification authorization. So we basically built a V1 implementation of our session keys for our modular smart accounts by Biconomy. And essentially what we optimized for was sort of three things. The first was modularity. The second was UX and security. And the third was optimizing L1 gas fees. And so essentially for us, this was, whoops. I don't know what's going on. All right. And essentially for us, we built this implementation with these three core things in mind. And when it came to the modularity, the reason why we built this is so that for dApps, they could essentially have a separation between general permissions and use case specific permissions or flows that they have in their app. And then sort of when it came to the UX and security side, they could basically think about the security they want to implement and think about the user flows in a bit more detail. And we also basically implemented Merkle trees in order to, at least on the design of the session keys, in order to optimize for L1 gas. And in a way, what this kind of looks like, from let's say a gaming perspective, what a dApp could do is essentially allow the player and the user to have these different conditions based on their application. And so whenever the user is doing a transaction, if that transaction basically if it's basically obliged by these criteria, then they don't need to sign anything. The transaction just happens whenever they're doing a simple operation. And so, of course, this is, in a way, what we wanted to enable for dApps that are building with account abstraction. So, like I said, I want to show and tell. So let's look through a demo. And this is basically a live implementation right now that you guys can use. Okay, this is a trading example. I know it's not a full-on, like, this won't bring, 1 billion users to Web3, but it still at least showcases a real flow that like thousands of traders, even tens of thousands of traders, are using on a daily basis. So, all right. So over here, as a user, I go on Manage. I go on one-click trading. I could basically see that my session is inactive. I could then dictate how long I want the session to look like. So here the user has chosen 5 hours. They enable this. It's one simple signature request for the user, and then it becomes active. This session happens on chain. And so now, for the user, what they're able to do is they can now do a simple trade. They're longing ETH over here, which is probably a good idea. No financial advice. They're opening in position. They're confirming the order. And it's just as simple as that. There is no wallet pop-up. This is all on chain, all verifiable. And here the transaction has succeeded. So from the user point of view, especially from a trader point of view, when seconds matter in the form of trading, this use case, I'd say the trading use case has been like the #1 use case that we've seen in account abstraction. And here the user is doing another position, which is basically closing the position, and here they're submitting the close order. And again, within these few hours that they've enabled this permission, they don't need to worry with any wallet pop-ups, no gas, or anything like that. You guys might ask, okay, so how is the user paying gas? There is a gas tank that the user has pre-funded. So essentially, this permission is basically saying, okay, or at least on the dApp level, it's taking gas from the gas tank, which basically makes this UX super easy. So that's I'd say a real life implementation of session keys. And so what does this look like in terms of adoption? Where are we at with this? So I would say the #1 use case that we've seen has been for trading. So we've worked with companies like RageTrade, Quenta, and Depop. And it's been quite astonishing, actually. Like, we've seen over 15,000 session keys registered on chain. Yes, it's small in number, but it kind of goes to show, okay, the impact that it could have. And what was really cool that we saw was that we enabled a form of multi-chain transactions that we kind of haven't seen before. So what does that mean? If I'm a user, like for example with RageTrade, they're a perp aggregator. Now, as a perp aggregator, they aggregate perp platforms on Arbitrum, on Optimism, and other chains. And so what they enable the user to do is, I could basically sign a transaction on Arbitrum for me to execute a trade on Optimism, right? Now, why is this useful? Because it's useful for this use case, right? But if we think about sort of further use cases, imagine a user had a wallet on Arbitrum and Optimism, and they wanted to send funds from their Optimism, let's say, wallet, right? And in this chain abstraction world where the user doesn't need to think about switching the network ID or anything, they could literally sign a transaction on whatever chain they're on, and then it would execute the transaction on another chain. So this was, I would say, in a way, a more sophisticated example of how this, was working for one client of ours. As we went through this, there was a lot of learnings from V1. We wanted to introduce security policies or more generalized security policies. However, the V1 design was not that compatible. There was also, V1 had a dependence on an off-chain layer. And so this also led to complications if a user had a session key on one app and a session key on another app, and what if there was, let's say, a collision of session keys. Gas costs were also high. I remember when I was using these platforms, I was paying like $1, for to enable a session. This is, I mean, for traders, it's not a lot, but if you're a user using any form of, any simple application, this is still a high amount. And at the same time, to achieve, I would say, multi-chain flows and essentially transaction flows, the developer had to integrate different modules. So basically, the integration was a bit complex from the developer side. So now, as Bioconomy, we're going to be rolling out Session Keys v2. And essentially, this is an upgraded version from all the things that we've learned. So what does this mean? It basically means it's more L2 native, and it's scalable. We are focusing on minimizing a lot of cost in terms of gas. So that's focusing on minimizing call data and allowing for sessions that might have to be enabled separately. They can now be enabled in one transaction so in order to save the gas cost for the user. So the form of batch transactions could also work in this case. And also, we found a way to enable multiple sessions that could be done across chains within a single click as well. So these are all, I'd say improvements that we are building towards with V2. And so when we look at the immediate benefits and improvements, they literally span across security and transparency, cost and time, and DevX. And so for us, security is paramount, and especially if we want to enable a verifiable way to check out sessions and really a decentralized way to authorize them. And so this basically means now anyone could basically have their own form of security policy, or we can have a general form of security policies with V2. As I mentioned before, we're now able to reduce the cost and time for developers to integrate session keys, especially with the gas costs, which are super important to optimize for. And then there's also DevX improvements. Now, the developer does not need to integrate many different modules, or they don't have to do a lot of complex things like our previous clients had in order to enable customized user flows. One thing that I also wanted to talk about here was, we had this concept of ABI session validation module. So essentially what this means is with our V1 of session keys, every DApp that we worked with had to build their own custom session validation modules. Now, what is a custom session validation module? Let's say a DApp wants to enable free NFT mints, for example, using session keys. They would have to build their own SVM. They would have to write it in Solidity. They would have to get it audited. They would have to get it deployed as well. And so this was a very, very long journey for applications to do. Now, for these more complex DeFi applications, it was way more than just a simple NFT, SVM that they had to build. So a lot of the developer integration work and time actually went in building out these SVMs. Now, what's cool with V2 and with this ABI session validation module that we have is, we're going to have pre-deployed modules, meaning that developers don't need to reinvent the wheel for many, many use cases. And as well as if a developer had a specific flow that they wanted to implement, they could do it without having to code, which is super cool. So it kind of expands the developer crowd that we want to attract with this. And the great thing is there's no overhead. You don't need to get this audited. You don't need to write Solidity or deploy anything. And so it just becomes a way, way easier sort of experience for developers and apps. So we're really excited about this. We're going live with this soon, and we would love to see sort of how it operates in the wild. So, just wanted to touch base for us and at Bioconomy. We're, if you're a developer wanting to utilize account abstraction, I'd love, for you guys to work with us. We essentially provide a full stack account abstraction SDK from all the way from modules, the smart account layer, to Paymaster service and the bundler service. And I did want to take some time to like talk about some of our clients. So we just recently integrated with Trust Wallet a couple weeks ago. This is to power the new wallet called Swift. It's a contract account. So what we've enabled Trust Wallet to do is for their users to pay gas in over 250 tokens. And it's been already 2 weeks since launch, and it's really interesting to see that the top 2 tokens being used to pay for gas for any form of operation is USDT and TWT, which is a Trust Wallet token. And what Trust Wallet did was if you pay with Trust Wallet token, you kind of have a discount on gas. So it's a pretty cool sort of token use case that we were able to enable for them with account abstraction. Eccentric, now this was a announcement we did yesterday. Eccentric is basically a product of Mercedes-Benz. We officially announced our partnership with Mercedes-Benz to allow them to enable account abstraction in this new data marketplace that they're building on top of blockchain rails. This data marketplace is going to be about automobile data, and essentially for them, because Web3 is really important and it's easier to enable, I'd say a marketplace for this data. They wanted to use account abstraction to make it easy for people to onboard and to access the platform without having to pay gas, of course. Another cool integration was chess.com and Animoca. You guys might have, you saw the previous presentation with the Web3 auth. So we worked with chess.com and Animoca on the new game called anychess.com. So it allowed, so this game is basically like a magical chess.com, and users get like free NFTs for, doing whatever they're doing on the game itself. But what was really cool was this was an integration with both Web3 Auth and Bioconomy. So Web3 Auth was a social login provider. Because we don't provide a social login solution. We work with folks like Web3 Auth. And so they used Web3 Auth for social login and Bioconomy for the full account abstraction solution. And right now, it's one of the biggest, I would say, dApps that are continuously doing transactions on a day-to-day basis. And we've also have gotten on board folks like JP Morgan as well to use account abstraction in their POC last year with Project Guardian. And so far, all of these efforts has already enabled us to become the largest account abstraction provider in this space. So, we've kind of like gone through so much in terms of building the stack out, a lot of trial and error, and ensuring that everything is as reliable and as scalable as possible. So, if you guys want to build with us, please let us know. I'll be around here for a bit. And yeah, if you have any questions, I'm happy to take any questions that you guys have. I think we have another minute or so. All right, if there are no questions, it means that I've explained everything clearly. I hope that was the case.
Thank you so much, Ahmed. Let's give it up one more time for this amazing talk. And thank you so much for joining us today. Okay, welcome everyone. GM, hope you're doing well this morning. And I wanted to welcome our next speaker. We have Yoav Weiss. He's a security researcher with the Ethereum Foundation. And his talk is titled, AA is easy if you don't care about decentralization. Thank you.
Right. Hi, everyone. So, so many of you probably heard me talk about account abstraction before, and usually I talk about use cases, but I often get asked about the complexity of ERC 4337 and why does it have to be so damn complex. So today I'd like to say a few words about that. Of course, we won't be able to go into the full depth of the protocol, but I want to give you a glimpse. Now, before we start, let me tell you a little story about a monkey. So I have a monkey NFT. I really like it. It's really nice, and it's a really nice monkey. But it's worth a lot of money, so I want to sell it. And now I'm asking myself, why do I need this? Why do I need Ethereum, this complex blockchain, in order to trade my monkey? It's just, there's like complex data structures like Merkle trees. We have many staked validators with slashing conditions, and we have a complex DHT protocol for peer-to-peer communication. We have multiple client architecture. Why do we need all that? Why don't we just use a centralized web server and get it over with? Well, it turns out that the answer is that if we are serious about the monkey being my monkey, then we do need this complexity. If I was okay with trusting some server operator who may decide to take my monkey or to prevent me from selling it to someone, then I wouldn't need a blockchain. But it turns out that the community values things like self-custody and censorship resistance. So with that, let's talk about accounts. So smart accounts are basically smart contracts that let me implement functionality into my account, my on-chain representation. But there's a problem. With an EOA, I can communicate with the network. I can transact on the network directly. The EOA pays for the gas. I just sign a transaction. The EOA pays for the gas, and stuff gets executed. With a smart account, it doesn't work that way. And you actually need a funded EOA that will sign a transaction to pay for the gas and make a call into the account. And that's a big UX problem, because we cannot require users to have both a smart account and an EOA with some ETH, and then require them to sign each transaction twice, once for the EOA to pay for the gas and once for the real transaction. That's a UX that's not going to fly, and we'll never be able to get the next billion users. So with that, there's the centralized approach, which is what some projects tend to use for smart accounts. And it means that there is a centralized server. The server has a funded EOA that can send a transaction, and so I send my transaction, I send my operation to the server. The server wraps it in a meta transaction and puts it on chain for me, pays for the gas, and I compensate it like later. But or maybe I do, maybe I don't. Now the problem here is, as I said, it's not really self-custody. If I need somebody else's server to interact with my account, is it really my account? I would say not really. It's not, if I cannot use the account directly, maybe it's not really self-custodial. It's not really mine. It's only somewhat mine. And some people say that's not a big problem, and in many cases it isn't, until it is. Like, what happens if the wallet company runs out of money, it goes bust, and stops paying its AWS bill? So suddenly the server goes down, and I can no longer interact with my account. I'm stuck. Or maybe they get a denial of service attack against the server, and also I cannot interact with my account suddenly. Or maybe they work just fine. The server works just fine, but their business model changes to extract MEV. So they front run every transaction that has value, and they are going to win 100% of the time. I have no way to defend myself because they are actually the ones sending my transaction on chain. And of course, they could censor me because someone coerces them to do so. I mean, the server is operated by humans. They can be coerced. And there's the issue of privacy, because the server knows my IP address, so it has my real identity, and it sees all of my transactions, and maybe it keeps logs and shares them with someone, I don't know. So having a centralized server is not very good for self-custody. Now, so let's try to naively solve this problem. One way to do it is say, let's have many servers. What if the wallet company runs multiple servers, not one? Well, that doesn't change anything because the servers are still operated by the same entity, so they would go down together, or they would censor together, or front run me together. So it's like one server. So the next logical step would be, let's make it a decentralized and incentivized network of relays. And then it's no longer operated by one entity, and problem solved. Well, we try that with, this is what we did with GSN, with the gas station network, and it does decentralize access, but there's a catch. There's a catch, because what if the account behaves inconsistently? The account could, when in an off-chain simulation, the account would appear to be compensating the relay, but when the relay puts it on-chain, it actually doesn't compensate because it can detect that it's running on-chain by looking at some environment opcodes. So it decides not to pay, and now now the relay gets griefed. So we need to protect the relay against griefing. Now, how can the relay protect itself? We'll again try some naive approaches. What if the relay keeps a whitelist of known account implementations that don't grief it, and the relay only accepts these account implementations? So that's fine, but then who gets to decide what account implementation is legitimate and says that everything else is not? So it's permissioned in the sense that innovation is now permissioned. So instead, what if we restrict users? We say you can use any account implementation, but you have to sign in with your phone number so the server can identify you. And then if you grief the server, they're going to block you. So this brings us back to censorship, because if they can block you for griefing, they can also block you for any other reason. So what if instead we say we don't require usernames and we don't require implementations. Instead we keep a reputation for each account. That doesn't work because of Sybil. You're going to have Sybil attacks. Any attacker can keep spinning up more accounts and keep griefing the server. So what if the server, after simulating and seeing that the transaction pays, it will use flashbots to submit the transaction, and will not. So it will use flashbots and ask the flashbot relay to only submit the transaction on chain if it ends up paying. So now the DOS vector moves to flashbot itself, because the attacker is going to send an ongoing, is going to keep sending transactions that behave inconsistently. So the all pass simulation gets submitted to flashbots, but then flashbots ends up not including them because they don't pay, because they revert instead. So after a while, the flashbot relay that is now doing a lot of unpaid work is going to block this server, which brings us back to censorship. So now the entire server gets censored. So without taking all of these things into account, we cannot build a robust and permissionless solution. Either it has to be permissioned, or it's going to be vulnerable and be taken down by someone. Either way, we don't end up with a censorship-resistant solution. So that's what ERC 43.7 aims to solve. ERC 43.7 is account abstraction without compromising decentralization, which means that there are no centralized components, nothing is permissioned in a network, And the account is fully abstracted, which means that account validation involves executing EVM code. And this enables many attacks. It can lead to many denial of service vectors, which we need to address. So the protocol has to take care of all of these requirements, or else, if any of these requirements is not met, we're going to end up with a network that can censor users, or with no network at all because it will be attacked. But if we can make it, if you can make the network have all of these properties, then we end up with a robust solution that we can count on and not have any censorship vectors. So how does ERC-4337 achieve all that? The first thing we had to do is we had to separate validation from execution. The transaction has to be structured in a way that we know what part is the validation and what part is the execution. And then we can limit the amount of work. This is really the bare minimum we have to do. We have to limit the amount of work that has to be done in order to validate the transaction. If we don't do that, then the server may end up doing an infinite amount of unpaid work and never get to do any paid work. So we can say that even if the transaction is 5 million gas, it can only use 200K of gas for validation. And this limits the amount of potentially unpaid work. But that's only the start of it. Now, if a transaction is valid in the mempool, it gets propagated in the mempool, which means that every node in the mempool performs some work in order to validate it. Then we need it to also be valid with high likelihood to be valid on-chain, because otherwise, again, we get a denial of service vector. So, for example, suppose I implement an account that has a check for block number, and it says if the block number is even, I'm going to accept the transaction. If it's odd, I'm going to reject it. Now we have, so now during simulation, during an odd block, during an even block, it will be successful, so it will get propagated in the mempool. But then when someone tries to put it on chain in the next block, it's going to fail and not pay. So we needed to prevent that. In order to do that, we had to ban all the environment opcodes during validation. Note that all of these restrictions are only in validation. During execution, you can do whatever you want because you're already paying for it. But until you pay for the transaction, you cannot look at something like block number. You don't really need block number in order to validate any signature scheme. So that's one type of restrictions. Another issue is mass invalidation by flipping a flag in storage. What if I have many accounts that all check a flag in some singleton contract, and then I send 10,000 transactions to these accounts, but I front run my transactions with one transaction that flips the flag and invalidates all of them. So now at the cost of a single S-store, as a single state change, I invalidated 10,000 transactions, and I caused every node in the mempool to first have to process these transactions and not get paid for them. In order to prevent that, we needed to limit the storage access, but storage access is useful. You need, for example, to access your keys in order to validate them. So the account is allowed to access its own storage and its associated storage, which means storage that is associated with the account's hash in other contracts, such as an ERC20 balance for that account. But it means that two accounts cannot access the same storage slot during validation, which brings up the cost of the attack to order of n. Now you have to write to n slots to do n S-stores in order to invalidate n transactions. Another issue is the transactions cannot be mutually exclusive, because otherwise I can have many transactions, all of which are valid during propagation, but when you try to include them bundled together in the same block, they invalidate each other. For example, they could invalidate each other because during execution they can actually access anything. So what if transaction 1 passes validation, and then during its execution, it flips a flag in the account of transaction 2. And now transaction 2 that was formerly valid becomes invalid. So you can send any number of such mutually exclusive transactions, and the block builder will never be able to produce a block. To prevent that, we have to run all validations before any execution. So even if it's going to revert later because of then it will revert after paying. We have some global entities in the system that sometimes do need to access the same storage slot during transaction. For example, paymasters. The paymaster pays for the transaction for multiple transactions, multiple accounts, and it needs to access the same slots. In this case, we need to have a reputation for it, so if it causes too many invalidations, we're going to throttle it, and it will not cause a lot of unpaid work. But this requires Sybil resistance, because otherwise someone can keep spinning up more paymasters. So if the paymaster needs to access its own storage, it's like a global storage, it has to be staked. The stake is not slashed in any case, it's just used as a Sybil resistance mechanism. So I'm going to skip a bit because we're running out of time. Now, why does it have to be a standard? Why do all the bundlers need to implement, all the bundlers in the mempool need to implement the same restrictions and not come up with their own protection? The answer lies in spam protection. Bundlers need to, nodes in the mempool have to protect themselves against spam, against nodes that keep sending them invalid transactions. So, because this consists of this is unpaid work for them. So, if one node considers something to be valid, it propagates it to another node that considers it invalid, it will have to block the first node as a spammer. So if they don't implement exactly the same rules, the network will get fragmented. Different parts of the network, different implementations will block each other, and we'll end up with many small mempools. Now that's a problem because having many smaller mempool is much more prone to censorship attacks. It's a smaller group of, the transaction ends up in a smaller set of nodes, and also it means that we lose the benefit of multi-client architecture. Currently we have many bundler implementations, but if each bundler implementation had its own mempool with different rules, it means that a bug in one client can censor transactions. So, and of course we lose some economic security because bundlers are less profitable. They only see a subset of the transactions. So we have many reasons to have the same rules for everyone. This keeps the mempool more robust. Right, so the solution here is to have exactly the same implementation, exactly the same rules for all implementations, and we needed to do the same with Ethereum because of the multi-client architecture. So Ethereum has very clear specs for the very clear consensus specs, and we do a lot of testing and fuzzing to cover that. And ERC 457 does the same thing. So just to summarize, since we're running out of time, we have so account obstruction could be really easy if we didn't care about censorship resistance, which is exactly the same reason we use the blockchain, because we do care about these values. So smart accounts shouldn't have to care about decentralizing, about that. They should focus on user value. So ERC 4337 does it for them, as long as you use bundlers that are compliant with the protocol and participate with the mempool properly. Right. So I think we're out of time, so thank you. Right. Do you have time for questions or no? Okay.
Hello, everyone. We're ready for our next talk. Thanks for joining us here at the Trident stage, ETH Denver 2024. I'd like to welcome our next speaker. We've got TJ Connolly. He's a principal engineer at Fireblocks. And the talk today is called Security and Trust Assumptions for Evaluating Non-Custodial Wallet Providers. Thank you, everyone. Welcome.
Thank you. So hey, everybody. First thing you should probably notice here, right? Non-custodial in quotation marks. I think that means a lot of different things to a lot of different people. It's a very nuanced subject. And once you start getting into the underlying security models, that can mean a lot of different things, right? Is a wallet truly non-custodial if the wallet provider is able to, eavesdrop on sensitive activity, things like that. So the purpose of this presentation is to, help educate. If you are looking to use non-custodial wallets, maybe you're a Web3 business or a DApp looking to onboard users, this talk can help you ask some of those hard questions to look for, what are the most kind of secure models to do this, and really the most trustworthy as well. So quick about me, that's me, background cybersecurity, specifically kind of in this field around applied cryptography, pen testing and things like that. So first off, why would you as a business want to offer non-custodial wallets? We all know that, you have to onboard users, right? So what are your options to onboard users? Number one, they need a wallet, right? Without a wallet, then it's a Web 2 facade over Web 3 and doesn't really provide any of those benefits of Web 3. So your options are, number one, let them bring their own wallet, right? This requires the user to be a crypto native, have expertise. This may limit the amount of users that you can onboard. Number two is you provision custodial wallets on their behalf. So this is what a lot of exchanges will do, right? You go and you trade on Coinbase or Robinhood. Your crypto is physically sitting on a wallet that those exchanges control, right? It's not your keys, it's not your crypto. This is obviously tons of risks here, right? Counterparty risk, everything along with that. But also as a Web3 business or a DApp trying to onboard users, that is a big regulatory concern as well, because now you have to hold all those users' assets in your custody on your balance sheet and assume all of the risk that entitles, right? We have things like SAB 121 here in the US that really prevents that and kind of makes that impossible for most publicly traded corporations. Good news is hopefully that's changing. But some big challenges with that model as well. And so the third model, which we've seen with embedded wallets and non-custodial wallets, is that user comes to your platform, you provision them a Web3 wallet because they don't have one already, and it allows them, all of the benefits of self-custody and allows them to easily interact and onboard to your application. So again, all of these have trade-offs. Non-custodial wallets, aka embedded wallets, they've seen a recent surge in demand. Really trying to onboard Web 2 users. And one of the things that I think is really overlooked too is if you can control the wallet, which is effectively where all of that user's identity, economic activity occurs, there's a lot of value that you can extract from that, both for the benefit of the user or the benefit of your platform or some hybrid thereof, right? So quote here that I really like is from the Salesforce Web3 lead. He says, the wallet is now the new cookie, right? If I can give a user an identity and track that identity across different boundaries, I can start creating a profile, start doing really interesting things like targeting them with different ads, for better or for worse. And then there's also, direct revenue opportunities. My favorite example is MetaMask. Within MetaMask, you can do native swaps. They're not doing any of that swapping themselves. They're just routing through, Uniswap and other routers. But they've been, because of the ease of use of that swapping capability, they're able to charge about 87 basis points. You compare that to most swaps, which are, 5 to 30 basis points. And they've been able to do that because it's a great user experience, right? And the users are okay paying for that because they can do it all natively within that wallet experience. Oh. So, this is what the current market looks like. You obviously have providers like MetaMask or Ledger, hardware devices where you bring your own wallet to the DApp or the Web3 business. We have wallet widgets. These are the ones that have definitely gotten the biggest uptick so far because of ease of use and convenience. And then you have the white label wallet SDKs, which is where Fireblocks sits among some of these other players, where you have more bespoke programmability and SDKs to be able to build a more bespoke non-custodial experience. So that being said, right, what is the trust assumption? When you go to a wallet provider or a DApp and they provision you a wallet, you're inheriting a lot of trust assumptions, right? You're inheriting the trust that, hey, that wallet issuer, whether or not the tech provider or the business, they haven't backdoored it, they haven't eavesdropped on any of the sensitive key material, and they can't, maybe censor transactions or things like that. So what we've seen is a lot of issues with this, right? Again, in the race for convenience and ease of onboarding for Web 2, a lot of sacrifices have been made for security and trust. So here are just a couple of examples of that, and I don't want to throw shade at any particular model here. Really, the purpose of this talk is to educate all of us to be able to ask these hard questions. There are going to be businesses where you care more about convenience, right? You care more about onboarding users easily, right? And you want to get to market fast. Totally get that. But understand, what the trade-offs are. So a lot of these wallet widgets, what they use is some form of a magic link. So user comes in to the app, they authenticate, typically a Web 2 authentication, like a social login using your Google credentials or your iCloud credentials, and then the wallet provider produces a one-time link, which then once you click on that one-time link, it does something in the background and a wallet is provisioned. That link itself, I don't agree with this particular headline calling this a vulnerability. It's more of a phishing scenario. Right? There's opportunities for a man in the middle to go and manipulate that magic link or control that magic link prior to you actually clicking on it, such that they can control and own that underlying wallet that's being provisioned. We saw this here with FriendTech. Very similar model, right? There's a magic link. There's some other issues with that, which we'll get into. But same thing, right? There's a supply chain of where that wallet gets provisioned from how it gets accepted and authenticated by the end user, and with that supply chain, there's lots of opportunities for vulnerabilities. The next one down here, this is pretty interesting because on the bottom left, this is not a non-custodial wallet per se. This is just a typical self-custody wallet. This is in the Binance Trust wallet. I don't think it has anything to do with Binance anymore. I think it's its own thing. But typical wallet, it's on your phone. They found, a pretty severe vulnerability. This is in the NIST vulnerability database, and there's basically not intentional. There's a backdoor in one of the cryptography libraries that wallet uses. Right. So what does that mean? Was that there intentional? Was it there not intentional? We don't know. It doesn't matter really. All that matters is that the seed generation on those types of wallets is now vulnerable, and the wallet issuer may or may not have been aware of that. The other one here is another supply chain type vulnerability, where you have fake wallets being listed in the app stores. Right? App stores are supposed to be these super secure walled gardens, but we found that fake wallets that have drained users' funds have actually been able to get through the Apple and Google security checks. So again, in the idea of education, right, I think everyone here, if you're looking at wallet technologies, you need to understand this, right? This is the private key and digital signature lifecycle. This is how accounts on blockchains work, right? This is how TJ on the blockchain is somebody different than Satoshi. So you have, 4 key components here. You have how the key is generated, how the key is stored, how the digital signature, which authenticates and authorizes that user, is created. And then lastly, this is where the blockchain comes in. The blockchain just says, yes, that's a correct signature. Use the correct corresponding public and private key, sign the correct data, and we'll go ahead and settle this transaction. So the attack vectors here, right? Every piece of that life cycle, that's happening within your wallet, right? So if I'm bad guy here, right, and I steal, your credentials to your laptop, you have MetaMask running there, right? I can go in and I can do whatever I want at that point, right? I have your password. I don't need to steal private keys or anything. I can just go and use MetaMask. Now, as the wallet provider, you also have insight into all of these different levels of activities, right? So as the wallet provider, you're generating the seed that then those private keys are generated from. You're storing those private keys in some form or fashion. You're also prompting the user to sign transactions that they authenticate with those private keys, right? So tinfoil hat, lots of opportunities here if you were a wallet provider to kind of take advantage of this. So, don't want to be doomsday scenario here. I think we can find a happy medium here between, being both secure, trustworthy, and convenient. Again, not a one-size-fits-all. You may find yourself as a business more focused on the convenience factor, less on the secure and trustworthy. Again, that's fine. We all have different objectives and goals. But, if you are looking to build in this, really take the time to understand what those trade-offs are that you're making. The trustworthy one is tough because in this space, right, if you lose trust as a technology provider, it's very hard for that to come back, right? We've seen this with protocols that have gone hacked or, obviously if a protocol, does a rug pull, they're never going to come back from that, right? So trust is super important in this industry. So going back to, how should you look at different non-custodial wallet providers? We're big fans, obviously, of multi-party computation. This is what Fireblocks does. We provide MPC-based wallet infrastructure. Some of the other providers, generally, the kind of key architectures that you see is that the first one on the left where there's some cloud server, it's an AWS server, and basically the wallet provider is generating the key, in a secure enclave or in an HSM, and they're doing that on your behalf, right? This really isn't non-custodial because it's all happening on somebody else's infrastructure that you don't control, right? The other one is going to be Shamir secret sharing. By itself, you should kind of look at this with some concern because Shamir secret sharing, if that's all they're using without MPC, then basically what it means is that there's a single private key that gets generated at a single point on a single device. And again, that device could be, on their infrastructure, on your infrastructure, but there's still a single private key, and that's a single point of compromise. And so with multi-party computation, all of that key lifecycle that I showed you, that is done in a distributed manner, in a trustless manner. And I'll explain that here. So we have our private key. We have Alice, Bob, and Charlie. With MPC and threshold signature schemes, what it's allowing you to do is jointly compute a function over different inputs while keeping those inputs private. So in the example of a digital signature and key generation, right, we have to generate the key. Can we do that in a distributed manner? Can we store the key in a distributed manner? And then when it comes time to sign a transaction, can we do that in a distributed and trustless manner? This is useful in scenarios where no one trusts each other. So take the example of, okay, I'm a user coming to a Web3 app. You're provisioning me a wallet. How do we create a trustless setup where I have really kind of the most important input into that key generation, but I still, can use other parties to help distribute that and make it more secure? So again, the full key life cycle here is that it can be generated and calculate the signatures interactively through these different multiple parties. And most importantly, the private key is never assembled in one place. And when implemented properly, all three of these pieces of key material here, this could be arbitrary. You could have a 2 of 2 MPC. You could have a 4 of 4 MPC. There's different models for that. But what the important thing to note is that if you're a bad guy, whether or not you're the wallet issuer and you want to backdoor the wallet, or you're compromising their infrastructure, you need to get all of those key shares in order to recreate the master private key, right? This is the concept of perfect secrecy. So also want to reiterate that with everything in security, there is no silver bullet when it comes to security. And MPC is definitely not a silver bullet. It is something to aspire to, and again, I think it's the best model to look at. But we found a couple of researchers at Fireblocks found multiple zero-day vulnerabilities in some of the most widely used MPC protocols out there: GG18, GG20, Lindell 17. These are prior implementations than Fireblocks' MPC CMP, if you're familiar with that. The vulnerability here is in that threat model, right? If you remember Alice, Bob, and Charlie. In those implementations, Alice here is actually a malicious party, right? So this might be the wallet issuer that's a malicious party. So we found about 15 different vendors whose implementations were vulnerable to this, where it resulted in total compromise of the underlying key material, right? So just a friendly reminder, right? And the underlying issue here was that a lot of those, again, they're very different compared to the different wallets, but generally speaking, a lot of them did not use required zero-knowledge proofs to basically verify securely that the key was generated correctly, they were stored correctly, and that the signature was generated correctly. If you do that in this trustless this multi-party environment, and you don't do that with also verifying and without exposing sensitive data to the network, then you're going to find yourself susceptible to these types of vulnerabilities. So again, friendly reminder, security should never be a commodity. This is what I see a lot. People say, oh, you're an MPC wallet, we got MPC, we're good. It should be more than just that. We got a firewall, we're good, right? It's more than that. Partner with security and cryptography experts to help you focus on your core business, right? You're trying to onboard users, you don't want to worry about this. There's resources out there. And when it comes to end users, right, this is something we didn't talk too much about, but if you don't understand those trust assumptions for your users and being proactive with addressing those, then that can put you in a very challenging spot once that trust has been lost. Okay, so what about account abstraction? Yov did a great job touching on this a little bit. One thing to take away is that every account abstraction-enabled wallet requires to be deployed from an EOA, and an EOA may or may not be part of the signing scheme of that account abstraction-enabled wallet. So you want to make sure that, again, MPC, we think that MPC plus account abstraction is really the way forward. I call it a match made in crypto heaven. So that wraps it up. If you guys are interested in building with Fireblocks non-custodial wallets as a service, we have free sandboxes, so you can go and sign up. Don't have to put in any credit card information, anything like that. You can get in, start building. And you can find that right there on our website, noncustodialwalletdevelopers.fireblocks.com. Feel free to email me directly if you have any questions or need any help. And thank you very much.
And how can I? How can I?
We don't ever.
Yeah.
Okay, try a different. Oh, here.
Hello, everyone. Thank you for joining us here at the Trident stage of ETH Denver 2024. I'd love to welcome our next speaker. Her name is Yeah Wong. She's a data scientist at EigenFi, and the talk today is titled "The New Era of Transaction Observability." Sorry.
Yeah, it's fine. So, hi everyone, I'm Ye from the data team at the EigenFi. So today I'm gonna share with you the recent findings from our team on the battle of backgrounding the private orders and how the transaction observability on Ethereum may impact the distribution of MEV revenue in the whole supply chain. For those who may not be familiar with the idea of private orders, you may probably hear of the following products here that provides MEV protection services, like the Flashbot Protects and like map blockers. What the idea of private orders? So basically on Ethereum, the user transactions may face the risk of MEV. So these types of products, they may provide services for users to choose to submit their transactions directly to the builder's private RPC. So this means that these user transactions may not be seen from the public, and then this can prevent those user transactions from running MEV. And currently, the data from Flashbots shows that every day about 10% to 20% of all the user transactions on Ethereum are sent to the builder's private mempools, which means these parts of user transactions cannot be seen by the public. So when we have a basic understanding of what our private order flow are, so we can go through about the several questions that you may hardly think of it before. So first of all, imagine that when you are trying to submit your transaction to the private order flows, do you know exactly how much value that can be created from your privately submitted transaction? And also, if I told you that there are some MEV opportunities that can be found inside your privately submitted transactions, so who can be powerful and who can be privileged to take advantage of these private orders and to try to make profits from backgrounding these private order flows? And consequently, in the supply chain, whose revenue was taken from during this process? And for the last question is that, so if there are only a small parts of players in the whole supply chain that can utilize these private order flows and try to make profits from backgrounding these private orders, what will have impact on the whole MEV ecosystem? And will we go to like a world towards MEV utopia or MEV dystopia? So within these questions in mind, so let's start from the idea of so-called transaction observability. So it derives from the idea of the public transactions and private orders. So basically, if a user wants to submit their transactions to the builders without any other specific settings on Ethereum, their transactions may probably enter the public mempool. So in the public mempool, it means that everyone can see the transaction in the public mempool, as well as for the searchers. So if the searchers, they find that there's some MEV opportunities that are in the user's transaction in that public mempool, so those searchers can take actions, right? They can try to background or front run your transaction. So for the users, they may face the risk from front running. So front running might be harmful because the searchers, they can submit a transaction before the user transaction. So the users have to pay more about their swap and at a higher slippage rate. And for the backgrounding opportunities, this may be a little bit tricky for users because sometimes the user may even not recognize that their transactions can create such a huge MEV opportunities for searchers to make profits. So, for example, if a user has made a swap on a certain liquidity pool that create a backgrounding opportunity for searcher, this revenue from the MEV cannot, paid back to the users. So users cannot get any MEV kickback from the backgrounding transactions. And imagine that if the user submitted their transactions to the private channels, so things will change. Because the users can choose to send their transactions to several builders specifically. So only the selected builders can see their privately submitted transactions, which means searchers cannot see these private orders. So this can protect the user transactions from front-running MEV. And as for the backgrounding MEV, there are some order flow auction mechanism also provides the users an option that you can submit your transactions to the order flow auction clients, and the searchers can bid for the backgrounding opportunities from the user's order flow. And then, if there's any MEV revenue that can be extracted from the backgrounding transactions, the users can also benefit from this backgrounding transaction, which means they may get some of the part of the MEV revenue from the backgrounding. So let me explain by detail. So basically, we have 3 types of private order flows, and these private order flows are exclusively visible to the builders. The first one is what I mentioned about is the MEV protection RPC. So basically, these user orders are sent directly to the builder's RPC. And the second type is the order flow auction RPC. So these types, via these types of channels, the user transaction are submitted to the clients, and searchers can bid for that user transactions. So once the searcher included the user transaction, and they can redistribute the user transaction in a searcher bundle and send to the builder's RPC. And the third type is basically the searcher bundles. It's like because the MEV searchers, they rely on a bundle mechanism. So once they find there are some MEV opportunities that hidden in the user transaction, they can choose to include the user transaction in their searcher bundles and then send this bundle directly to the builder's RPC. So when we get a basic idea of all the private order flows, we can call back to the first question. So do you know exactly the value of your private order when you send in your transaction to the private order flows? So we found that actually there's a large cake for backgrounding those private order flows. And these parts of MEV value has been largely ignored in the past. As we have observed that there are more and more MEV bots, they are shifting their competitive focus from bidding for the transaction orders in a block to the compete for the transaction observability. However, we found that although this, from backgrounding these private order flows that can be huge MEV potentials, these backgrounding opportunities are found exclusively available for a very limited amounts of players in the market. So how it happened and how the private orders create exclusive MEV opportunities for searchers. Like if for the searchers who want to background the user transaction in the public mempool, so they may face intense competition to bid for the top of the next block opportunity. So they have to pay high bribe payment to the builders, and then these parts of value will flow to the validators in the end. And for the searchers who can have the privilege to background those transactions via private channels. Because there are only a limited players can see these private transactions, so backgrounding opportunities are less competitive, and only a few of the players are, trying to backgrounding these private transactions. So they may not, these builders, these privileged searchers may not have to pay such a large amount of the gas fee or cost for bidding these MEV opportunities. So for those privileged searchers, their costs are pretty low. And I will explain this into based on these several types of private order flows. Because that the user orders sent via protection RPC are of limited disclosure of the data sources. So we will mainly focus on the last 2 types. The first type is the user orders sent via order flow auction RPC. And we will see an example from of the backgrounding private order flow via order flow auctions. So here's a list of transactions in a block, and for the position from position 3 to position 5, it was a MEV share bundle. So it includes three transactions, basically. The first one is a user swap, and the second one is the order flow auction searcher's backgrounding of the user transaction. And the third transaction is a builder refund. So the builder transfers some parts of the MEV value to the user in this whole bundle. And we found that interesting. Yeah, something interesting that at the position 10, it was another background targeting this MEV share bundle. So it's crazy because the MEV share bundle is privately submitted, right? But this transaction are targeting the user transaction in this map share bundle. And let's see how it happened. So first of all, basically in this map share bundle, we can see the three transactions. In the first transaction, the user tries to swap ETH for ELIT based on a Uniswap V2 pool. As you can see, this pool highlighted in orange. So the user swapped WETH for ELIT, and then the searcher in this order flow auction mechanism sent a backgrounding transaction targeting the user transaction, which made a reverse swap in this same pool, in this Uniswap V2 pool. So basically, these backgrounding transactions are swapping ELIT to WETH. And then in the third transaction in this bundle, the builder then directly transferred the ETH to the user. So this is a builder rebate of the parts of that shares part of the MEV value to the user. So this is typically what a map share bundle works like. And then let's look at the backgrounding targeting this privately submitted bundle. So for the order flow auction searcher's backgrounding transaction, as we talked previously, it made a reverse swap targeting the user transaction, right, from ELIT to the WETH within this Uniswap V2 pool. And for the backgrounding these private orders, we can see that the MEV bot also took advantage of this Uniswap V2 pool. It made a same direction swap just like the order flow auction searcher. So it also backgrounds the user transaction in that map share bundle. But for the order flow auction searcher, they have to pay parts of its MEV revenue back to the user. But for this backgrounding of the private order flow, this searcher here, all of the MEV revenue are taken by the searcher. So you may have questioned that how to make sure that whether this backgrounding transaction targeting this bundle are really targeting this private order. Will it be like, will this searcher see any on-chain signals previously and then make a background? So we can do a very simple check by using the transaction simulation. So we can see that on the position 10, as what this transaction happened, it will be successfully executed, right? But if we position this backgrounding transaction in front of the privately submitted bundle, what will happen? So if we position this transaction at position 2, it will be reverted. So it will return a reverted fail message. So we can say that before that MEV share bundle, there's no arbitrage spaces for those MEV bots to make profits. And this backgrounding transaction is exactly targeting this privately submitted bundle. And here's another example targeting the searcher bundles, specifically targeting a sandwich attack bundle. So here's also a sandwich attack bundle in the block. So it will be from position 0 to position 3. It also includes 3 transactions, right? For the first one is the front running, and also the second one is the victim's transaction, and third one would be a backgrounding transaction targeting the victim's transaction. So it's a very typical sandwich bundle. And then, soon after this bundle, we found that there's also a backgrounding transaction targeting this sandwich bundle. So let me explain this in a simple way. So let's only look at the backgrounding transaction from that sandwich attacker. So we can see that that attacker utilized the pool of this USDT and WBTC curve pool to make profit. And let's see what that private backgrounding transaction of this private order flow have done. So basically, the MEV bot also took advantage of the same curve pool. It also made a same swap, just like the sandwich attacker do. So in this way, these searchers can take advantage of those privately submitted bundles or private transactions to make profit without paying a high cost for the builder bribe and to the downstream. So it's more important to think about who is privileged to background these privately submitted order flows. And in the supply chain, whose revenue was taken. So we can see that basically we found that these searchers are privileged because they have collaborated with the builders. Because only builders who receive those private order flows can have the privilege to knowing which orders will appear in the next block. So those vertically integrated builder searchers can take advantage of this transaction observability and make profit from backgrounding these private order flows. And then when backgrounding these private order flows, they need not to pay high bribe payment and high gas fee to the downstream. And then, in this way, they can reclaim some MEV revenues from validators in the downstream. So as we have investigated from October to November in 2023, we found that in the whole arbitrage market, there are over $7 million in revenue were generated, and over 18% are generated from backgrounding the private orders. And more impressively, we found that if we break down the revenue structure, we may find that backgrounding private order is super cheap because only 30% of the whole revenue were paid for pay as cost. And for other types of arbitrage, searchers usually pay over 90% from their whole revenue as MEV cost. So in this way, we may say that for backgrounding those private orders, some of the profits that would be flowed to the validators are taken from these vertically integrated builder searchers. And then let's come to the last question. So what will happen if this transaction observability as a competitive advantage continues? So we found that those vertically integrated builder searchers may take advantage of the transaction observability to background private transactions without paying a higher fee and then get some of the value from validators. And also, they may not follow the same rule as those order flow auction searchers, and they need not to pay back MEV revenue to users. And also, it will redistribute the MEV revenue throughout the whole supply chain as the validators are getting less than the past. And also, so if this circumstance continues, we may face the threat that falling into what Stephanie calls a so-called MEV dystopia, where a few amounts of players in the market may take most of the MEV revenue. And they can take those transaction observability as competitive advantage and set higher entry barriers. So I think it's time for us to reconsider these circumstances and take possible solutions for that. And so much for today's sharing. So if you are curious about the cases that I mentioned today, just feel free to scan this QR code to read a full research article that written by our data scientist, Sophie. And we are also welcoming all the discussions regarding the MEV issues and also regarding the whole supply chain. And so much for today's sharing. Thank you again. I'm Ye from Ironfly. Thank you.
Okay,
Ah, like that. Got it.
they want it right up on your face.
You getting anything?
All right, hello everyone. Welcome. Thank you for joining us at ETH Denver 2024. This is the Trident stage. Thank you so much for being here. We have a really exciting panel titled DAOs, Taverns and Town Halls. We moderated by Bill Warren, head of product at Summon. We've also got Charlie Blackstock, co-founder of Gamer.xyz, Anjali Young, co-founder and CCO of Collabland, Alex Poon, CEO of Charmverse, and John Allen as well. So thank you so much.
Thank you, everybody. Welcome to our game show, Taverns and Town Halls, where our contestants will compete for the best answers. But thank you all for being here. It'd be great if each of you did just like a 2-second intro of yourself and kind of your role in the DAO space. And we'll start with Anjali and just work our way back.
Sure, welcome everybody. So happy to see you. What a great crowd we've got today. I'm Anjali Young. I am the co-founder, like Bill said, of Collabland. We started off as a DAO tool back in May of 2020 and it have grown since then, but are the creators of token gating on Telegram and on Discord, and now on web apps and on websites.
Well, down for 100. So I'm Alex, co-founder of Charmverse. We are a Web3 community management software that also get used by NFT communities, refi communities, and also foundations, grants organization. So really it's about the town hall side of getting people engaged in voting, getting together, and making decisions.
Yeah, my name is John. I'm one of the co-founders of Game7, the largest gaming DAO. We're extremely excited to basically be the hub for gaming to support gamers in different areas and also help with push standards, best practices. I'm also one of the co-founders of Summon, which is a community management tool that really seeks to kind of be the glue to bring a lot of these fantastic community tools together that we'll probably be speaking about today.
My name's Charlie. I was the co-founder of Gamer.xyz. Now I run a product called FarWorld on Farcaster, so you'll be hearing a lot of Farcaster takes from me today, but excited to have you all here and share a lot of stuff we've learned over the last couple of years.
All right, thank you. So I think we're going to start out with the question of what's the best mix of taverns and town halls? And just to give the audience a little bit of context and background here for the language we're using, we're thinking of taverns as those digital spaces where people are boisterous, the conversation is pretty free-flowing. Think like a Discord or Telegram channel, versus town halls are often the places where governance decisions and conversations are happening, mostly discourse or charmverse. So I think, John, we'll start with you and ask, what's the best mix of tavern and town halls for a community?
Yeah, I mean, it's a great question. I wish I could be like, here's the exact structure, but I think what's like so cool about this is that we're seeing a bunch of different iterations and experiments on what the right balance is. For me, I think there's like a couple prongs that I kind of analyze it on. It's like one, kind of like what is the general sentiment of your community? Like for me personally, I prefer the town hall because I like asynchronous. I like things more organized. I'm not constantly there. Whereas I think a lot of people like that tavern. They like to be boisterous with memes, really loud. They're constantly there. It's like more synchronous, kind of like real-time communication. So I think it's like kind of like, you know, you have to consider what your community is, kind of what their personal preferences is, and then you also have to figure out what is the mandate of your entity. Are you trying to just be more of like a social gathering, sentiment, really retail focus, or are you really trying to get things done? Do like really tangible decisions have to be made to like for you to be successful, right? So, I know that's really a non-answer, but it's really a case by case. And what's fantastic is there's a lot of great implementations of each of these kind of tavern and town hall-esque tools, and just pairing that together in thoughtful ways is something that each community manager really has to do themselves.
That's great, but we will dock 100 points for the non-answer. Anjali, so Collabland for several years now has really served almost like the bouncer for the taverns, the Discords, the Telegram channels. How do you all advise the communities using Collabland to maintain kind of a lively atmosphere, but also keep the trolls at bay?
Yeah, that's actually, I come from digital communities before crypto, as an admin and as a mod for many digital communities, mostly around international adoption and homeschooling. That was my previous iteration of my life. I was a full-time caregiver to my children. And the amount of troll management that we do now and communities have to do now is so much less because of token gating, really. Like, people need to have they have to buy in, right? Like, they've got to have skin in the game. And once they do, then it makes it easier. As far as like how to keep it fun, how to keep it interesting, like we're also a distributed team. And so much of what we do obviously is work. However, without that time, social time built in, like mandated social time where we're getting to know each other, we notice the difference. If we don't take that time, if we don't take that Friday time to play a game together and get to know each other a little bit better, kind of keep tabs on each other, how people are doing socially, it makes a tremendous difference on how much work we get done the next week. So taverns and town halls have to work hand in hand. I mean, we're all separate, right? We're here at ETH Denver. I mean, it's so important for us to all be at IRL events. Like, I love being able to hug you and give you a kiss on the cheek. Like, it matters because the next time we talk, we have that now. So, of course, IRL relationships are super important. However, when you don't have that, you still have to have the tavern. Without it, like, you get less work done. You need to be able to know where people are coming from. So one thing we tell our admins and mods is, like, commit to a calendar. Commit to a content calendar. If you show commitment to your community, then they're going to show a commitment back to you. So I could go on and on, but I'll stop there.
Yeah, that's great. We'll give you 50 points for that answer. Moving on to Alex, in some ways, Charmverse is really meant to be the town hall, or if not, fight back on that. But how do you make sure that conversations are getting to the town hall? How are you all advising communities to use Charmverse's proposal system and forums to really come to good consensus decisions?
Yeah. So I came from Web 2, and I remember like 10 years ago, I wrote a blog post about complaining how many messages my team is sending over in Slack. I think Slack sent me an email saying, like, congratulations, like, your team had wrote 100,000 messages or something like that. And I was like, that's 100,000 messages of almost too much. So I think to me, like, yeah, it's deeply important to me that finding a place where, yes, people building relationship with your coworker, with your community is important, but also having a place to help you focus and get the important things done. So yeah, as we enter Web3, just seeing all these messages in Discord, and we find it challenging. And I think what's important is having a dedicated place that people can be orienting themselves to, like, if I am here to submit a proposal, to discuss a proposal, or I'm here to apply for a grant, you want to just communicate only thing about the grants, that's a place to go to, and not being dropped into a forum and trying to figure out like your way and trying to search and spend an hour reading everything just to find that one place that you wanted to figure out what's happening.
That's great, and I'll drop the game show shtick at this point, but Charlie, as the Farcaster maxi on the panel, where does Farcaster fall in all of this? Is it going to be a tavern, a town hall? Like, what's the future of this kind of like crypto darling of the moment?
So that's a good question. So, like the difference for me for town halls and taverns is like town halls is a great place to like get things done and be organized, but they really go hand in hand with taverns, which I think is a great place to build community, build identity, build memes, and I think those are all so important in DAOs. I think having like a culture of identity is really important, and I think it's something that extends. You just see flavors of it across chains, across apps, across currencies, and so I think town halls and taverns really go hand in hand together, and I think you really need both. And Farcaster is doing a really interesting job with one of their primitive features of Farcaster is things called channels, which are very similar to like Reddit channels, and they have a lot of NFT and gated features built into it. So I think those really fill the need of a tavern. This is where everyone's hanging out, they're talking about your product, they're sharing links, they're sharing frames. Frames are like little mini apps that get built into Farcaster. So those serve as a great community building like feature. And then we're actually using token gated groups, so you can actually create groups of people with NFTs, and those end up serving very much as like a town hall, where you just limit the people who are participating and try to have a lot more organization. So that's kind of like the use cases right now, but I think Farcaster's working on a lot more primitives outside channels that I think will continue to add flavors and ways to bring a lot more governance and organization to groups of people.
That's great. Yeah, and I think for taverns, the important part is kind of having a bouncer to keep the trolls out. But for the town halls, how do you make sure that you're balancing getting the most educated, high context people participating in those with also not excluding the gen pop, so to speak? This question goes to John.
Yeah, so I think it's a great question, because it's like trolls is a big deal, right? On the one hand, they're some of the most engaged people you're ever going to have in your community, but a lot of times they can be extremely disruptive. So I think there's a couple considerations I think is interesting. Like, it was already mentioned, right, about like just token gating something. That's really easy to make sure somebody has skin in the game. Oftentimes when you're like, hey, if you hold at least one token or one NFT, that'll exclude a lot of people, because at least they have some skin in the game. Like, it's very easy for people to be extremely negative when they don't really know about something or they just have a cursory understanding, but they've actually bought in a little bit. That screens some. That being said, very motivated trolls, it's not that hard to buy one NFT oftentimes, unless it's prohibitively expensive, so you'll still get them. I think kind of the other consideration is like, how do you kind of, one, use reputation to inform a better understanding of, should I be listening to this troll as much? Like, obviously, if they're a massive whale in the community, they have a huge amount of skin in the game. You should probably listen. They're probably not trolling themselves, right? There's probably something there that you might want to unpack. Maybe you don't agree with it, but you should definitely consider it. I think the other piece of it as well is there's some people who maybe don't have that much skin in the game, right? They're just constantly being negative. One of the things that I found very interesting is that there's one community that I was a part of, and we had one or two people who were like just constantly negative about things. And what we ended up doing was we ended up pulling them in and being like, hey, we would like you to start an ambassador program to improve the community. We're going to give you a tag on Discord. We're going to have like little meetings with you, right? We're going to kind of like involve you. And the craziest thing happened was all of a sudden they were the biggest advocates for the community. Other trolls came in and they were like, hey, no, like, let's have a one-on-one, let's talk, and they actually like, trolls converted to the best ambassadors that I've ever seen, and actually
well, they're passionate, right?
Exactly.
They're already passionate, and that is what we're all needing. Like, apathy is the killer, right? And so if they're passionate, you can turn them around.
Yeah.
Yeah.
Yeah. No, that's fantastic, and I wanted to follow up with Anjali and how does Collabland, one, empower communities to deal with trolls, and two, kind of what do you all do to help those communities manage trolls? Like, can you boot people with Collabland? Can you take away NFTs? Or is it really up to the community to kind of use your tool as they see fit?
Yeah, we cannot take away NFTs. Yeah, people ask all the time about that. No, we cannot take away NFTs, but you can ban people. And the beauty of it is with token gating, yes, you can ban them from access to your group if you're not behaving in a way that is conducive and constructive for the group, but we're not taking away their NFTs, right? Just because you're losing access to the community does not mean you're losing access to the value that's being created from the community. And I think that's what makes this world, right? Crypto, blockchain, whatever, NFTs, assets, so different and unique. It's like you do have to behave within the rules of the community, but that doesn't mean you lose your financial stake in it.
Yeah, no, that's great. And I guess, Charlie, back to you. Where do you see Farcaster, I guess, going in terms of adoption, and what communities are joining, especially in the gaming space? Is there a future for Farcaster, or is it a little bit kind of like flavor of the month in crypto, which we do a lot of that?
Yeah. I was talking to someone else about this. If you're not immediately skeptical by like something that's getting a lot of hype in crypto and it like kind of bursts onto the scenes, you haven't been in crypto long enough. I feel like we see these things all the time. Like something blows up and there's so much FOMO and so much hype. And like, if you don't come into that with like an immediate lens of skepticism, you will. If you're in the space for long enough, you'll get burned enough times. You'll back a project that was a rug. Like, there's just a lot of stuff that gets built in this space that ends up not fulfilling its initial promise. But I do think Farcaster stands above that. I think Farcaster is one of those things that I tell a lot of people, it's the most excited I've been about a set of technology since I went to my first Ethereum meetup in 2015. I think some of the stuff that they're building as like the primitive layers for social engagement, it rivals the technology of like smart contracts. And I really do think it's going to completely change how a lot of apps work on the internet. And so I'm on the Farcast Maxi is bullish, big surprise. But I do think that it has a lot of core primitives of things that take a lot of effort to do with the current tech stacks. Like a lot of what we do on the internet is just navigating a social feed and then constantly getting redirected to other apps. And apps that make that process more seamless and more interesting tend to do better. But on Farcaster, you get to do a lot of stuff within the feed and within the forum and in the context that is most interesting. So no, I don't think it's a fad. I think it's definitely here to stay. And I feel like we're going to start seeing a lot more builders and a lot of people looking for really great integrations to leverage the distribution that you'll get through something like Farcaster.
Yeah, and I guess maybe just to tack onto that, because it's like for us, we've done a lot of work with like the Twitter integration, and we start looking and we're like at scale for a community to do something thoughtful and engaging on Twitter. We're talking like 20 to 30K a month API access for Twitter. We look at Farcaster, it's run a node. And if you start thinking, okay, what if we redirected that maybe in half, 10 to 15K a month into actually developing things for Farcaster? That's why I'm really excited about it, right? Like by having that kind of like open protocol and allowing like this kind of like flexible like kind of client, or even build your own client on top of it. It's really leaning into the reason why I got into Web3 was because like we don't want to be limiting the creativity of people that we're working with or the community that's around us. I mean, just adding on to that, I'm also bullish Farcaster.
Yeah, I'll add on Farcaster too, since we all talk about Farcaster. So we took a totally different route. We actually made frame available in Chamverse, so you can actually embed the frames. So in a way, like instead of putting the information into the feed, you can now actually take the frame into Chamverse. So then, if you build Farcaster frame that is disappearing in the feed, you now have a place to store your frames and discuss the frame and share people the frames that you build in Farcaster. So kind of go both ways.
That's really cool. And just a little more context, if you're not aware, Farcaster frames are just like a base set of code that allows you to build essentially like mini applications within Farcaster. So imagine scrolling through a feed and then an item shows up that's basically like a little mini app that has some constraints. So
yeah, and Anjali, I'd love I always think of Collabland as the OGs of mixing crypto, blockchain with social spaces and gating them, probably just because that was like I think I was part of one of the first experiments in Metacartel of token gating a channel in Telegram. How are you guys thinking about Farcaster or the future of social in the space? Like, where's Collabland's mind at around all this?
Yeah, it's a good question. We're still so early. I'm excited about Farcaster. However, we've also seen other Web3 native platforms come and go. So I'm excited about Farcaster. It's got so much great stuff. Like, I was at 2 different Farcaster events in Paris last week. I love the people there. Of course, they're wonderful, and I'm excited for Farcaster. I hope it makes it. However, it's still early. I think there's still a need to be in places that are more Web 2 focused to onboard more. So it's like filling 2 separate niches. We've got Collabland, like we're on Telegram and Discord now. We're looking at other platforms as well, Web 2 platforms, for a larger group of people to enter, right? It's like top of the funnel. But for everyone to eventually go to Farcaster, or once you're more sophisticated enough and you're more involved in Web3 to move to Farcaster, I think that's great. So I think there's room for more. And so our approach is still more at the mass onboarding stage.
Great. No, I love that. And to go back to Chris a little bit and shift towards the town hall, since I think we've talked a little bit more about the taverns so far, how do you get attention to the town halls? Traditionally, and maybe other than John, people resist residing there because it's not as exciting, it's not as fun, and it's meant to be serious and thoughtful conversations, not just kind of like meme posting. But how do you make the experience engaging so that it gets the attention it deserves?
Yeah, so put on my product hat a little bit, right? So instead of counting daily active users, our North Star is more weekly active or monthly active users. Partially for that reason that we don't expect people to come and socialize on a daily basis or multiple times a day compared to your Facebook, your Farcaster, your other social platform, right? So I think the key is having those. You came to Charmverse for a reason, right? Like you're not really here to hang out. You're here to either have a serious discussion about a certain topic, you're here to apply for a grant, you're here to check on the proposal that you submitted, or having these structured discussion going back and forth. So I think it is much more purposeful. And I think with that I think a big part of it is earning your reputation, building your reputations, so that because again, this is something that you are building toward something, and having more that higher influence and decision making along the process of the community. I think that's what get people coming back to contribute to the community in a little bit less exciting manner, or less fun manner, perhaps.
So does that mean that the future of DAO governance, especially in the town hall, looks closer to the IRL town halls, where it's mostly filled with elected officials and occasionally some old retired folks that come yell at them?
I mean, I think partially is that, but I think it's more about people who write proposals, people who submit for grants or RFPs and so on. They care deeply, right? They care so deeply. They spend the time to write this 1-page, 5-page thing that they show up to. Maybe this is people that are retired, but also that I think it fundamentally people who care deeply about the community that they're showing up for. And I don't think we should demand that every single person you just happen to hold an NFT or part of the social conversation to also have to read your 3-page proposal and vote on it. I don't think that's reasonable.
Yeah. So John, direct democracy or something more like a republic?
Yeah, well, it's to kind of go back to your first question, right? It's does it look more like these elected officials, right? Or does it look more like this more direct democracy? I think blockchain and DAOs and a lot of these structures make it a lot more efficient and easier to do direct democracy. The problem is always people who spend time, who's actually going to read and understand kind of that problem. And so what you're already seeing is even in these more direct democracy approaches for a lot of these decentralized communities, that it's kind of how do you describe it? It's more kind of like signaling from the people who are very well known in the community, right? And even for elections, oftentimes it's more of a popularity contest. So one of the things that I'm like a huge advocate of is just like having it be much more meritocratic, where it's not like a popularity contest. It's not like the person who has the most kind of followers on Twitter or X, at this point. It's really, you can granularly understand what have been their contributions to the community, and based on that standing, I think that they should have more autonomy, more agency to like help represent or be elected ideally. But I do think that we start to trend toward some people are either elected into position to make decisions, or people are just seen as kind of like signals for the community that they're like, hey, here's the reasons I'm voting this way, and people oftentimes trust them. Because like we can try to make things more efficient and more democratic, but at the end of the day, I mean, like not 100% of your community is going to read the 10-page proposal. They're not going to follow the entire discussion. They're not going to have the context, right? And so I think for me, it's like that battle between how do we basically make things more meritocratic so that ideally we have more of those high signal people and more of those people who are maybe elected actually deserving to be that status, and then how do we make things more efficient, more digestible, more easily kind of like available to the general community so we can have more direct democracy. But yeah, for me, it's meritocracy, kind of reputation. That's like, I absolutely love that. I'm a huge proponent of it. So yeah.
I got a plug for AI there. I mean, really, that's how it's all going to come together, right? Like, how else are you going to get all that information distilled for everybody? Like, that's a natural fit.
Mm-hmm. So you stole my next question,
sorry.
which is great. No, I'd love to keep exploring. Is like, obviously AI is another topic du jour and more of the kind of broader zeitgeist outside of crypto. How does it change DAO communities? How does it change what, sorry to do more of a down the line question. How does it change what each of you do, both to kind of like help people digest more, but also is there a downside of like we're playing into people's laziness even more?
I will tell you, last year at ETH Denver, we had a bounty, and the winner of the mini app was an AI mini app. And it was, at that point, you weren't able to just put documents up into whatever ChatGPT and have it respond. So it's a mini app where you can put in your documents, and that way it helps with onboarding, because mods and admins are completely drained from answering the same question over and over and over again. And so even with that, like wanting more people to participate, you need to have that information available, and being able to say, like, what is the sentiment of this group right now? I'm joining this new group. I want to know what are the popular topics that are happening, what are the conversations, and what has been the mood over the last week or two. I mean, like, you're going to be able to get so much more information that way, which is going to encourage more involvement. So it's kind of an exciting thing. I mean, as far as downside, I don't know. There's a lot of downside, but for what we're talking about here, I think it's there's a lot of upside.
Nice. So when the Terminators take over, Alex, how are they interacting with Charmverse? What's the kind of future of AI there?
So there's a lot of excitement around text generation and summarization, but I actually think in terms of community, what's more exciting about AI is like really gleaning the contribution and interactions of people and how they're really contributing to the community, being able to pull out those minor interactions and not only using like the most basic signals like someone saying GM or whatever. I think like that's where it gets interesting of like helping find those people who should be more involved or can more influence in the community. And then I guess the AI overlord can find those people and talk to them.
Yeah, Charlie, we'll go to you and then finish up with John. Does AI ruin Farcaster? I mean, in many respects, blockchain is somewhat the opposite, and it's all about self-custody, the human layer interacting as yourself or pseudonymously owning your identity, owning your own money. Like, what does AI do to something like Farcaster?
Well, I think the underlying like niceties of Farcaster is like guaranteed cryptographic proofs that message came from someone, because it is like a decentralized blockchain and decentralized data. So I don't know if like the world's quite ready for just how much content is going to be made over the next couple years. This election cycle is going to be absolutely nuts. Like the amount of propaganda and just insane stuff that's going to come out over the next 6 months, I just don't think we're ready for. And being able to tell where that information came from and being able to quickly verify that it's authentic is going to be paramount. And so I think AI lends itself really well to a social graph or a social media network that has more cryptographic proofs that you're seeing a video from someone that isn't a deep fake and is real, because these things are going to be impossible to distinguish in a very near timeline. And so I think social networks being built on blockchains are going to be critical, because there's going to be way too much content. It's going to be way too hard to verify all the sources. And so you'll need signatures, and you'll need more cryptographic proofs of that data or content that you're seeing is from the person you think it is. And that's going to be a real challenge on like Twitter and X over the next 6 months. This is going to be in a crazy election year for a lot of reasons, unfortunately. But content's going to be one of those things.
Yeah, and I guess, John, what does AI do to that meritocracy where you're trying to find the best people for the town hall, but all of a sudden now you can have ChatGPT write your proposals and make you seem kind of smart?
Yeah, because I think it's like there's two things. When I think about AI, right, like obviously there's a lot of stuff moving very fast, right? So it's like I think they maybe start off on the stuff that I'm excited about. It's like one, being able to synthesize a community's kind of like content. Most people have documents like here's our shared ethos, our values, like our documentation, like getting people spun up very quickly, and then having a bot be able to engage those people and spin them up. It helps because like there's only so many ambassadors at scale, right? And so I think like as far as kind of like making people feel more welcome and getting spun up more quickly to like self-select into maybe like a larger role kind of within the community. That's something I'm really excited about. I also think that like from a community manager standpoint, being able to kind of like measure sentiment, like as mentioned, right? Where it's like, if I could see the snapshot of all 9,000 messages and be like, hey, people are generally kind of pissed in my community and it's about this keyword that keeps coming up, I think that's compelling. But directly to your point, the thing that I am concerned about is that, if you look, it's bots is always a problem, right? When we're trying to figure out how to make some Sybil-resistant system, it's just this constant game of cat and mouse. And so I think really identity and reputation and kind of like effort is a really important piece of that. And so I think right now we're thinking of it in kind of like one way, but I think as AI becomes more ubiquitous, it's like, when you can train an autonomous agent to fill out a type form, to be very engaging, to write a proposal, to write a really thoughtful kind of like, rebuttal against somebody else's proposal, right? It's like, it's going to get very odd, when it's like, how do you kind of distill down from the average very motivated community member and the average very motivated autonomous agent, right? And so I think it starts to get a little bit weird. It's something that we're watching, but I think we're all kind of seeing it unfold together, so.
Yeah, I think it's particularly, this is a unique thing in crypto, that there's such an incentive to pretend to be an engaging member because you're farming tokens and you're hoping that you'll get token. Like of course there are bots and trolls in Web 2, but like just the magnitude and the sophistication, it's so different in crypto.
Yeah. Yeah, and I think that's for us. It's like it's really been predicated on like engagement, right? Because it's like I think a lot of people are like, hey, if you have kind of like this token or you do this KYC process or but it's like it's really just a game of cat and mouse, because it's like as soon as people start using that and they're like, hey, this is a very good Sybil resistance method, there's a market for that immediately. People are like, oh, I'm willing to sell my token. I have this. I don't care. So it's like it's this game of cat and mouse. And so I think the way that we're thinking about it is like if you can granularly kind of like measure and reward and incentivize engagement, you're kind of continually moving like that line of like where people need to be, right? If you're continually allowing them to engage and kind of like you're seeing kind of what their engagement has been in a granular way, then sure, with enough time and effort, this is why we're calling it Sybil resistant instead of Sybil proof, right? Unless I'm like standing right next to you, and seeing you kind of engage, it's like really hard. So anything digital makes it challenging. Yeah. But I think like continually moving that goalpost and like having engagement, at a certain level of engagement, it doesn't really make sense for somebody to kind of like try to take advantage of that system. Because I agree, it's like everyone's trying to farm these airdrops, everyone's trying to pretend to be something real. And I think just being thoughtful about the hoops that you're making people jump through is really a problem in a space that a lot of people are trying to solve.
I love the reputation building, identity building, like it's so important, but we're still in crypto, we're still so financially motivated that we have to find some way to like turn identity and reputation into some financial gain, because until that happens, I don't think, like what Alex was saying, like most people are still airdrop farmers. That's just the ugly truth. And so we have to find some way to reward that reputation and identity, and maybe then we'll get closer to what we want.
Yeah, I totally agree, because I think like a lot of like DAOs are predicated on kind of economic contribution, and I think that's like super misaligned, right? Because it's like $1, 1 token, 1 vote. one, maybe somebody invested super early and they have a huge stake, and after 6 months, maybe they're not involved anymore, but
Yeah.
they're still like this like whale, right? And then two, it's people who either invested early or people who have a lot of capital. Those are the people who have say. Where we're like, I think if you predicate it kind of like engagement and reputation, and you start saying like they're the people who have more access, maybe more say, more voting control. I'm not saying it should be 100% either way, but I'm saying we should have a spectrum between those two, economic contribution and an engagement and direct physical contribution, right? And then somewhere on that line, that 60-40, 50-50, I think if we open that up, and like that's a much better model than I agree. Just like I hold this token, right? Or I want this token, right? Because at the end of the day, if you put in 1,000 hours into my community and you want some tokens, I think that's very aligned. Most projects need that
agreed.
engagement. You know, they need some reasonable amount of money, but it's really engagement that I think is distinctly lacking for a lot of these projects.
Oh, that's great. And since we're short on time, final question, Anjali and Charlie, your answers are the most important here. Favorite tavern?
Oh
and
my
you can
word.
do favorite town hall if you really
Wait,
have one.
what? But I can't say my own because shout out to all the Collabland DAO members out there and members of our Discord community. So,
Boom.
I meant literal tavern in Denver.
oh, literal tavern in Denver. I don't know. I have a startup in Denver, so I don't get out much.
Fair enough.
Probably, I like Denver Central Market's a good spot. I feel like there's a lot of stuff happening there.
That's great. Yeah, so thanks again to all our panelists. This was a fantastic talk. Really appreciate you all being here. And if you haven't checked out any of these projects on the stage, all of them are fantastic, doing great things in the DAO space. So please do visit Collabland, visit Charmverse, check out Game 7, and then watch for some interesting experiments on Farcaster from Charlie.
Farworld.gg. That's the next one.
Love it. Thanks, everyone.
All right, thanks. Thank you. Thanks, Bill.
Hands.
connected? On, we're good? Awesome. Thank you, everybody. My name is Greg. I'll be the MC for the last section here. And today we've got Tracy, who's from Pluto, a ZK dev tooling team, and he's going to talk about a very interesting talk today about signal versus noise, and I'll let him take it from here.
All right. Hello, hello. Can you hear me all right? A little bit closer. All right, that looks good. Hi, everyone. So I'm Tracy. Like he said, I'm the founder of a company called Pluto, and we're building a dev platform for applications to add cryptography, which we think brings novel features to those applications. Today I'm going to talk about this idea that's been on my mind for a few months now, which I call signal versus noise. And really the problem is, in the last 5 years, we've seen a rise of LLMs and generative AI that can produce content that's more or less indistinguishable from human content. And I'm going to talk about the solutions that exist today and possibly some ways that cryptography can help with that. And this really started as an exploration into identity and fraud more than anything. But the deeper I dug, the more I thought about misinformation and how important that is to solve as well. Okay, so first off, I'm going to go through a few examples that are kind of coming up recently. So first is real ID, fake ID. Today's KYC and identity solutions like Stripe, Jumio, Persona, they're built on the notion of a valid identity. And generative models have reached a point of quality that they can construct those IDs that are really difficult to tell from a real identity. So this is actually an LLM or like a generative AI model identity. And it was used to bypass some OKX identity KYC. So there are still safeguards. So for example, this has on it like an issuance ID, and you can actually check with a central authority like LexisNexis to ensure that the ID was issued by a government organization. But if you mix this fake ID with like a valid serial ID, you can actually bypass those checks as well. So this is a challenge. Next is real person, fake person. So text generated from an LLM at this point is just indistinguishable from human text. And that's also becoming true of voice and video. And the cost and sophistication to create these fake people is decreasing. And then finally, real media, fake media. So like I was saying, generative AI produces increasingly realistic video, audio, images, and we can no longer trust our human sense to help us determine the truth. So imagine this scenario. You're watching a video on YouTube, and you think to yourself, damn, that can't be real. Like, how would Donald Trump say that? And then you attempt to investigate. You Google, like, did Donald Trump say this? Ultimately, despite your best efforts, you literally cannot tell whether it was real or not, and you give up and you kind of move on with this weird sense like, I don't know the truth here anymore. I'm curious how many of you have had this experience already? Yeah, that's nearly everybody. So just broad strokes, like what is the landscape? There's three big problems. It's fraud, spam, and misinformation. Fraud is typically financially related, so that's about KYC and KYB, and those are the techniques that we use today and the regulations associated with them. Spam is about creating fake accounts and using them to misuse a platform. And misinformation is about spreading information that is difficult to distinguish from real information. Okay, so what solutions do we have for fraud today? Like I said earlier, we have Stripe Identity, Persona, Plaid, LexisNexis, and they're very sophisticated platforms. It's not that they haven't given it a good go. Each of these platforms employs many, many techniques. So today they'll use things like deep neural networks based on videos of a user holding up their license. And the actual goal of that interaction is not just to capture the license text. They're actually monitoring to see the reflection and the sheen on the license, the person picking it up and putting it in front of the camera. All of that information is collected, and it's part of determining that it's a real ID. They also use biometric data, so often if they're asking for a webcam, they're actually looking at your eyeballs as well to try and see if you're a real person. You're looking around the room. They monitor how your mouse moves around a website. They check that parsed identity against a central database. They use really adaptive ML techniques, so emerging threats are kind of constantly happening in this space. It's a game of cat and mouse. And when a new technique comes up, often it's so hard to respond for these companies they'll just like write a hard rule. Like, okay, we see a new technique, it's coming out of Slovakia. It's like breaking through our checks here. Like, let's just ban everybody in Slovakia for the next like week until we can figure out a better way to fix this problem. And they build those into like a programmable decision-making framework. What about spam and misinformation? So a few solutions exist for spam, and we've seen this on Twitter. That's like account gating, paying $8 to get a single account, or Sybil resistance mechanisms like CAPTCHA, and also content moderation, like the infamous horrible job that a lot of Facebook people have sitting around and looking at terrible content. And then on misinformation, there are things like community notes. So having the community try to digest information and determine if it's real, Google fact check, and a coalition for content provenance, which is an attempt by like content creation tools to create a chain of trust from where you created a video to your eventual distribution of it. Cool. And then briefly, the regulation landscape. So there are global regulations in every country that try to put a framework in place for these problems. Here's a list of them. I'm not going to go too deep on regulation, but it'll be in the slides if anyone's curious to look. Okay, so really, I'm posing the question, like, is there a problem? Is this problem solved, or is it an open problem still? And my case is essentially like fraud prevention is pretty robust today, but despite that, the rate of fraud continues to increase. So platforms already have a really strong economic incentive to get this right. There's multiple billion-dollar companies trying to solve it. And the costs are sort of directly measurable. When the fraud rate increases, the revenue decreases. So that one, I think we're doing an okay job, but it is getting more challenging. And then on spam and misinformation, I think this is where there's really an opportunity to do a better job. So historically, misinformation's focused on text. As I said, generative AI makes highly sophisticated audio and video misinformation possible. And today's solutions are really built platform by platform only by the largest organizations in traditional internet, Google, Facebook, etc. They essentially have teams viewing this content, trying to train models to predict whether it's good or bad information. And information is highly subjective, so it's very difficult to determine a sense of ground truth. Furthermore, because they're so specific to a given platform, like say Facebook, they're highly centralized, and it's very difficult if you're a small blog to use this type of solution and have the similar quality of content moderation as Facebook might. And so I propose a few things that are missing from what's out there today. First is anonymity preserving tools for fraud. So today's fraud prevention requires you to reveal who you are. And that involves revealing your PII data to some central authority. I think we're probably going to enter an era of the internet where almost everybody who uses it has to be KYC'd to avoid the spam that's going to arise from AI. The downside of that is it's a very dystopian world to imagine that all internet activity is KYC'd. So I think we need anonymous preserving tools that allow you to use your identity to prove you're a human, but also give you privacy and anonymity. I also think we need universal tools and platforms for misinformation. So as I said, there's no universal truth on information. It's subjective. So each platform has to make judgment decisions, but I think every platform needs access to a tool for making those decisions. And then I also think we need a general solution for spam, but it's almost impossible. Spam and not spam is another subjective challenge. Spam's only detectable when it becomes abuse. The first message from a user might not be spam, but the second might. Okay, so what are some emerging techniques? Like, this is all valid pain points, but we haven't really talked about any solutions. So for those of you who are in crypto, there's quite a few that are up and coming. So one is proof of humanity. This is WorldCoin, sort of scan your eyeballs, determine that you're a real human, give you an identity, and then let you link it into a platform. There are challenges here. There's black markets for identities. People in third world countries may not mind selling their retina scan for $3 or $5. And there's also privacy concerns. Excuse me. We're trusting WorldCoin a lot to use that information and protect it. And despite their best efforts, you may have a security leak. And in the event of some exploit in their stack, extremely sensitive personal information can end up on the internet and never be put back in the box. So I think it's a legitimate concern. I don't know if those of you have paid attention to the DNA processing 23andMe. They recently had a scandal where they were selling like DNA sequences to third parties, which is kind of like permanently revealing information about you to the state or whoever's buying that information. Next possible techniques and solutions are signed identity documents. So I don't know if everyone knows this, but inside your passport is an NFC chip. And on your NFC chip is a signed attestation from the government, private key, about your information. So this can actually be a really powerful source of identity verification. You could tap your passport on your phone, extract that signed information, and have a pretty robust source of identity. And then the final is just composable attestations and reputation. So if you can take these attestations from a few sources, proof of humanity, a tapped passport, maybe some personal information about where you live, your tax returns, etc., you can compose these things together and maybe layer on some social reputation. You might be able to make a pretty robust artifact about your individuality and your proof of humanity. And then on misinformation, some emerging techniques. So one is attested sensors. That's microphones, cameras, location data. You can actually, in the hardware of the device, create a signed production of content and use that signature to verify that it came from a trusted public key. So influential figures are probably going to start publishing most of their content from signed devices only. And recently we saw the White House announce they'll start doing this in 2024. That helps, but it doesn't actually solve the whole problem. A big part of content production is the initial production, but then the editing and modification of that content. So we've also seen a few cool hacks around verifiable modification of content, cropping, resizing images, while maintaining proof of provenance. So checking inside of a ZK snark that it came from a signed source, transforming it inside of a snark, and then producing a proof that it was transformed correctly and it was the signed data that was input. There was a cool hackathon project at Stanford Hackathon for this. And another one is this cool idea called perceptual hashing, which is taking an audio, or not necessarily audio, a video or photo, and hashing it to check the similarity to a prior video or photo before cropping, screenshotting, or modification. There's a paper from Apple called Neural Hash, and it offers relatively robust hashing across transformations. So you might take an initial image, screenshot a piece, take it out, and then compare the prior and the latter perceptual hash and get like a 90+% positive ratio, which can help to detect that the content derived from a valid source. And there's actually a team, Morpheus Labs, who just did some work on this a few days ago. Cool. How do these all help? So really, if you think about it, like I said at the beginning, the goal is to only have 8 billion human actors on the internet, at least in a setting where other people are consuming that content. It would be great if you could sort of binary know it's coming from a human that's a valid source. And if you could, from these actors, derive a fair reputation score, you may be able to remove some of the noise from the internet. It's also important, like I was saying, that the classification is robust and forgiving. If we have one person online and somehow they get misclassified, it's like taking away a fundamental human right. So there needs to be some path for remediation from that situation. And then from this set of actors, you can sort of classify strong versus weak information. So I took a photo from my attested sensor, I have my identity linked to this attested sensor, and I can prove it's strong information from me. And weaker information like deriving perceptual hashes to show that I had the content, I modified it, maybe put it in a meme, and then put it on a website. And the ultimate challenge really is to do this while preserving anonymity, privacy, and freedom. If we build these systems and they don't have hard cryptography at the core of them, it ends up being a pretty dystopian internet that I don't think any of us want to use. So individual freedom needs to be protected for this to actually work. And then maybe I'll spare one thought for the AIs, which is I think that AI-generated content in general will be an important part of the internet. I'm not saying we should ban all AI-generated content. It's just a question of being able to differentiate the two and know the provenance of some content. And then finally, can blockchains help with this? I I think the answer is yes. I think blockchains serve as a great shared protocol source. So as I talked about before, Facebook has their own platform for doing this problem, but it's very hard if you're an individual content creator to use that platform. If we could have a shared protocol for identity, reputation, content provenance, and we could use that as a source of truth, I think it would be a better tool in general than one centralized system for this. Cool. So the path forward is 3 problems. Solve the Sybil problem, build a chain of trust from content creation to distribution, and create shared protocols for information user quality. And that's that. How we're thinking at Pluto. Today we're building tools for the internet and developers. We want to keep the internet weird, but keep it useful. And we're building trustworthy techniques for merging the internet and blockchains and using advanced cryptography to create a transferable chain of trust. All right, questions? I see one hand up. Do we have microphones?
First, I want to say I really love this. I mean, I think this is super important stuff to think about. As far as like the composable stuff, I love that too. Have you thought about, everybody, we're in the decentralized world, right? So it's like one guy can't be the center of trust for the whole world. Have you thought a little bit about how to interoperate between different centers of trust?
Yeah, I have. I think a big part of what I describe as composability is using programmable cryptography to verify an attestation from some arbitrary source and kind of like Boolean and it together with attestations from other sources. In the beginning, you could imagine a heuristic model. So you have like if conditions, if this, then that, if this, then that. But you could also get to a richer model where maybe you're doing a binary classification with a ML-based estimator. And you can also verify that inside of a snark. So. Oh, there's one more.
Testing. There we go.
Hi there.
Hello. Thanks for a great talk. Super interesting. I was wondering if you talked about almost like putting a watermark on content.
Could you speak a little louder? I can't quite hear you.
Yeah, is that better?
Yeah.
Okay. You were talking about putting almost like a watermark on some content if it comes from the White House or something like that, so that people can see that that came from them.
Yeah.
But there's no watermark on any AI-generated content, so there's no proof of the provenance for that.
Yeah.
Would another alternative be somehow regulating the AI-generated content to have provenance on-chain so that you can see where that content originated from in the first place?
I see. So one, I'm not a fan of trying to regulate things. I think it's even if you tried to make it the case that you had provenance for any AI-generated content from like one fixed source, someone could just spin up an open source model and start generating content. So it's very difficult to have guaranteed provenance of content. I think the best we can do is have signatures and attestations to what we know is good, valid content from good, valid sources, and the rest we essentially have to consider noise. And then you have to opt into how much of that noise you want to experience. So for like White House content, yeah, I think it's about signing the content, and any user who ultimately consumes that content being able to look at the signature, verify it themselves, and see that it actually came from the White House, having like a little check mark next to it. And then if users want to edit that content, maybe like remix it into a news feed or something, I think it's about having segments of that video that can be verified as derived from an original attestation. And that's kind of where perceptual hashes, I think, come into this.
Hello. What incentive do you see for centralized parties and commercial parties to use decentralized solutions for provenance and other things? Is it legal? Is it commercial? Something else?
I see. Yeah, so I don't think there's an incentive for a central organization who's already doing KYC or identity checks. I think they'll continue to use centralized technology. But I could imagine a world where platforms that value anonymity find these solutions the most appealing to avoid having to KYC and manage that type of identity information. So I think Twitter or Reddit, where like famously anonymous profiles are a key part of their social strategy, would like to find decentralized solutions to this. That's my hunch. Okay, that's time. Thank you everyone for coming. I'll be around for a few minutes if you want to ask questions.
Thanks, Tracy. That was great. And let's give Tracy one more big round of applause. Yeah, well, only going to go a little longer. Thanks, everybody, for coming out. Next up, we've got Golda from the Ceramic Network, who's got some very interesting things to talk about. And I think it relates really well to what we just heard from Tracy. So while we let her set up, we'll get on going here. Are you excited?
That's why I came up here before I was supposed to.
And everybody, welcome. We got Golda speaking, and we are good to go. So everybody, enjoy. Stage is yours.
All right, thank you guys. And actually, I'm really excited to be following Tracy from Pluto, who was just talking about AIs and fraud and trust, because I'm also going to be talking about AIs, fraud, trust, and those kind of problems. I think it's kind of interesting. I just actually was conference hopping. I was here at ETH Denver, and I went to 2 AI conferences and back to ETH Denver. And yesterday in San Francisco, it's like everybody's like, oh, AI is everything. Everything in the world is going to be AI. It's going to be so great. And it was like so much hype. And it's actually very refreshing to come back here and also get the anchoring, pardon my pun, to identity and who actually is talking and what is true, what is not. So AI actually causes, as Tracy was saying, a greater need for trust systems because it's so much easier. Let me go back here. It's risk. I used to do risk work for Postmates. So I was actually fighting credit card fraudsters at scale. And when you think of fraud, it's not always just like Joe saying stupid stuff on the internet that's misinformation, using something. It may be a very organized crime ring that's actually doing fraud for profit. And when you're fighting risk rings, you're actually fighting another team of fraudsters that's attacking your system, and it's kind of that spy versus spy thing. And so there's various types of risk and fraud that you can think of. Some of them that we would run into is account takeovers, where maybe there's a guy's account that was a good account, but then someone got the password or private key. They do a lot of massive, laundering. So all those stolen credit cards, they don't just get used by the guy who got them. They sell them, they bulk transfer them, and then there are people who, launder them at scale. Phishing attacks. Social hacks is actually a big one. We used to always tell all of the drivers, we never ask for your password. And then, of course, somebody calls them and it's like, oh, we're Postmates. Can we have your password? And they were like, yes. So social hacking is actually a big thing. That's how actually a lot of chains have been compromised. And, of course, ransomware. So you really have these kind of high-stakes games that are being played. So it's not just a matter of, is this a human? But, there's actually attackers that are systematically trying to subvert whatever system you might make. And generative AI makes detecting fraud harder because LLMs can simulate human behavior much better than anything we've seen before. So telling whether something is a human based on its behavior, based on its timing, based on its click patterns, all those things that we normally were able to do, a lot of those are not going to work. So really, I'm seeing that we're going to need to transition to more trusted and gated spaces for a lot of us. And that's kind of what we were saying as far as, do I want to interact with all the bots? Do I want to interact with all the noise? So there's a lot of opt-in spaces nowadays. There's allow lists. Your mail is probably being sorted to people that you have previously talked to. My phone is blocked unless I have people in my contacts. Essentially, we're creating ourselves little walled gardens that are safer spaces for ourselves. And it's interesting, coming at it from a biology perspective, there's a reason that cell walls evolved. Inside a trusted space, you can be much more open. And it's actually more efficient. And I can tell you this from looking at what is the bottlenecks on, for example, an IPFS. If you're reading all the traffic from IPFS, the bottleneck is going to be the signature validation. So signature validation, all of those types of validations are expensive, even without going to the blockchain, even without paying the gas. Blockchain is expensive to use. Signature validations are expensive. If you have a trusted space in which you don't have to validate, you can go and scale much more. I mean, we would even not use HTTPS on the internal networks because you want to speed things up as fast as you can once you're getting to massive scale. You don't want to have to validate every packet. So how do you create trusted spaces, supposing that you want to? You need really two things. You need long-term identifiers, and you have to be able to share data about the behavior of those identifiers. I think a lot of people here are probably familiar with the prisoner's dilemma. And what that is it's simply, it's a game theory that if there's a repeated game, they're going to behave better. You know, the classic example is splitting the check in a restaurant. If you know the people, you're going to split it more fairly than if it's like a one-time thing and you're never going to see them again. And if it's anonymous, of course, you're going to possibly behave worse. So if there's long-term identifiers, it creates the potential for accountability, the potential for consequences for behavior. So how do you get long-term identifiers in this world where an LLM could like pretend to be anybody at any moment? And then how do you gather the information about them? One of the big things actually from working at Postmates when I was doing risk and fraud is I would do all this work and identify some kind of identifier. We called them assets that were hard to necessarily replace. So it might have been a device ID. It wasn't really a DID with a signature. It was just a device ID. But these things still would have reputations in our system. And if they had a bad reputation, we wouldn't let them in. Now, I might find a device ID being used by hackers, like 5,000 logins just got associated with this device ID. But I would not tell the people at Lyft. And the same guy is probably also laundering credit cards through Lyft and laundering them through Uber and laundering them through every other place that takes credit cards. I mean, what they do is, I'll just tell you a funny story. They would actually advertise Postmates pizza on WeChat, and Postmates didn't sell on WeChat. But if you ordered pizza on WeChat, they would actually fulfill the order by taking a stolen credit card, making an order at Postmates. The guy gets his pizza, but he would pay the WeChat dudes. So it was this, they could do massive fraud at scale with pizza because it's being orchestrated. So these are the, let me keep this going. Let me make sure, okay. So anyway, I would like to be able to share this behavior, and that's one of the things I'm going to propose here, is that ability to have long-term identifiers as kind of a cultural expectation, and then a way to share that data in data pools. That's the two things I want, just two things. So here's a DID. If you haven't seen a DID before, this is a DID. DIDs are nice because they're a standard. They have private keys that can rotate depending on the DID methods. If you lose your keys, you might be able to have a rotation method where you could restore your keys. And they're standard across different things. So like Blue Sky uses DIDs. Every message on Blue Sky is signed with a DID. Nostr uses DIDs. Every message on Nostr is signed with a DID. Ceramic uses DIDs. Every message on Ceramic, or Orbis, which is built on Ceramic, uses DIDs. And those are completely separate protocols, but they're all signed with DIDs. And DID is the thing like in your MetaMask wallet, when you sign something, you're signing with your DID, your decentralized identifier. So they can be protocol cross-chain because there's a DID method that's actually a W33 standard. So that provides a powerful identifier that can cross all these different things. And one of the reasons you want to cross things is if you have graph information, if you have cross-domain information, you can protect against fraud better because you have more knowledge about the guy. When a guy just shows up, you don't know anything about him. You have no idea if he's a fraudster or not. But if you see him in a little ring with other fraudsters, probably he is, if he's connected to them. So if he shares like an IP with them, he probably is. If he shares a device ID with them. So you want to have this cross-domain information, though you also want to preserve privacy. So I just want to also give a shout out to separation of concerns, old-fashioned programming stuff. Okay, please. So signal and models are two separate things. The fact that I sign a message doesn't make it true. The fact that I sign a message, this guy's a human, doesn't make him human. Maybe I got fooled. It's just a piece of signal. So the way we would do it, old on Web 2, is you have a Kafka stream, ton of events coming at you, boom, boom, boom. You process them, you store the significant ones in a database, and then you roll up features and you feed them to models. And believe me, I used to be a proponent of heuristics and rules. Models are smarter. I'm sorry. At scale, models can catch the fraudsters better than my rules, no matter how hard I tried to guess at the best rules. So if you have a source of truth for the model where you can tell it, hey, I found out this was fraud. And we used to do that by allowing some of the stuff to go to chargeback, and the fraudsters would win a little bit. But then we would find them. So if you have a model, it can roll up all these signals and make a prediction. And then if you have a source of truth, of knowing when those predictions are true, you train the model. And the model then is trying to outwit the fraudsters as they constantly change their behavior. So I think from an engineering standpoint, it's better to separate these ideas of a signed thing or a thing that's on blockchain or even a thing that you proved with ZK Trust or whatever. It's just a signal. And it may be a strong signal, it may be a weak signal, but it's not an absolute. It's a signal that goes into the model as a feature, and then the model makes a prediction. Fraud, not fraud. And then you have maybe in some percentage of cases, you have some humans looking at it, you have bad outcomes, depending what outcome you're concerned about. You'll know if it was a credit card fraud because it'll be a chargeback 2 months later. So anyway, you want to have signals, you want to have models that read the signals and make predictions. So yeah, Web3, and now comes the ceramic part. I'm going to put my ceramic hat on. I work for ceramic. I like ceramic for this because it is composable. It's all about composable data. It's very low cost. It's cheaper than an L2. We have basically schemas that you can register. Other people can consume them. It's just like MongoDB, except that it's on like, well, right now it's on IPFS, but if you run a ceramic node, it'll actually become a little better than IPFS soon. And they talk to each other. They share the data on streams that you can publish to and consume. And they're cheaper than an L2, but they are anchored to Ethereum. So the idea is that it's very scalable. So a lot of people can publish and consume on ComposeDB at scale. And the hashes are being anchored to Ethereum, but the whole thing isn't being published to Ethereum because that'd be really expensive. So I want to do a live demo, and I figured there would be no good Wi-Fi here, so I did it locally. We'll see if it works. And this is just a really hokey demo, but it's like, I would like there to be a culture that every entity should sign with a DID. Now, normally, of course, it's not going to explicitly like talk to you and sign with a DID. It's going to be something you would call or you would use some code to do. But I just made a fun demo. I'm running Neo GPT here. And I'll just show you that it is live, if it ever runs. And so this is like a really stupid model. It only has 250 million parameters. So somebody give me something, or I'll say, hey, I'm Tracy from Pluto. And let's see. OK, so Neo GPT is thinking, and he says, here to give you more information about the command config. He's just making shit up because this is a really dumb model. But I'm going to ask it, who are you? Ooh, and my little wrapper answered, because I programmed it to, that if you ask it, who are you, now it signs a message with a DID. Now, obviously, you're not normally going to talk to a model and be like, who are you? Let me see your DID. But if you did that programmatically or directly, I think there should be a cultural expectation that everybody everywhere should have a DID that's going to talk to me on the internet if I don't already, if it's not over some kind of secure channel that I already know. Because also, you can't really tell AIs from people unless you make every human get KYC'd. And I don't want to make every human get KYC'd, so I have no idea if I'm talking to a human or a model. But I just want the damn thing to have a DID so I can talk about it. So for example, going back to the demo, I did this earlier, and I did the same thing, and I made it give me the DID. And then I put the DID into, this is a company I sometimes see, but you could program lots of different places that would do this. But this is a group that's doing decentralized trust and linked claims. And then I'm going to tell this interface, hey, this DID doesn't make any sense. It's probably not Tracy, really. It says it is, but it's not. And so then I'm going to sign that attestation with my MetaMask, and I'm just going to say something about it. And I can do that whether this bot gave me permission to or not, because it has a DID, so I can say stuff about the DID. And then the stuff I say can get published on the Ceramic network, and then other people can see it. Like Surscan is not my thing. I don't run Surscan. But as soon as I said something about this DID, it shows up on Surscan because it's part of the Ceramic network, and now other people could consume that data, and they can run their models. So all the signal can go out on the network, and we're using the Ceramic network as an example because it's nice and scalable, but you could do it other ways. I can consume it and make a model over it. You can consume it, make a model over it. If you don't like my predictions, make your predictions, use your anchors of truth. But if we could share this data, then we can all be more powerful against the spammers. And this is an example of that little guy, Link Trust. He makes because he doesn't have enough data right now, those guys don't have enough data to build models. They're just showing you a graph of like who said what about who that you could explore. So that might also be useful. But the main thing is to share the data, and then I I can decide which people's data I'm going to consume. Like, I only trust these guys. I'm only going to consume their data. I'm not going to trust those guys. I don't know them. And then it still is a game of spy versus spy, but the good guys, if you ever played Avalon, the good guys are the ones who don't have to lie. If you play the very naive version of Avalon, the guys who can tell each other the truth and be open, those are the good guys, can win. So I'm actually ending kind of early. I'm going to give some chance for questions. But here's some places you can look at more stuff. Shared data at scale. We have the stuff ComposeDB, where you can like make a model, make any schema you want, publish it, consume it, make an app. And then totally separately, not related to Ceramic, is like if you want to play with AI, go get some models from Hugging Face, Mistral, and you can start playing with the AI models, which is just like they're doing more and more stuff faster and faster. So yeah, I want to take a few minutes for questions. I don't know if anybody has any questions. Thoughts about scale. Okay. All right. Well, if you're interested in anything about, oh wait, there's a question. Oh, good. I like questions. Questions are good.
Hi. So everything you talked about is underpinned by using DIDs and using DIDs very pervasively. But the amount of stuff in the world is so huge. Isn't there a risk of DID explosion? And at that scale, what does a DID mean if there are billions, if not trillions, of DIDs being generated all the time?
Okay. I'm not sure I heard everything you said, but you said basically will DIDs scale, and like what does a DID mean at scale? Is that?
Yeah, I mean, an explosion of DIDs could be a problem.
Yeah, I mean, obviously, yeah, you do have scalability problems. It depends on what, state you're in. I think the DIDs are really the core thing. I mean, we were able to store data about millions of card fingerprints, millions of devices, millions of logins, without any problem, just like in Postgres, and it fits very nicely into a model. I think DIDs, there's less of them than there are messages, because like there's 9 billion people, and then maybe another 9 billion AIs, and maybe another 9 billion other things. But it's on the scale of countable billions of DIDs, which a model can handle that. A big model can. So yeah, somebody has to be consuming and then rolling up that data. And yeah, that person who's rolling it up is going to have some resources and probably charge for their model's predictions at some point. Maybe they'll give some freemium or something. But yeah, actually rolling up the billions and billions of DIDs and the data is going to be expensive. Somebody has to do that and be funded to do that. But just the fact that they're being transmitted, you don't have to store all of them. They're going to be flying by. They're just kind of like traffic that's flying by. So everybody's not necessarily keeping all of them all the time. But yeah, somebody has to, in order to do effective risk, you have to aggregate a lot of data.
Question. The ceramic model that you mentioned, are there any use cases in the world right now that is gaining traction on?
Wait, I'm sorry, can you say that one more time? I definitely want to hear that.
Are there actually use cases where this model that you described is gaining traction on? I'd like to learn more about the real life use cases.
What are the real world use cases right now for ceramic models?
Correct.
Yeah. So like Orbis is using them. So Orbis has a social network on top of ceramic models. There's, thank you for that question, and thank you for the other one. There's some decentralized science use cases where they're sharing scientific data. I'd like to see people actually sharing the parameters from federated models. I don't think people are doing that yet, but like for predictive models, you can actually do federated predictions and just share the parameters. Somebody should do that. Of people who are actually doing stuff, Gitcoin is the biggest example right now. If you go on Open Collective and you get Gitcoin passport stamps, if you've ever done that, like validate your Twitter account, that's all on ComposeDB, that's all on Ceramic. Then there's Oamo is doing some stuff. I should know this because I actually measure these guys. Oh, and I guess my time is just about up. Gosh, I shouldn't leave people out, but there are a number of people doing stuff from decentralized science to social pact. So there's a number of people. There are reputation cases and other kinds of things in social networks, and game points. Yeah. All right. Oh, my time's up.
Pretend like I'm a part. Welcome back, everybody. And as you can see, I've got 3 lovely ladies with me on this panel. And we're going to have some interesting discussions around innovation today. And I'm going to let dear friend over here, Susie, kick things off. And unfortunately, I'm not here for you, but I'll let you have this one.
Works. Okay, we're working. Hi, everyone. Welcome to our panel on investing in innovation. I'm Susie Batt, and I'm a board member here at ETH Denver. I'm also on the SheFi board and an advisor to 2 startups, and I source deals. So I have a good idea of what kind of investments are happening this year. However, this panel includes Vanessa and Kelly, who are old friends of mine and have years of experience in investing in startups and blockchain. So their perspective encompasses our space since 2016. Yeah? So I'll let them introduce themselves. Vanessa?
Hey everyone, my name is Vanessa Gurley. I'm a managing partner at Aglaé Ventures. We're an early stage Web3 fund. We focus on pre-seed and seed and core infrastructure.
Hi, I'm Kelly LaValle Hunt. I'm the founder of Mint Gold Dust, which is an NFT platform. And I'm also the founder of Pearl River Venture Capital. We're angel investors, and we typically invest in the Web3 community.
Before we kick off with questions, I wanted to ask the audience, who in the audience is a founder or a founding member, team member? Great. And who in the audience is actively fundraising? You should always be fundraising.
I wish we could get the poll from the streamers, because the streaming audience, we're streaming, so.
There we go.
Yeah.
So would each of you answer the following questions? What's your fund size, your stage of investment, you mentioned, but let's reiterate, your average check size, and where in this space do you play?
Fund size is approximately 70 million, so it's right size for smaller checks in early stage. We focus on pre-seed and seeds and do a little bit of incubation. And we also focus on 3 areas. The first one is core infrastructure. The second one, which is part of that, is ZK, technology and privacy. And the third bucket is financial services.
Kelly?
Yeah, that's kind of a funny question, because I'm my own fund. I'm not backed by a group of people. I don't accept money into my fund. So it really varies based on the year. And we were kind of talking about the bear market versus the bull market. And so my fund actually, or my ability to invest with larger checks into like the Series A, grows significantly in the bull market and shrinks significantly in the bear market. I tend to focus strictly on Web3, and from pre-seed or angel to all the way up to Series A, typically in the Web3 world.
So this audience, this conference, is really BITL focused. So I'd like to make sure my questions and your answers are tailored so that the takeaways can be utilized in fundraising for startups and just overall advice in this space in 2024. So can you give us a macro Q1 perspective of what kind of deal flow you're seeing right now?
So we've seen with the growth of sort of the late stage bucket, we see earlier stage also get their valuations inflated. So we're back. So it's good and bad, I would say, because it's always nice to see reasonable valuations, and I think we're going to be back in the 2021 type of activity where deals are closed very quickly. There's a lot of FOMO on them, and
But we're still at the end tail of the bear market, so not every deal gets that. There are certain areas that get more attention. So ZK is one of them. Obviously, staking, restaking, liquid staking in all its forms is also high on the attention list, and of course AI and blockchain. So that's a bit frothy right now.
Yeah, I have to agree. But I also see a lot of companies that are building DeFi platforms right now with also AI somehow backed into it, or NFT platforms with AI backed into it. So it's really interesting right now. I'm trying to get like a footing of like this year, 2024, of where I'm going to see the most deal flow or opportunities. And it's so bizarre. The last 3 months or 4 months, I've just thought, this is really strange. I think this is one of the first times since I've been investing that I don't see a clear focus of this community, of the Web3 community. There's a lot of DeFi, sci-fi, CeFi, AI, and then there's like a mixture of all of that. And whereas years past, it was definitely blockchain solutions or protocol solutions or platforms for art or etc. So there were clear lanes prior to now. This year, 2024, and the end of 2023, it's just like a mixed bag.
We were just talking earlier that in years past, and we've been around for a while, we've had a narrative to hang our hat on, whether it was ICOs, NFTs, DeFi, account abstraction, and this year AI. But we are seeing maybe a mélange or like a mix of hybrid platforms, protocols, projects, and maybe that's the innovation.
Yeah, I think you have to go through that period of kind of shake and bake, kind of with like a digging for gold, and like the gold stays on the top and then all the junk falls out. I think you have to kind of go through that where it has to be a mixture until the cream of the crop rises to the top. And when I say cream of the crop, I mean like the teams with a clear structure of go-to-market, a clear strategy of go-to-market, and a clear vision of their goal. Whatever lane it's in or whatever mesh of a lane it's in, I think eventually, maybe in the third quarter of this year, we'll see a lot more of the cream of the crop and have a more defined look. And I think this is the first time I've actually seen just kind of a mixture of where you can't, there are a lot of AI focused company startups out there, but I just don't see a clear lane for AI, just AI.
Let's talk about innovation in terms of like teams and talent and what we call like layer zero, which is like people. Are you seeing any evolution in teams or skill set from years past when you first started investing? How is the people capital evolved or innovated?
Yeah, I think it's great. We see a lot of second-time, third-time founders, people who have been in the space and building in the space for a long time, coming in with new ideas, being able to put together teams very quickly, find talent, and that was harder in the previous cycles. And we see a lot of Web2 talent coming in, especially in the new ecosystems like Sui or Aptos, where it's kind of closer to what they know. So I think that's super exciting. We also see people from the TradFi trying to move over. I think the Bitcoin ETF is a huge catalyst of giving credibility to our space in traditional finance, and we'll see more of that with the Ether ETF and all that stuff. So really exciting to see more and more experience in the space and more focus also on delivering specific solutions.
Yeah, I agree. In years past, it was really difficult to find like a Solidity developer. So we started back in the day in 2017. Block apps. We started training people to write code for Solidity. If they had a JavaScript background, we could very easily recruit into like the teaching of Solidity. We're seeing now that if you are in the Web3 space, you have some understanding of a Solidity, and I think that makes a big difference. Now I see guys coming to me and they're like, I used to run this DeFi platform, and it's just like ages ago though, like 2 years ago. So that's kind of nice because you see that there are resources that are evolving, and they're getting a lot of incubation time to be able to develop their skills to where they can actually build a startup or kick off one or lead a team in a startup.
Let's move on and talk about innovation in maybe geographic location. Electric Capital produces developer report every year, and one metric which was surprising for me was that new developers with new innovative projects were only 27% were coming out of North America, which lends to like where is all the sort of innovation or original source code happening. And Latin America and Central Asia and Europe took the big pizza pie of it. What are you seeing in those geographic areas?
So I focus only on North America and Europe.
We'll speak of Europe.
I think it's not a question of developers. It's a question of regional markets, even though we think a lot of the projects are global and the attention that the projects can get globally. So we see great talent in Europe, less go-to-market and market access, I would say. So it depends on where you focus, whether it's DeFi or core protocols. But I still see a lot of innovation in North America, just because of the firepower in the universities and this huge reach that they have.
Capital, yeah.
So it's not about the number of developers, it's about the quality of the projects that come out of each region and its capacity to go global. And I think that mirrors a little bit the Web 2 in that sense, that it's just harder to scale in Europe than when you have a big market immediately in the US.
Yeah, I agree. My team for Mint Gold Dust, they're based in Ghana, Rio, Brazil, and Mexico City, and I have a couple of guys in California. But for the most part, I'm very decentralized with my developers. I do see, I see that developers are more nomadic now, as you know, in comparison to like 2016, 17. They're a lot more nomadic. After 2020, it kind of developed into it's okay to be a decentralized developer or coder. I see a lot of startups coming out of North America, or they've moved to North America. They moved their headquarters to North America. There's a lot of funding on the West Coast. I mean, the majority of the funding for startups in the world is coming from like the West Coast of the United States. And which is just kind of funny because, you know, the European startups are very risk averse, and they're much further along than the startups that you see in North America. So they have more employees, but it's really, really risky to do business in Europe. It's a lot more expensive from what I've seen. And in North America, you can kind of spin up a startup and try something out and get funding for it from the West Coast a lot easier than you can see in other countries. And outside of Europe and the US, I think funding maybe with the exception of Asia, there are some countries in Asia where you can get a lot of funding, but majority of funding comes from the US from what I've seen, and it's a lot more difficult to do a startup in Europe. So it's kind of a nice little area to build a startup in the US because you have the funds, you have low cost of resources, and you're a lot more agile in the US. I think it's a lot less risky to try a startup out in the US.
Yeah, the funding issue is a big one. And I had never worked in Europe before, but I've been doing that for the past year and a half. And the risk appetite of early stage investors is very high. Low.
Why do you think there is that cultural difference?
I think so. What I've learned is that the VCs in Europe are, I would say, 80-90% financial VCs. So they've never operated a company, so they don't really they're not comfortable until they have metrics for the startups, and you only get metrics after a certain amount of time and money spent on the startup. So sort of the pre-seed area is very difficult for them. Whereas in the US, 90% of the VCs are ex-startup founders or startup employees, so they understand the struggles of coming in early and the risk, and how to help also the companies, that are engaging in this journey.
I think bureaucracy in Europe also plays a lot into that. But it's kind of funny because I lived outside the United States for 25 years. Full disclosure. So I love the U.S., but there is something to say about a more socially driven or community-driven society or community. And I think that I always tell people that live in European countries like Germany or the Netherlands, like, why don't you do a startup? Like, you have like a system built around you, a government that supports you in being a human. I lived in Germany for 4.5 years, and then the UK for 12 years. I lived in Spain for a little bit. I'm a big supporter of living in Europe, but the access to startup capital is very, very difficult to find that. So a lot of the times their headquarters get shifted over to Delaware, and they move over to New York or California or even Texas, Miami, to have access to that funding in the US.
Let's shift and talk about innovation in funding, and what different variations of deal structures. Oh, we have Rogue.
Hi.
We have a Rogue participant.
Happy to have you.
Last panelist, ETH Denver Security cut me up, so.
Okay.
What?
Yeah,
Wait.
They couldn't let you on the...
long story, but yeah.
Oh,
So what's your
gosh.
name? Introduce
Who are
yourself.
you?
Yeah, I'm Ani from Dragonfly.
Oh, great. Nice to meet you. Welcome.
Yeah, no, thanks.
I'm so happy that we're not an all-female group here. I was kind of like thinking we were discriminating against the limited amount of men in this event. So welcome.
Yeah, I feel that.
Well, introduce yourself.
Yeah, so I'm Ani. I'm a partner at Dragonfly. We manage a few billion in crypto, but yeah, I would say we started a few years ago kind of investing at the precipice of L1s, DeFi, and all of that fun stuff. But I think now as we look to the future between East and West, we have an office in Singapore and in New York. I think we're very excited by things at the marriage of atoms and bits. And I think it's that combination, I think, keeps crypto quite exciting. So.
Security's after you, or what? Do we need to
shouldn't have
hide
brought
you
the
out?
hand
You can hide
grenades.
behind the chair or something if security comes after you? What's
Yeah,
the
who
story
knows?
there?
I mean, we could talk about it after, I guess.
Welcome.
So we were
friendly.
discussing innovation in people and human capital, innovation in perhaps projects coming from different geographic locations, and now we're talking about innovation in funding and different ways for projects to be funded. Would you like to add anything that?
Yeah, I would say
Dragon?
a decade ago you had an explosion of venture, right? Because I think money was cheap, everyone was doing venture, but then now the industry is split into what we like to call minnows and sharks. So there's like tiny funds that are really good at like some parts. Could be crypto, could be like venture capital, could be American dynamism or whatever like the flavor du jour is. And you have the large funds, many of whom charge huge fees, and they're kind of making all this money off management fees. And I guess they don't have to invest that much, right? Because they can make money in all these sorts of obsequious ways. I don't think people are really ready for that because like venture has been over allocated for a very long time. And innovation has been relegated to a very few areas in the American economy, per se. We operate kind of globally, and so we see it as a comparison between, like, say, here in Asia, 20% of every American dollar goes into fintech, which are like big banks, and they're spent bailing out these banks or whatever. In Asia and Africa and India, it's wholly different, right? Like the average age in India, I think, is like 21. In China, it's 49. And in America, it's like 35. And so I think that gives you a sense of like where we see, I guess, and like where venture itself will probably change in the future.
So as I mentioned in the beginning of our panel, the audience here at ETH Denver, this is our 7th year running, has always been focused on biddling. When you have a startup looking for pre-seed investing, tell me what the cadence and dialogue is when you begin. Like, what can our audience take away from our panel as advice, or what to expect when those conversations start to help begin their fundraising process?
Well, I would say the 3 things that we look for, but I guess that's probably the case with everyone here, is team, market, and distribution. There's that line which is that first-time founders focus on product, second-time founders focus on distribution. And I think like that's very true because crypto in some sense is a unit of globalization. And if you can't distribute your product to even a few people, that's quite a bad sign, I think, right? Like given that capital now moves at the speed of thought, if you can't make people like your tweet or retweet, you have like no business being in business, I guess, right? Like business is actually way harder than...
Yeah, I think when I look at startups, I tend to focus on the founders, what they had done before, and what their skill set are. In a startup, you also have to think about like maybe somebody has to take the concept of sales into consideration, not just somebody that does coding and maybe somebody that does the books, but sales is super, super important. How do you go to market? And I'm assuming that's what distribution from your perspective is. And like, how do you structure yourself? Like, who's your target market and how are you going to get there? How are you going to reach these people? And because it doesn't sell itself, the whole idea of, in the early years of ETH Denver, it was like, build it and they will come. Well, that's great for a community gathering or a conference, but it doesn't always happen that way with code. So just because you can code something doesn't mean it's going to get into the hands of people that actually want to pay for it.
Yeah, what we look in the team is sort of a complementary team. The idea that you're able to build a team, and that's something you want to do. And so I think that's really our number one criteria, whether your idea has a good potential product market fit or tech market fit and has real innovation. And also I think what you need to demonstrate when you speak to VCs is that, you're able to take feedback, you're able to pivot, where you're building a long-term relationship when you get funding, or at least with your lead investor. You want to have great relationship for them for the next 5 years, right? So that's really a relationship building of trust, and that you can work together.
We're at the end of Q1 of this year and hopefully an uptick in the market. What are you excited for? Is there a particular cadence in your deployment of capital that has anything to do with, I don't know, timing? Or is there, for startups who are raising, does a quarter to quarter have any differentiation in their raise, or is it market driven, or like how would that? I'm just trying to think like how.
Yeah.
Is there any advice to give them and when to raise?
Yeah, I guess for us, I mean, probably the case for you guys too, but like we have a general sense of deployment over the life cycle of our fund. So it's not like, oh, it's Q3, sorry guys, like, no, we can't invest in you. I would say what's a lot more important is probably understanding the meta for a lot of companies, like things in crypto, because fundamentally it is capital, right? I mean, DeFi itself is a coalescence of different segmentations of capital that you're trying to like round up in one place in some sense. But I would say a lot of people kind of miss the meta. And if you do miss it, it becomes very hard to walk it back. So the meta might be like the theme of the moment, right? Not that people should be investing thematically, I know we don't, but like there's times where you might miss the boat. And that doesn't have to do anything with like the time on a calendar, right? It's just like where people's minds are at.
It's like AI right now.
Right, correct. And a lot of people will be focusing on that, whether that's the right thing or wrong thing, time will tell. But historically, focusing on themes has been quite difficult, right? Like I think, like you can look to the green bubble of like the 2000s, and the only successful company of that period was Tesla, a car company, right? So I think the same is true of crypto, where typically if you look in places where other people look at, it doesn't go that well. So
Yeah, I tend to only focus on, instead of historical investment structures or trends, because the Web3 world is so centered around the Bitcoin price. I mean, the market is, you know, if you're going into a bear market, you better be closing your round, and you better be closing more than you actually need, because you're going into a bear market. And I've had a couple of companies that I invested in go out of business in a bear market. And the last bear market was horrible. It was like really painful, much more painful than this bear market. I don't even know if we're still in a bear market right now. Right before the halving, which is unbelievable. Bitcoin's going to hit 67,000 before the halving. That's never happened before. So I'm kind of excited about what's to come. But I do know that if you're going into a bear market, you should definitely look at, as a startup founder in the Web3 space, definitely understand when the halving is, and what that period of time is, so that you can plan for that bear market, because it is really going to affect your sales, it's really going to affect your raises, and it's really going to affect your resources. In a bear market, there's so many developers available to work with you. In a bull market, forget about it, and their prices are very, very high. So you have to kind of plan for that over a longer period of time, not just, you know, don't just think about the raise, think about the timing of the raise. It's so valuable to plan for that in the Web3 space.
And I think on the investment side, there's really a herd mentality, and a lot of deals are driven by FOMO or by, you know, specific themes that a few gather around. So, you know, when you're building something, and let's say the life cycle, you get an investment and then you issue a token 3 years later, et cetera, you have to think of projects that are not the ones that are being built right now or launching a token now, but something in the future, an innovation in the future. My one of my partners incubated BitTensor a few years ago, who was thinking about the craziness of AI that's going on right now, and it was totally under the radar for years. So you really need to think of, where is the market going? What are the big trends? What cycle you're going to be in, obviously, to launch your token. And, you know, I think we can have some predictive, you know, data around the Bitcoin halving, et cetera, and the previous market cycles. It doesn't mean that it's going to repeat itself, but you can see the trends. So also when you're fundraising, think about how long it's going to take to build your protocol. What's your strategy and go to market based on that? And also, I think really important, what do you need from your investors? Do you need liquidity? Do you need advice on building teams? Do you need go-to-market? There's different types of projects that really need different things. So you need to make sure that you make those asks to the funders.
Well, we have just a few seconds left. Speed round. One piece of advice for the entrepreneurs in the audience, the bidlers in the audience, one piece of advice you'd give them right now.
For me, it would be don't take advice. I've never taken advice, and every time I have, it's ruined my life in some sense. So yeah, well, Well, I think people fundamentally know what they want to do deep down, right? And I think one perk about going to a lot of these things like ETH Denver is to be salient in your originality, right? I mean, it's like the job of being in a crowd is to, I think, keep finding yourself in the ranks of one insane. I think that was Marcus Aurelius, which I think is like especially true in things like this, right? Where you always want to be original and underdetermined when everyone else is overdetermined. So
Ironic, thanks.
Well, this is going to be really ironic. I would say to startup founders to listen more, and so not to be controversial, but I have a hard time. You know, I've been investing and working in software for years, many years, and also I see a lot of like, you know, every single bear market, there's a startup that has this really amazing idea, but you know, they have the same idea that there was like, you know, 4 years or 5 years before, they just weren't there in the Web3 market to see it. So listen more, take those nuggets from those advisors and apply it as much as you possibly can, but apply it in your own way.
I would say no matter how big your idea is, it's not big enough. So always think how you can push yourself more, how you can challenge yourself more, and how you can maybe take advice from others. But, you know, we are naturally limited by ourselves. And so the more people you have around you and the more advice you have, it is something that you want to look out for, but always think maybe, you know, there's something more.
Great.
And you can innovate more then.
Susie, you have to give your advice as well. I mean, you have to like tell us your thoughts as well. I want to hear your.
Oh my God, Kelly.
Not to put you on the spot or anything.
Surround yourselves with the energy
that's
that
good.
you want to give and receive, that reciprocate. Like, know your boundaries and know when to draw them.
Yeah.
I think. But thank you all for your thoughts and your friendship. And good luck to everyone out there. Thanks for coming.
Oh, she's here. Justine Humanansky. Justine, thank you.
Welcome back, ETH Denver. Next up, I'm excited to announce Justine from Optimism, who's going to be giving some interesting discussions on some DAO research. And those who don't know, obviously, Optimism's running some of the most interesting experiments right now in the DAO space. So give it a hand to Justine.
Cool. Today we're going to go over Optimism's DAO design principles. So I'm the governance lead at the Optimism Foundation. One of the primary goals of the Optimism Collective is to support open source public goods. So last year at ETH Denver, we open sourced some of the tools that we use in our DAO research via something we call the Collective DAO Archives. We've added new resources since last year to the archives, which we're open sourcing today. And those are the DAO blueprints and our DAO design principles. So we have to stop saying that we're building a plane while we're flying it when we talk about DAOs, because it's not really true. DAOs have been around since 2016, and there actually is a blueprint for this. Because I built them. So I mapped out the organizational blueprints for 17 DAOs. This is what Gitcoin looks like. You can see what roles were hired, when, which working groups were formed, when they were formed, how many people were part of those working groups. And you can see how this evolved over time. These are open source. You can go in and look at them in excruciating detail yourself. From this madness, though, comes a method. By doing this research, I derived 11 DAO design principles, and we actually use these in practice today at Optimism. So these are not theoretical. We're designing based on these. So we're going to go through those principles today. These are also open source, obviously, now. The first one is to use magic numbers when you're designing teams. I don't mean magic numbers in a mathematical sense, so don't at me. I mean magic numbers is a term used to refer to this natural limit in the number of people that can basically effectively propagate information between them. And for teams, that tends to be 7 to 14 members. When you look at DAOs, you also see a similar natural limit at around 50 full-time or almost full-time contributors. If you put those two data points together, it would imply that DAOs can support roughly 5 teams. If you look at the evolution of DAOs, looking at the blueprints, you'll see that's what happens. Most DAOs evolve to a final state of 5 critical business functions. The second one is to delegate convex decisions and make concave decisions directly. This is not my framework. This is Vitalik's framework for convex versus concave decision making, but we use it a lot at Optimism. So when decisions are convex, decentralizing that decision making process can lead to confusion and low quality compromise. That's when you want to delegate those decisions to a council or a board or a small group of experts. When decisions are concave, though, they actually benefit from the wisdom of the crowd, and those should still be made by the full DAO. We have to distinguish between representatives and contributors. I talked about this last year, but it's super important, so I'm going to say it again. Representatives are delegated rights that token holders would otherwise directly execute, and they should be elected and treated as public officials, held publicly accountable. Contributors that are doing work for the DAO don't take on token holder rights and therefore don't need to be elected and held to that same level of public scrutiny. A lot of DAOs just elect all roles, and we're publicly hiring and firing everybody, which is a terrible contributor experience. It's only necessary if you're a representative. Number 4 is we want to try to design for resilience to churn, not resistance to it. So churn is inevitable, basically, in DAOs. They're inherently part-time, flexible work environments, which means they're also going to be high turnover environments. So we still want to try to retain our high context delegates, but we need to do that within a system that doesn't break if any one of them leaves. Some ways that we think about doing that is that team leads should never be a central point of failure. community roles should be spread among multiple contributors and not concentrated in one or two. Like you can think of moderation or governance facilitators. If you only have one or two, they have a lot of power in the system. And then we have to establish talent pipelines and scalable onboarding flows so that we could replace any community leader in 7 to 14 days. Optimism's resignation policy is 7 days, so we need to be able to find a replacement in that period of time. 5, we need to avoid principal-agent problems. They're everywhere in DAOs. The problem with that is that they make organizations work across us versus them lines. DAOs are already managing tenuous relationships between many different stakeholders. This exacerbates that problem. We most commonly see this in waterfall compensation schemes, but you also see it in community-led initiatives that are dependent on core teams, or when the core team is required to support community-mandated initiatives. Teams should have as much autonomy over their own operations and budgets as possible. 6 is embarrassing to have to say, but we need to make data-driven decisions. Most DAOs are not really doing this. And that can help us make fewer, better decisions. So we need to reduce the number of subjective decisions voters are asked to make, and instead empower humans to override otherwise algorithmic decisions. So what can that look like? That can look like calculations that are run over attestation graphs or formulaic strategies, and then you have smart defaults that are built on top of that, which your voters can override. We need to develop more objective frameworks, especially when it comes to economic parameters, and that is partly to reduce this natural self-preservation tendency to accrue value for the DAO at the expense of the protocol. This happens a lot, actually. This principle is the most lacking in treasury allocation strategies that are most of the time made subjectively, so there's no concept of being in a growth phase or a value phase, or when or how you adjust economic parameters. 7 is really important to optimism. We want to value outputs, not inputs. So one way we do that is to separate decision-making about the work to be done from decision-making about the team that completes it. You want to try to avoid batch proposals because that doesn't let you value any specific outputs. And then to the extent possible, we try to value work based on the output or the impact, and not on hourly or any other type of input. The impact equals profit framework goes into more detail about this concept, and it's a core part of retroactive public goods funding. It's linked here if you want to see it. Number 8 is internal redundancy creates waste, not competition. So you'll see a lot of DAOs support redundant teams, thinking it's going to promote competition and the best approach will kind of rise to the top. It's not what happens in practice. What happens in practice is these groups have overlapping responsibilities and messy handovers, and it's basically inefficient and a bad UX. It tends to go on forever also because it's super unpopular to have to fire any one of those teams via public governance vote. Nobody wants to do that. What works much better are competitive, basically RFP processes, where you have multiple external teams competing for the ability to complete a piece of work. And that's because it creates healthy competition via performance-based accountability. Scope should be narrow, not broad. Most working group mandates and DAOs are super broad, and the problem with that is that it creates room for inefficient budgeting and also sometimes fraud because the ambiguity reduces accountability. You see sometimes like meta work streams, which is where you have multiple working groups within a larger work stream that represents the function. That doesn't usually work because it introduces additional coordination costs when coordination costs are already high in decentralized environments. For the same reason, you don't usually see cross-functional working groups. So the thing to remember is to keep scopes, mandates, RFPs, whatever, as narrowly scoped as possible. This one was one of the more interesting findings from the research I did, and that was that you want to scale work within the DAO via public goods rather than public services, and I'll explain what I mean. You can imagine like a data team or a data working group that provides data services to other teams within the DAO that suffers from diseconomies of scale, and also like a variation of the principal agent problem where the DAO approves the budget for that team, but the individual groups consume the services. What works a lot better, though, is if that same data team within the DAO provides like public data infrastructure that the other teams can use to conduct their own analytics. So that's what I mean by public goods, public infrastructure versus public services. This is the last one. So we want to try to achieve alignment through action. A lot of DAOs create structures without any consideration for what the strategic objectives of those structures are, and then retroactively try to align or justify the DAO's efforts. Usually attempts at strategic alignment are made via paper policy, and the problem with that is it results in bureaucracy, not alignment. Instead, we want to try to design systems that in which merely taking action is inherently aligned. So it's hard to do, but I can give an example. So paper policy approach would be having everybody grade proposals on a scale of 1 to 10 based on how much they align with a stated goal. A more inherently aligned system would be to allocate each strategic goal a budget and then have people rank order initiatives under them. So just by casting a vote, there's no way it can't be strategically aligned. So why are we open sourcing these, and why do the principles matter? Well, because we're actually not just open sourcing these resources, we're open sourcing everything. And what I mean by everything is the entire governance design process at Optimism. So this is the first step in a gradual path towards open meta-governance. Right now, we're in phase 0, which is to open source the thinking of the foundation and the design team by sharing resources, goals, milestones, the collective archives, so that we can build shared context with the governance participants. Phase 1, which will happen shortly, will be to establish or formalize a feedback panel of high context governance participants so they can start to provide feedback during the design process. Right now we get feedback after designs are more or less complete. We will start to have governance participants involved during the design process. Phase 2 would be that feedback panel evolves into a contribution path where it's an open process and like kind of training to do meta-governance design. And then the final phase of this is that contribution path turns into a concept we're introducing called core delegates. And much in the same way that core developers develop and evolve the core protocol, core delegates would maintain, develop, and evolve the core governance system through meta-governance proposal rights. So there's more details on this path. It's going to be experimental like everything we do and open to your feedback, but you can read the full forum post, which is linked here. And if you haven't already joined the collective, you can register to be a delegate. Anybody, whether or not you're involved in our ecosystem, can use the collective DAO archives. They're open source public good that are free for anybody to use. And they were also made using entirely public information.
Hello, thanks for the talk. I have a question. So this month we just started to organize we just started to ideate a DAO around neuroscience, and we have 2 formulations.
Thank you, Justine. Everybody, one warm welcome for Justine, and thanks for giving those lovely insights and learnings from all you do at Optimism. And I know I'm very appreciative of the work that you do, so thank you. We're going on a very short little break here, not even a couple minutes, and then we got our next speaker coming up, so hang tight. Thank you. Welcome back, ETH Denver. As a reminder, this is Trident Stage, and we've got a lot of couple great talks left today. Right now, I got a really great talk coming from Spencer Kavanaugh, who's going to be chatting about how we can build on-chain organizations. And so let's give a little round of applause for Spencer and let him take it from here.
All right, hi everyone, testing, okay. Yeah, I'm Spencer Kavanaugh, also known as Clinomenic here. I'm going to be talking about on-chain organizations. So over the course of this presentation, I want to give a brief explanation of what on-chain organizations can be understood as, how they differ from DAOs and draw from the DAO movement, some examples of smart contracts that can be used to build on-chain organizations, how they can be combined, and then ending with one example of a full-on org chart for an on-chain organization. Here we go. So I think a simple way of answering what an on-chain organization is any organization that uses smart contracts or has some other kind of on-chain presence. I think a parallel sort of term is a virtual organization, which has a couple different kind of confusing meanings, but it basically just means any organization that uses digital communication technology to work together. So it's not so much an entity type term, it's kind of a qualitative descriptor or some term that describes how an organization works. It's also sort of like an evolution of an online organization, just on-chain. And you can sort of think of this as a post-DAO framework, if that's helpful at all, in that it's not so much about decentralization as it is about the other redeeming values of smart contracts and operating on-chain. So how is it different from DAOs? If you think of DAOs as on-chain organizations that use this technology to enable decentralization in novel ways or enable collective agency in novel ways, then on-chain organizations are sort of just a generalization from that, and that they're not as much built around decentralization, but can be built around some other redeeming values of smart contracts. Because the technology itself isn't particular to decentralized applications, although a lot of it was built with that intention. There are also plenty of smart contracts that you can use in a traditionally centralized way. You can have a safe multi-sig that just functions as a board of directors if that works for your organization, or you can tie it into a lot more decentralized framework if you want to have a more decentralized approach. But the idea is that this term on-chain organization and a few other terms that have been used, like internet native company, can use this technology but aren't as dedicated necessarily to decentralization as DAOs are. So this may ring true for some of you. Hopefully it's not too pessimistic, but it does encapsulate a lot of my experiences. And it does make me think of when decentralization is an imperative or when it's an ideal. Sometimes it involves a lot of friction and added difficulty and bureaucratic complexity because we think it's worth it to embody those ideals. But sometimes we just learn that decentralization isn't necessary for a given activity or a given operation, or maybe an organization doesn't need to be totally decentralized to incorporate those values of democracy or equitability. And so the idea is that if you can be a bit more selective about where you use centralized and decentralized components, you can still have accountability and hopefully less dudes arguing online. And so here are some examples of what I think of as the other redeeming values of smart contracts. For nonprofits, the transparency can be important or sometimes required legally. Or again, if it's an ideal of an organization you're with, you may just want to embody the value of transparency. Interoperability is another one that's a bit more of a network effect promise. If you want to envision a future wherein a lot of institutions and organizations operate on-chain, then it may be in your organization's interest to be interoperable with whatever that technological status quo is, whatever that may look like for your industry. But that one's still a bit like prospective. Like right now we aren't at a status quo where it's the norm for organizations to have an on-chain presence. So the interoperability, like value prop, I don't think has quite materialized yet, but it could be. But I think one of the big ones that, at least as far as I can discern right now, is currently valuable is autonomy, largely from siloed or proprietary software platforms that certain organizations may use now for hosting content or facilitating payroll or whatever other kind of storage or operations, where if you are operationally dependent on some other proprietary company or platform, you're sort of also depending on that company to stay in business. And if they go out of business, that part of your stack or your infrastructure goes out of business too, and kind of takes out a chunk of the integrity of your organization. So the idea with smart contracts, at least as I understand them, is that you can interact with this stuff through interfaces that are maintained by companies, but a lot of the underlying infrastructure is a bit more capture resistant, is the term that the folks at HATS protocol would use, and that it's difficult for this stuff to, or at least it can be more difficult for this stuff to be captured or to be deprecated in ways that I gather is much more frequent in the existing status quo virtual organizations. So I think these are some redeeming values of smart contracts beyond any kind of decentralization they may enable. And here are some examples of smart contracts in particular. I just mentioned HATS for role management. DAO House is a platform for interacting with Moloch contracts, so you can build a membership body on chain and enable that kind of collective agency. Grant Stack is for if you want to run a centralized or decentralized grants program, whether that's quadratic funding or direct funding, you can do that on chain now. And Safe, just joint accounts, they can also function as committees. Very easy to start plugging these things together, and that's what I hope to convey in the next couple slides as well. Yeah, we're all kind of familiar with the Lego block, kind of organizational building block things. So that's what I'm hoping to convey with a few of these diagrams like this. Now I've got a QR code at the end of this if anyone's interested in checking out the slideshow and seeing some of these details that are probably too small to read right here. And I've also got a link to this article that explains some of this, but this is one example of tying together HATS protocol, a Moloch framework, and Safe to essentially allow a group of people to redelegate someone who's on their board of directors or some other kind of representative committee using a few steps. Granted, it's still pretty complicated, but the fact that something like this is like feasible is still pretty amazing to me. And I think a lot of work is being done to make using this technology a lot easier and to make the prospects of actually letting more people than just nerds and developers interact with this stuff a bit more likely. I find that very reassuring. And again, I've got this article explaining this particular dynamic right here. And this article right here, again, for anyone who wants to look at it, is intended to try to bring the reader from zero to understanding on-chain organization design, again, beyond just DAOs in particular. And this is another really big one that, again, details are far too small to see, but the idea is you can start composing these things to build full-on organizational charts and kind of, or black prints or architectures, combining all these things. So you can have, is my cursor up there? Yeah. You can have a committee, essentially, or a community of token holders, in this case represented by a Moloch contract, effectively operating as a large board of directors functionally. Again, from a legal capacity, you may want to look at particular circumstances. This may not be advisable for what you're trying to do, but from a technical perspective, this is possible. You can have an arbitrary number of members in a Moloch contract essentially overseeing who is on their executive committee or something like a C-suite, using Safe. Every one of these committees, these little big orange dots, is a Safe contract, and all of the signers for those contracts are wearing hats that are bound to those safes in what the HATS team calls a signer gate multisig, where instead of having individual users or accounts be signers on a multisig in a more fixed way, they're dynamically bound to hats, and thus whoever's wearing those designated hats has signer access to a multi-sig, and that's what can, when you contextualize that within this whole kind of on-chain hierarchy, you can have a lot more accountability than just what was the status quo for a lot of early DAOs, which is just a bunch of people voting on a multi-sig. I mean, a bunch of people voting on a snapshot, and then a multi-sig of 3 to 5 people choosing whether or not to go with the verdict. So this kind of ties it all together and lets you have hierarchy and certain degrees of decentralization in a way where there's still accountability. A community of people can still track what's going on and can still exert some kind of agency, but whether it's just switching the hat of someone that has proven to be a bad actor and has violated some kind of internal policy or code of conduct, they can switch the hat to someone else that went through some other kind of designated election process, or they can add someone else, or they can switch they can switch it so that there is a more centralized board of directors away from the DAO as well. And this top 3 right here is one example of, all right, I've got enough time. One example of this risk of code is law, or code slaw, where if you depend on this stuff for an organization to run in a compliant fashion, you may run into certain edge cases where there isn't any human who's able to step in some sort of state of emergency or failure case, and then that may have nasty implications in terms of people's liability. And so one potential way to address this, and this hasn't been implemented to my knowledge, but I'm sure there's analogs in traditional organization design, is these 3 top ones right here, or what I'm calling the fail-safe committee, is you can have a DAO, essentially, or whatever you want to call a wide body of token holders or members of a Moloch contract. This may work with governor contracts as well, but I haven't tried that. You can have this community or this DAO essentially be the board of directors or the main supervisors of an organization, and they manage this C-suite down here. And the C-suite is the one that's operationally in charge. They handle a lot of the budget, but they're still accountable to this DAO essentially up here. And a lot of this kind of needs to be glued together by operating agreements and other kind of internal policies that get more into social consensus and legalese. But that plus this kind of infrastructure, I think, can reconcile a lot of the trade-offs between operational efficiency and accountability and prevention of corruption and accessibility and democracy and a lot of the stuff that I think has been driving the DAO movement. So the idea is that the DAO or the community of token holders or members can oversee this C-suite and essentially be in control of the C-suite. But if something is compromised technologically, or if there's some other kind of edge case or takeover, a whale attack or something that people de facto realize as a failure case, then there can be provisions in some operating agreement that designates this fail-safe committee to override the DAO or switch it to an updated DAO contract. But this sign-aggregate committee, which could be the same people in the executive, or it could be some other kind of auxiliary board that doesn't do anything unless a state of emergency is entered into, that could be one way of preserving that kind of emergency human agency in some kind of technological failure case, but just confined to well-defined failure cases within some operating agreement or some other internal policy. So that's just one example of how you can use all these building blocks to build a whole on-chain architecture for an organization and start trying to address some of these operational difficulties with trying to enable decentralization to be a bit more effective and to enable more accountability, but not at the cost of hindering like the operational efficiency or the dexterity or the ability to execute of an organization. But again, this is theoretical. I haven't seen this implemented. Maybe, again, there's something analogous in a DAO or in some traditional organization. But yeah, that's the presentation. I'm glad we did manage to get through it, and hopefully there's time for questions. Yeah. Is there time for questions? So good? Cool. Thank you.
Welcome back, Heath Denver. Hope you enjoyed the nice intermission and whatever ads were playing. Next up, we've got Dermot from Pocket Network, who's coming to share some nice insights about what's going on in that space and what they've been up to. So everybody, a round of applause. Dermot.
Hey everyone. So my name is Dermot Aruden and I'm one of the directors on the Pocket Network Foundation, and I'm here today to talk a little bit about growth. But first off, what is Pocket Network and what do we have to add to this story? Well, first of all, we've been around a while. Pocket launched its mainnet back in July 2020, and 3.5 years later, we've made our fair share of mistakes along the way, but we're still here and we're stronger than ever. And we like to think we've learned a few things along the way too. So in terms of what Pocket Network is a deep-in or decentralized physical infrastructure network that coordinates and incentivizes access to any open data source. And we do this via a method known as Remote Procedure Call, or RPC. And essentially, this is a communication protocol for machines. And today, Pocket, and it uses this method to enable anyone to essentially talk to a blockchain, so to send a transaction or to query the state. And tomorrow, this same protocol will be able to enable adjacent open data sources as well as even non-blockchain data sources too. And one of the more interesting things about Pocket is that we enable this service through a network of over 15,000 nodes distributed across over 22 countries. And despite starting off with close to no growth, similar to many projects, we've evolved over time and developed some interesting strategies that we'd like to talk to you about today. So today we're going to talk about some of the key problems that face pretty much all major crypto networks. We'll introduce the idea of deep-in. What is that? Give you some background, as well as to introduce the growth strategy that we've been pioneering at Pocket Network that we feel is dramatically underutilized and is potentially incredibly valuable to the space. And then we'll also talk about a few practical tips and tricks and things to think about if you want to implement this strategy for your own project. So first off, yes, walking the corridors of ETH Denver or the streets of Denver, you can feel the exuberance and the excitement, but, you know, come on, we're not just there yet. So let's not get too excited, and it's important to realize that we've got a lot to do if we really want to reach that promised land and achieve the global adoption that I think we all believe we can really get to. So here's some of the 3 high-level problems that we see across the space. First off, I don't need to labor this too much, but if you're really going to use a blockchain and go through all that pain, make sure you have a really good use case for it and don't just slap it on for the sake of it. And this slide is quite a nuanced one, but really it's pointing out the fact that while you may not agree with the rules of the game that a centralized platform gives to you, as well as how you interact with it, ultimately it's often very transparent and you know what you're getting. On the other hand, once you get into the funny, uncanny valley of decentralization theater or projects that don't know if they're fully centralized or decentralized, often end users can end up worse off than they would be if the project was fully centralized in the first place. So this is something that builders need to be really thoughtful about when and where they use decentralization in their system. And yeah, I guess this slide speaks to what we want to talk about today and where is all that growth? Despite all the billions of capital, the amazing innovation and talent, we haven't quite seen all that growth just yet, at least on a sustainable basis. And before I go into talk about deep-in and what that is, it's helpful to go back 10 years to 2014 and an incredible article published in the Harvard Business Review that was titled Understanding New Power, written by Jeremy Hamans and Henry Timms. And this essay described how the internet was accelerating a cultural and behavioral shift away from an era of passive consumption to a new age of active participation. And ultimately, this is talking about harnessing the power of the crowd. And the two biggest examples used in this essay were the early rise of Airbnb and Uber as these new networked marketplaces that were leaning into more open and collaborative ways of working to unlock value in ways that simply wasn't achievable before. And 10 years later, in 2024, I think the concept of new power has never been more relevant. However, I think it's now clear to most, at least in this space, that a blockchain is necessary to unlock the true value that new power discusses. And really, this is where DeepIn enters the space. So, what is DeepIn? If I was to ask 10 different DeepIn founders or builders, I would 100% get 10 different answers. And you can look at this sector map and see the many different services that DeepIns are looking to tackle and improve. However, the easiest and simplest definition comes from Sal from EV3, which is simply that DeepIns are community-powered infrastructure. They harness the power of the crowd to reimagine and improve centralized digital services in ways that simply aren't possible without leveraging a blockchain. So to bring it all back to those three very simple and high-level problems I put at the start of my presentation, when you look at a DeepIn project, does a blockchain fix this? And this is a resounding yes. Without a blockchain, it simply isn't possible to achieve the cost and scale benefits that a DeepIn can provide. A blockchain-powered protocol can really efficiently and effectively match supply and demand by disintermediating all of that middle layer of middlemen and contracts and KYC, and also handling all those payments to the supply side and from the demand side in a really programmatic and autonomous way. So that achieves major cost and scale benefits, and additionally, a decentralized network is by definition more resilient than a centralized single point of failure that traditional businesses are. And again, this is a much more nuanced question, and clearly we need decentralization to unlock those cost and scale benefits enabled by a blockchain in terms of the on-chain settlement and the resilience factors, as well as arguably ownership. However, when it comes to crowdsourced CapEx, clearly Airbnb and Uber and other major platforms in Web 2 have achieved major scale by tapping into the crowd. So clearly they've done this through availing of pools of private and public capital. I think it's arguable that using a blockchain and token incentives, we can do this more efficiently and effectively, but this remains an open question on how to do this best. And additionally, on the innovation front, I think many here would argue that token-powered open source ecosystems can actually combine intrinsic and extrinsic incentives in a really unique and powerful way. However, there are very many powerful and productive open source communities already, and I think we've got a lot to learn from them in this space too. And again, problem number 3. So have DeepIns have a golden solution to where all the growth is? Clearly the answer is not yet. Despite all the talent and funding and building to date, the levels of revenue and impact doesn't hit the mark for where we all want to be as a space. Yeah, at least. So all of this preamble is to really get to the point where we are at DeepIn, and we're here climbing the hill, staring at a big climb ahead of us and a big chasm to jump across. And it's no surprise that there is so much problems with achieving the growth and getting to mainstream adoption when you think about all the problems that a DeepIn project has to get through. You have to build out the protocol and the tooling, coordinate and onboard a supply side, enable a community that's productive and impactful, You need to avail of the capital to build out your project and likely to overcome the cold start problem to build up and bootstrap your supply side. And then you need to be super thoughtful about who the stakeholders are in your protocol and how they should be represented and ultimately have some governance and representation. And then demand is multifaceted, right? You need world-class BD, super targeted and thoughtful marketing, fantastic customer support, and most end users need much more than a basic service. They often typically need value-added features too. And if you're not moving and adapting, you're going to die. So standing still is not an option. You ultimately need to move quickly and evolve as a project. And this leads into the first innovation and common, I guess, solution to much of the growth problems we see across the DeepIn space, and that is the realization that decentralization by itself does not sell. You need to abstract away that painful UX layer of dealing with the protocol to make it much easier for people to interact with it. And gateways are typically centralized interfaces, often built by the core team, that abstract away the protocol and make it much more easy to interact with. And so you can think about gateways from an end user perspective as a way to get a trad SaaS-like experience. So you can avail of account management, potentially value-added features, tailored customer support, and all of the things that you'd expect if you were to use a Web 2-like competitor. So this is, again, helping DeepIn projects achieve parity with their centralized competitors. And I guess to many, particularly in this space, the idea of using any kind of centralization is almost seen as an absolute no. However, as I discussed a few slides before about the benefits of DeepIns in terms of the cost, the scale, the resilience, and even the ownership, that's all really enabled by the core decentralized blockchain and protocol layer. However, when you get to the end user interfaces, actually the need to move quicker, the operational efficiency and speed often overcome the benefits you get from decentralization. So it's important to not think this is all a one-size-fits-all approach. And this is where the DeepIn mullet comes in. And for us, I guess, the way we think about the DeepIn mullet is this is sort of like a have your cake and eat it approach. So often there's that tension between centralization and decentralization, and often the question of whether you can have a token or an equity business. And actually, thanks to an incentivized blockchain protocol, we can actually separate out these concerns. And actually, we can enable token and equity business models to run in parallel without causing any unmanageable conflicts or even any unsustainable overheads. And I guess the foundations of the DeepIn mullet come from the three principles of pragmatism, minimalism, and co-opetition. So the pragmatic ideal is that decentralization does not sell, so you need a convenience layer. Once you realize that, the principle of minimalism comes into place, which is that focus or a lack of focus is often the death of most businesses. So if you really want to achieve the best results, you should not try to do everything yourself. And that leads to the understanding that you need to partner and bring in others to bring in all the benefits that gateways can provide. However, and this is where most DeepIn projects are today, with one or two gateways in your ecosystem, actually you've created other single points of failure. And actually you're failing to achieve the true levels of innovation that competition on a dynamic ecosystem can enable. And so this is the co-opetition ideal, where if you can foster a dynamic culture of collaboration while also putting in the right economic incentives and opportunities for a really competitive ecosystem on the demand layer, you can bring all these benefits. And additional benefits, if you're successful in achieving this, come from so much less redundancy in the ecosystem. Instead of every single new storage, RPC, or bandwidth project having to build out the same back-end infrastructure and also coordinate and incentivize the same supply side infrastructure or bring that in-house, you can actually build on that same base layer infrastructure. So this lowers startup costs, meaning that you need to charge less margin and ideally need less profits or revenue to get to profitability. So this is incredible for entrepreneurialism and ultimately growing out these markets. And once you have teams that can focus on their end users, they can look to innovate on providing value-added features, move a lot quicker, and adapt to the needs of their local markets and regions. So this all sounds well and good. However, to really achieve and adopt the deep-in mullet, you need to sort out some things in the back or the decentralized protocol end first. And really, like everything, it starts with your culture, your mission, your vision, your values. And because no matter what your technology or your code may say, the social contract is the layer zero. And if you're going to be able to convince businesses to offload some or all of their back-end infrastructure to your protocol, they're going to need to feel welcome. They're going to need to feel like they can trust you, and why. And part of this comes from how you think about representing these stakeholders in your ecosystem. Will their voice be heard? Does it have weight? And the more likely this is the case, the less likely they are to exit. And this is actually one of the strongest moats in open source and blockchain today. And lastly, if you can really succeed in enabling that culture of collaboration, this can compound over time and achieve incredible benefits that I think is what we all want to see from the communities that we're building and are participating in. So again, this is pretty much what it says on the tin. I think we're all excited by the amazing blank canvas that the crypto world brings for these incredible crypto economic experiments. However, while you may speak to someone who perhaps is a degen in the streets, if they build a business of any kind of scale, they're going to have someone on their team who is a neat freak in the spreadsheets. So if you really want to bring these businesses onto your platform and to use your protocol, they're going to need some clarity around your costs, how predictable this is, and have incredible user experience and transparency around the risks involved for them to build on your protocol. And again, this is pretty straightforward stuff, but it's really important not to overpromise and overdeliver. You can help people test on your protocol, prime them about the benefits of building on your protocol. However, it's important not to overstate the benefits of working with you, and think about that timing. It doesn't need to be perfect, but it does need to be good enough. And the key dimensions here are typically reliability and performance, but ultimately it also needs to be super easy to integrate and maintain this gateway integration and adapt it to their needs too. So to bring this all together, if you are able to bring in more gateways into your ecosystem, this can not only enable more collaboration on your base layer, so feeding back into your protocol to drive better quality of service and reliability, this can also bring more demand. With more protocol revenue, this can incentivize more suppliers to join your network, raising the standards for everyone, and again, feeding into that flywheel and driving more and higher, better quality of service and reliability for everyone. So to close off, the deep-in mullet is a synergistic mechanism that leans into all available business models for an ecosystem without creating unmanageable conflicts or an unsustainable overhead. And it's built on the foundations of the three principles of pragmatism, decentralization does not sell, it's convenience that expands markets, minimalism, knowing that if you try to do everything yourself, you're very unlikely to succeed, and whatever you do succeed in is unlikely to be that good in the first place. And lastly, the true success comes from being able to foster that healthy and dynamic collaboration and competition dynamic at your demand layer. Thank you all, and look forward to taking any questions if you have any time.
Hi, I just wanted to ask, since you mentioned that not everything needed to be a blockchain, and the mullet was specifying that in the back you will have this decentralized physical infrastructure, but at the front you're going to have sort of a centralized experience. But in the last wheel, you present that maybe you will need more gateways. You mean a decentralized system of gateways, or a gateway that comes from the community? Like, what exactly did you mean by that?
So I guess more gateways, I mean more businesses building on your protocol. And so today, if you look at most decentralized infrastructure protocols, they typically have an option to connect directly to the protocol, and that was the initial thinking with most of these storage bandwidth protocols, that if you really want access to this decentralized service, you would connect directly. However, nobody really wants that. So almost every protocol has built one gateway. However, the thesis of this gateway ecosystem and the deep-in mullet is that you need to foster many, like tens, if not hundreds, of these businesses to build on top. And so they may look like a 1 or 2 person team. And I guess in Pocket's case, today we have 3 gateways. So they are 3 different RPC businesses. However, of the next 3 we're planning to onboard, 1 is an existing RPC business, but the next 2 are actually major developer communities that currently don't run any RPC, realize they have a really strong brand and ultimately a distribution channel they can tap into. So actually by building an RPC business on top of the protocol, we provide the infrastructure, and they can provide essentially the network and the sales process. Does that answer your question?
Round of applause for Dermot, everybody. Thank you. We'll jump back right into a quick intermission, a couple minutes here, and then we'll get on going with our next presentation. And it's a duo, so it's going to be a good one. We're back live at the Trident stage at ETH Denver. Next up, we have a little bit different. We got two lovely speakers here to talk about public goods, open source, and DAO governance. I'd like to introduce Daniela and Alex. Take it away.
Thank you, everyone. Hi, I'm Jenny. I'm Blockful PMM. And today I'm going to talk about open source, public goods, DAO governance, and yeah, present yourself. So I can.
I'm Alex, founding member of Blockful, today developer, executive director, and yeah, happy to chat with you about what we've been doing, and yeah, take it off, Danny.
Yeah, thank you. Yeah, so let's talk about public goods first. What is public goods? First of all, we need to talk about the non-excludable and non-rival characteristic of the public goods, such as sunset, common knowledge, or laws. I could dive into all these topics, but I think we don't have enough time to do it. So think about that, like public goods, non-rival, non-excludable, and companies don't like to build public goods because they think that public goods, there's no rewards. They don't deliver rewards because they are not getting profit of it or direct profit. But this is not true because think about build a company without laws, without those public goods. It can be tough. If you are building DAOs, you can see that it's very, very difficult to build a DAO without without regulation, and so it's not true that companies don't get any benefits from public goods. Mainly when it comes to Web3, because this ecosystem is built for communities and individuals. So if you're doing a public goods, if you're building a public goods in this ecosystem, probably you're going to get any benefit in a long term. And I have some examples very soon. And companies don't like to do it because they are afraid of the free riders. So people that are not paying for that public good but are using it, getting profit from this public good. But we have the Pareto efficiency. In this ecosystem, it's very nice to talk about Pareto efficiency because it means that you can get benefit from the public good, but other people will not get any benefit, but nobody will lose. So there is a public good, you can benefit from it, I cannot, but I'm not losing anything. And let's not forget about the utility theory. All the public goods are endorsed by the utility theory, which means that if there is a public good, if people are using that, it means that we are providing utility. So if a DAO is building a public good, people are using it, it's another utility field for that DAO. Here I put some brief explanation about the utility theory. So based its belief upon individuals' preference, it is a theory postulated in economics to explain behavior of individuals based on the premise people can consistently rank orders their choice depending upon their preferences. It's a brief explanation. So, but how does private companies benefit from public goods? As I said before, imagine build a company without laws or without public transportation. So it's not direct, but the companies get benefit from that. So DAOs have a lot to benefit as well, mainly because it comes more direct when we're talking about this ecosystem built for individuals, built for communities. So think about Optimism, for example. Optimism is doing very, very well building public goods and financing public goods. And I can talk about the Season 5, for example. They are providing money for people to build, for example, ZK, private voting, and they are going to do, they're going to finance these public goods. They're going to use that, but they are not only using that, they are not only financing this tool for them, they are also enhancing all this ecosystem, all the Web3 through that, which is amazing. So we are connecting the wires of the ecosystem. So Optimism is doing that. They are helping the ecosystem, and probably they will participate in a better ecosystem in the long term. Well, so final words from my side. This isn't just about enhancing governance tool only, it's about fostering active participation from the whole ecosystem, enabling more decentralized, resilient governance from the project start. But now Alex has a great explanation. He will explain. He'll do a very nice explanation through math. Go ahead.
Okay, now it's better. Yeah, I'm a bit nerdy, so I like to explain things using math. And first, let's begin with an interesting question. So what's the social valuation of a company? What I mean by that is every company has a financial valuation, but, well, companies are made by people, and the market have tendencies. Financial valuation, you have like tendencies, but there is a floor price when you talk about people, because brilliant people are like rarely brilliant people, they stay brilliant, and if you have the ideal environment for that and the ideal tools for making these people to organize, then you have like a floor price of this organization that's like social. It's not about financial. So I was jamming a bit around math and trying to express this idea of how we get into this social valuation of the company. Well, the first aspect is people. So this part of the equation, it's kind of like the sum of people. The second part is about how these people interact. So in Sarnoff law, we have a centralized organization. It's like top-down. And the second, that is the Metcalfe law. It's more common to know about it. So it's more like peer-to-peer network. And then you have Reed law. Reed law is it fits more the organization ecosystem, because in larger organization you have like subgroups, and Reed law is not just describing the communication and interaction between peers, between persons, is also describing the interaction between persons inside this groups and groups, and it's more complex than just peer-to-peer. So because of that, when I expressed efficiency of coordination, that's expressed in 2n, also like the exponentiation term. So the more people you have, the more like it's harder to coordinate, right? And then the third aspect of the social valuation of an organization is the value generation for society. So that's interesting. Well, if you have a team of brilliant people and they know how to coordinate, but this idea doesn't like solve something big for humanity, or like is not something that people will use and well, generate value for the society, then perhaps the social valuation of the company isn't so high. And the idea here is expressing this through the formula in a multiplication way. So you have here, infinity times 0 is 0, because it's about the social impact that this organization is having. Well, now let's describe better efficiency. You have tools, so that's the way people organize, or like the tools they use for organize themselves, perhaps governance tooling, perhaps Notion could be one example. The second one is clarity of the mission, so everyone having a clear direction of what to execute and where are we going, that's really important. And protocols, cultures, and routine. That's really important for like making sure we are on this mission, on this execution in the right way. Well, C and P are parameters we cannot control from outside. It's something that's unique for each organization. But tools, it's something that you can use what's around. You can use public goods. You can use open source. So tools are the only parameter where you can leverage from what other organizations build. Better tools, especially for DAOs, means lowering the entry barrier for creating new organizations and more efficiency and productivity. So, yeah, having better tools means having also like a higher market cap of like new organizations, and then you can start creating being more creative for people. It's easier for people to spin up their organizations. Here is a quick example. So down here you can see the infrastructure. Oh, by the way, I hope my mom don't see the presentation because my letter is really bad. So in the lower part, you have infrastructure tooling for organizations. When you're building that, all organizations above this are benefiting from these tools. And then you also have specific tooling inside those organizations. For example, in ENS, if we build a public good for ENS, perhaps it's not benefiting Balancer or Optimism, but it's leveraging the organizations that are above this ecosystem. So I will divide this public goods in two ways. More in our perspective. One is for all digital organizations, and then you have the specific tooling. And there is something really beautiful happening here because, well, the infrastructure layer is helping the layer above, that is helping the layer above, and perhaps taking again the example on ENS, Rainbow, Namehash, Namestone, 3DNS, these guys will all also build public goods that can benefit the ecosystem itself. So it's pretty cool to see this, and that's only possible because of open source. That's a really important part of it. So that's our invite. Build on public goods. Yeah.
Yeah, I don't know if you guys have any questions. So if yes, raise your hand. If not, just clap your hands again. It's okay. Thank you. Don't forget to build in public goods. Yeah. Bye.
Another round of applause for Danielle and Alex. Thank you so, so much. We love public goods.
Oh, yes. Thank you.
Awesome. So we've got a little bit of time here, so we're going to go on a little bit more of an extended break than usual, I think. AV team, am I correct? Yeah, they're loving it. This is break time. Watch out, they might get some snacks in. Cool. I'll see y'all in a bit. Enjoy the ads. And we're back. Welcome, ETH Denver, to the Trident stage. It's Friday. The day's nearing an end, and got my next speaker coming up. I seem to have forgotten my hat, although my next guest, Spencer from Hats Protocol, definitely hasn't. So everybody, please give a warm welcome to Spencer from Hats. Got it. You got it, Mike.
All right. Hello, everybody. Thank you for coming. I know there's a ton going on right now, so it means a lot to me that you're all here. My name is Spencer Graham. I am a co-founder and protocol lead at Hats Protocol. And today I'm going to talk about, shockingly, DAOs. And what I'm going to focus on primarily is what I've been more recently calling full spectrum rule enforcement, and why that is critical to enabling DAOs to fulfill their promise of becoming the best organizations that have ever existed. I think DAOs will win because they are able to enforce their rules with both what I'm calling constraint-based enforcement and accountability-based enforcement. And we'll get into that in a little bit. But first, we're going to take a very, very brief tour through a framework that I developed over the last few years that comes from an article that I wrote just a couple of years ago that has informed a lot of the ways that I think about DAOs and governance and how we should go about making them better. And that framework is called anti-capture. And anti-capture begins with first principles. And those first principles are resources. Really everything that you can think about is a resource in some way. Some of those resources are private. And what I mean by that is those resources are held or controlled or owned by a single individual person. But other resources are shared, which means they are held or controlled or owned by more than one person. 2 people, 3 people, 10 people, 10,000 people, 7 billion people, as many as you can imagine, can share a resource. And that distinction between private and shared resources is critical for our point today. Resources, though, are only valuable, they're only useful if you use them. They're only important, they're only valuable if you can take actions with or on them. And this is really the core of anti-capture. It focuses on actions and the different phases of how actions are taken by either individual people or groups of people. And there's a lot more detail in the framework, but for the purposes of today, what's important is that the different phases have different vulnerabilities to what I've been calling capture. There's also a trade-off between the ability to resist capture and actually execute actions. And it's the execution phase of actions that is really critical to ensuring strong security and strong properties of those resources. If you're interested in seeing more about anti-capture and the framework, this QR code will take you to that article, and I encourage you to take a look at that. Resources brings us to organizations, especially shared resources. So my claim, which might be a little bit surprising, is that really this is all an organization is. An organization is a network of agents, a group of people with some kind of collective or shared goals, and with resources that they share. And that the organization takes actions on or with those shared resources in order to achieve those goals. In some sense, this describes every organization across all time forever. But it's a simple idea, but I think it captures the essence of what organizations are. And this is also what we call governance, which is the process of taking collective action on or with shared resources to achieve common goals. governance has two primary objectives. In an organization, governance is attempting to use its shared resources as effectively and efficiently as possible in order to achieve its goals. And we can call this effectiveness broadly. It also is trying to make sure that those shared resources are only used for achieving the organization's shared goals, that they are not captured and repurposed for some other objectives or for some other entities. And that we call capture resistance. And there's a fundamental trade-off between effectiveness and capture resistance. At least to date, across all time in history, there has been. And that is, back to actions, the only way to use resources is to execute actions with them. But in the process of executing actions, you make those resources vulnerable to capture. So how do we be effective, do things we want to do, achieve the goals we want to achieve, while making sure that the resources don't get diverted to some other purpose, that they don't get captured? So how do organizations do this? I contend, or I'm sort of introducing a narrow definition of the concept of rules, which means, and the definition of rules is that they are the means by which organizations resist capture. They are the processes, the guidelines, the rules that organizations put into place to prevent capture of their resources while those resources are being used, while actions are being taken with their resources. So any good lawyer will tell you that rules aren't good for anything. They're only rules if they can be enforced. How can rules be enforced? I think that there are two primary buckets or types of ways to enforce rules. One way, which is on the left of this spectrum, is what I've been calling constraints. Constraints are by their nature preventative. They are like physics. Constraint rules are unbreakable. You cannot break the laws of physics. You cannot, for all you might want to, you cannot break those rules. Recently, we've been able to introduce new types of constraints with cryptography and more recently with cryptoeconomics via blockchains and smart contracts. New types of physics that allow us to make unbreakable rules with respect to our organization's shared resources. On the other side of the spectrum, we have what I've been calling roughly accountability. Accountability-based enforcement or accountability-based rules are retroactive by nature. They are incentives, they are penalties, they are punishments. But they also rely on multiple layers of accountability. If you reach all the way down, if you peel back all the layers of the accountability onion, what you primarily get at the end of the day is the state monopoly on violence. This is how organizations across all of history until DAOs operated. And this is a real big constraint that makes all these organizations fundamentally capturable by external actors like governments. They are susceptible to, or they are dependent upon governments for their own operations, which creates vulnerability, but it also creates a lot of inefficiency. It's very expensive. But on the other hand, accountability-based enforcement of rules is very flexible. It allows the people that are operating within the bounds of those rules to exercise their own judgment about what falls within those rules, which allows them to explore what they need to do and the actions they need to take in order to effectively achieve their organization's goals. Constraints, however, are not very flexible. Again, like any lawyer will tell you, every contract is incomplete. It is impossible to delineate all of the actions that we want to allow an agent or a person to take on behalf of an organization that is going to actually be effective, that are going to be in the realm of things that need to happen. So on one side of this spectrum, we have constraints, and on another side of the spectrum, we have accountability. So let's move into a slightly different formulation here. Let's return to this trade-off between capture resistance which is on the y-axis here, and effectiveness, which is on the x-axis. And if we model these two objectives in this way, we can borrow a tool from economics called the production possibility frontier, which allows us to describe and define and diagram the trade-offs between optimizing for one versus the other, or maybe a balance of those two. So here we can visualize the trade-offs between optimizing for capture resistance and optimizing for effectiveness. And we get this curve that represents the frontier of what we can do, the frontier of how good, how effective, how productive, how valuable, how impactful organizations can be. This is what I think traditional companies look like. They are pretty effective, generally. They've done a lot of good things, but they really sacrifice, or they don't, well, less sacrifice, more like they are not capable even of imagining what capture resistance is. They've never lived in a world where that was possible, because they only are dealing with accountability-based rule enforcement. This is what I think DAOs look like today, or over the last 5 or 6 years for their full existence. They have introduced this powerful idea of constraint-based rule enforcement, and that pushes up the frontier on the capture resistance axis. DAOs can now, relative to traditional organizations, be much more capture resistant for the same level of effectiveness, up to a point. You can see the curve for DAOs falls short of the level of effectiveness that traditional companies are able to access. And this is because they only have been able to rely on constraint-based rule enforcement. They cannot have the flexibility, the judgment, they cannot enable the judgment of their individual members to act on their behalf, because they literally cannot give them the flexibility and the extra space in which to operate. They are constrained to constraints. What would it look like if we could remove that constraint? What would it look like if we could extend the frontier of the effectiveness axis? What could DAOs look like today and into the future? I think they could look like this. I think they could be the most effective organizations that ever existed. So how can we do that? How can we make that happen? That brings us to what I've been working on with a bunch of amazing people for the last couple years, which is called HATS Protocol. HATS Protocol, or one way to think about it, is that it brings accountability-based enforcement back into the picture for organizations, back into the picture for DAOs. And it does this by using smart contracts to establish constraint-based rules to manage accountability-based enforcement of organizations' rules. It extends the frontier on the accountability axis. So how do we do this? How does HATS Protocol do this? HATS Protocol is called HATS Protocol because it enables the creation of and management of on-chain roles, or what we call HATs. This is a little bit of a preview of what HATS Protocol looks like if we visualize it. We have a bunch of roles that at first blush look like a strict hierarchy. But if we think about these as roles and not the actual people in the organization, we can understand that these are the relationships between the roles, between the work that needs to be done, between the actions that need to be taken to achieve the organization's goals. And we can embed a bunch of things into these roles, including authorities and responsibilities. And we can also identify who has these roles. We can manage who has these roles. And what is not pictured here is that we can also attach and program accountability criteria directly into the roles themselves. And that includes things like token holdings or reputation or elections, or perhaps most importantly, staking. Staking to get a role is maybe the ultimate accountability mechanism, because you can be slashed if you don't follow the rules. It gives you the flexibility to operate within a space that the DAO creates for you, and take the actions with the DAO's shared resources that you think you need to take in order to best achieve the organization's goals. And it still gives the organization the ability to slash you, to penalize you, to punish you for breaking those rules if it judges that you've gone awry, that you've gone MIA, that you've gone rogue. So back to this concept of roles. HATs are programmable on-chain roles. We think they are the atomic unit of organizational structure. They are also a pure abstraction. Their great power comes from the fact that they are almost nothing in a sense. We practice this concept and we espouse this concept of roles, not souls, or what we really say, which is hats, not heads. We abstract away the wearers from the hats. We extract away the heads from the hats, which allows us to do amazing things with the roles themselves. And as I talked about, roles are really bundles of a bunch of different things. They are bundles of responsibilities, such as the role's purpose, its tasks, and other rules that have been established for the role. They're also bundles of powers, of authorities, of permissions, like the ability to spend money or access a communication channel or broadcast on behalf of the organization. Crucially, like I mentioned, they're also bundles of accountabilities that we can program in, as well as qualification and granting criteria and revocation criteria. And they have programmable and composable interfaces for everything that I just described. So let's take a closer look at those powers, at those permissions and authorities. Like I said before, permissions and authorities really are the ability to execute actions with or on the shared resources of an organization. These are typically delegated by the organization to the individual. And this represents both an opportunity to do great things, but also a risk of capture. And so we really need strong rules strong rules to make sure that we aren't risking capture too much. So we can either have constraint enforced authorities or accountability enforced authorities. So for example, on the constraint side, maybe you can only transfer up to 2 ETH because the smart contract says that that's the case. Or you can only set a protocol parameter within a specified range of values. Or you cannot access Telegram unless you are in the working group that the Telegram is for. On the accountability side, these are things like soft powers, like a working group facilitator, or maybe the right to cast on Farcaster, but make sure that you don't cast bad things. We can't actually prevent you from casting bad things, but what we can do is we can penalize you if you do so. That's the accountability enforcement. Taking a step back, the key point here is that almost all organizations have authorities or powers or permissions that are really important to achieving their goals, that cut across many different domains, across on-chain and off-chain, and are necessarily enforced by both constraints and differentially accountability. And so it's crucial that a roles system for an organization, in order to enable this full spectrum of rule enforcement, the roles need to cover the entire organization. They need to extend across the entire domain of the organization, across multiple domains of permissions and powers and authorities. And this is why HATS as a pure abstraction is so important. It enables those rules to cover all of those responsibilities and powers in the organization, which means that programmable accountability can be applied everywhere it's needed, in addition to all the constraint-based rules that are so important for DAOs as well. So this is why I increasingly believe that the best organizations wear hats. Thank you for coming. It's been a pleasure speaking here. And here are a couple ways that you can find both me on Twitter and Farcaster, as well as HATS protocol on Twitter and Farcaster.
And thank you, Spencer. Wow. One more round of applause, please. Hey.